Justru kami ini, kurniakan kepada kami ilmu-Mu, sinari hati-hati kami dengan cahaya dan hidayah-Mu. Semoga dengannya kami mudah menerima dan menghayati serta mengamalkannya. Allahumma ja'al hadza jamman muhuma wa tafarraqna ma'suma wa la taj'al fina wa la ma'ana sakiyan wa la matrudan wa la mahruma. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sallam. Walhamdulillahi rabbil alamin. Taqabbalallahu minkum.
Terima kasih diucapkan kepada Ustaz Muhammad Balian bin Mahmud di atas kesudian memimpin bacaan doa sebentar tadi. Yang berhormat hadirin yang dihormati sekalian, majlis pada pagi ini diteruskan lagi dengan mempersilakan yang berusaha Profesor Vishna Devi Vinadaraja, CEO Newcastle University Medicine Malaysia NUMED, selaku penganjur bersama Johor Research Day tahun 2024 untuk menyampaikan ucapan aluan. Dipersilakan.
Terima kasih. Selamat datang, salam sejahtera dan selamat pagi kepada yang berhormat Tuan Ling Tian Sun, yang berusaha Dr. Haji Mokhtar, Dr. Khairul, Dr. Marina, semua yang di sini hari ini ya. Saya nak mengalu-alukan ke semua yang ke sini, termasuk clinician, non-clinician, academics yang telah mengambil masa untuk datang ke Johor Research Day dan melawat kampus kami sini di Newcastle. Saya mengaku saya bukan anak Johor. So tadi kali pertama saya melihat lagu Johor, saya anak Pahang. So saya masih ingat dari masa sekolah kita menyanyi lagu state kita di Pahang ya. Boleh nyanyi sekarang tapi tak boleh lah ya. Okey. Tapi lepas tu saya berpindah ke KL dan bekerja di KL untuk lebih kurang 24 tahun sebelum mengambil peluang untuk di sini, datang ke sini ke Johor. Dan memang Johor ada tempat yang special untuk saya sebab bila kita budak-budak, banyak keluarga saya ahli kerajaan lah. So kita datang, dulu mana nak cuti, tak ada Air Asia kan. Tak cuti semua dalam negara kan. And kita buat trip tu Johor Bahru, tapi Johor sekarang dah berbeza ya. Lebih maju ya, lebih maju, dan memang saya rasa inilah tempat untuk kita berada sekarang. Selakunya sultan kita pun Agong kan. So this is the right time, right place. Yes. Dan juga kami di NUMED kan, walaupun Newcastle University dari UK, tapi kita sudah bertapak di sini selama 15 tahun ya. Dan fikiran dan minda dari UK ke sini ialah kami global. Ya, fikiran global tapi action kita lokal ya. Dan saya adalah CEO dan provost pertama ya, ada yang rakyat Malaysia. Sebelum ni semua dari UK ya. So inilah transition dari UK ke sini. Dan memang tim saya di sini, ada juga beberapa rakan kerja saya di sini. Kita nak bekerjasama untuk memajukan kesihatan, memajukan pendidikan tinggi, sebab we are the only university, I boleh kata, yang fully di sini ya. Sebab 5 tahun pengajaran dia di Johor. Medicine, kita ada biomedical sciences, ada foundation, dan tahun depan kita tengah mengusahakan untuk sports dan exercise science, data science dan pelbagai bidang-bidang lain. Tapi kita tak boleh membuat ni secara institusi perseorangan ya. Kita memerlukan kerjasama dari state government dan juga KKM. And I have to say ini izinkan saya cakap dalam bahasa Inggeris juga ya. I have to say, I'm very, very proud to have many graduates working in KKM as a teacher. I've been a teacher for 24 years. And I just told Dr. Mokhtar tadi, how proud we are as Malaysians. Gejala COVID ni masih ada kan? Tapi how KKM came together to support us, and also the government at that time, right? I think all Malaysians are very grateful to all of you. So I just want to say thank you so much from us orang biasa to see how KKM actually is still continuing to fight the battles on the ground. So thank you, and thank you to the state of Johor. So lepas ni saya akan saya mengalu-alukan yang bukan saja you enjoy the the whole research day, but please walk around our campus. Ni memang cantik campus ni. Ada banyak Instagrammable moments, right? So tolonglah ambilkan cakap you are at Newmat, because it's a nice place dan tempat ni untuk semua anak kami, ya. Untuk semua anak kami, ya, bukan untuk just certain people. It's for all of us. So please come and welcome to do CPD, nak buat apa-apa khusus ke apa, we are open, right? So terima kasih ya. Thank you very much.
Terima kasih diucapkan kepada Profesor Vishna Devi Bintang Darajah di atas ucapan aluan sebentar tadi. Yang berhormat dan hadirin sekalian, majlis pagi ini diteruskan lagi dengan mempersilakan Yang Berusaha Dr. Marina binti Abdul Rahman Sabri, Ketua Pusat Penyelidikan Klinikal Negeri Johor, berangkap pengerusi Jawatankuasa Kerja Johor Research Day tahun 2024 untuk memberikan ucapan. Dipersilakan.
Okey, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Minta maaflah kalau suara tak berapa jelas tapi saya ucapkan terima kasih kepada pengerusi majlis yang berhormat Tuan Ling Tian Sun sebagai pengerusi Jawatankuasa Kesihatan Alam Sekitar Negeri Johor, Yang Berusaha Datuk Haji Mokhtar bin Pungut alias Haji Ahmad merupakan pengarah kesihatan negeri Johor dan merupakan penasihat dan penaung bagi Johor Research Day. Yang Berusaha Profesor Vishna Devi Bintang Darajah, CEO Newcastle University Medicine Malaysia, Newmat, selaku penganjur bersama Johor Research Day untuk tahun 2024. Yang Berusaha Datuk Khairul Riza bin Uthman, Timbalan Pengarah Kesihatan Negeri Johor, Bahagian Perubatan. Yang Berusaha Timbalan-Timbalan Pengarah Kesihatan Negeri Johor, Ketua-Ketua Fasiliti Kesihatan Negeri Johor, Pegawai Kanan Jabatan Kesihatan Negeri Johor, dan juga dialu-alukan penceramah dan juri jemputan serta pensyarah-pensyarah universiti, juga para ilmuwan, datuk-datuk, datin-datin, tuan-tuan dan puan-puan. Okey, jadi saya dengan ini mengucapkan alhamdulillah lah kerana kita hari ini kita akhirnya dapat berkumpul dan kita telah bermula kerja kita sejak daripada awal tahun kan, kalau ingat. Dan terlebih dahulu saya mengucapkan terima kasih juga kepada Yang Berhormat Tuan Ling Tian Sun sebagai pengerusi Jawatankuasa Kesihatan Alam Sekitar Negeri Johor atas kesudian Yang Berhormat untuk menghadiri dan seterusnya merasmikan program untuk hari ini. Diucapkan terima kasih kepada Prof Vishna, kepada Newcastle University kerana, dan juga Johor Parenteral Enteral Society Japan kerana sudi berkolaborasi untuk kami pada julung-julung kalinya. Saya rasa ini adalah kali pertama kita berkolaborasi dengan orang dengan departmen lain, jabatan lain, okey, selain daripada hanya CRC sebelum ni dan juga JKNJ. Jutaan terima kasih saya ucapkan kepada CRC dan MUA sebagai urus setia Jawatankuasa Saintifik dan juga Pertandingan. Tidak dilupakan juga ahli-ahli Jawatankuasa JRD yang bertungkus lumus, okey, yang terdiri daripada 6 bahagian, iaitu Jabatan Kesihatan Negeri Johor dan juga daripada HSA. Urus setia kami yang juga terdiri daripada warga kerja Newmat yang menjadi tunjang pergerakan JRD sejak daripada awal tahun dan membantu dari segi-segi teknikal dan juga IT. Okay, dan satu kerjasama sebagai satu pasukan telah kita jayakan sejak daripada awal dan sehingga akhir ni terbukti di mana kita telah akhirnya berjaya dan hari ini telah berlangsung. Jadi sila berikan tepukan pada masing-masing. Okey. Okay, menjadi harapan dan hasrat saya agar input dan ilmu yang bakal kita perolehi pada hari ini dapat disebarkan pada semua pihak sekaligus dapat meningkatkan kecemerlangan dan produktiviti kita dalam mencapaikan perkhidmatan kesihatan yang lebih baik kepada setiap pelosok. Akhir kata, saya turut mengalu-alukan kehadiran semua yang telah mendaftar untuk datang pada hari ini bersama-sama, sama ada sebagai peserta yang bertanding atau hanya sebagai peserta umum. Jika tiada perempuan dan tuan-tuan, maka tiadalah Johor Research Day untuk 2024. Sekian, wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih diucapkan kepada Dr. Marina binti Abdul Rahman Sabri di atas ucapan beliau sebentar tadi. Hadirin sekalian, kita teruskan lagi dengan ucapan perasmian. Dengan itu, majlis mempersilakan Yang Berhormat Tuan Lim Tian Sun, Pengerusi Jawatankuasa Kesihatan dan Alam Sekitar Negeri Johor. Dipersilakan.
Okay, terima kasih pengacara majlis. So lama tak duduk dalam lecture hall ni, rasa lain sikit. Yang Berusaha Dr. Haji Mokhtar bin Bumud, Pengarah JKNJ Negeri Johor. Yang Berusaha Profesor Wisna Devi, Kerja, CEO Newmet. Yang Berusaha Dr. Khairul, Timbalan Pengarah Kesihatan Negeri Johor. Yang Berusaha Dr. Marina sebagai Ketua Pusat Penyelidik Klinikal Negeri Johor, merangkap pengurusi Jawatankuasa Kerja Johor Research Day tahun 2024. Bagi satu tepukan gemuruh kepada Dr. Marina. Hari ini susah payah dia anjurkan program ini dan saya banyak perubahan waktu. Saya minta maaf lah kerana kebetulan hari ini hari Rabu adalah hari mesyuarat kerajaan. Itu satu mesyuarat yang wajib dihadiri dan hari ini ada kertas penting daripada Jawatankuasa Kesihatan. Kalau saya tak bentang, nanti Dr. Mokhtar tak ada bajet. Boleh dibelanjakan dalam tahun ini. Dr. Mokhtar tak ada duit, nanti Dr. Sal tak ada duit. So hari ini saya kena hadirkan. Dan juga bagi semua pegawai-pegawai kanan Jabatan Kesihatan Negeri Johor, pada yang penceramah dan juri jemputan, pensyarah-pensyarah universiti dan juga para ilmuwan, datuk-datuk, datin-datin, tuan-tuan dan puan-puan yang saya kasihi sekalian. Hari ini saya berdiri dalam lecture hall Newmet. Yang depan dengan saya ni semua pakar. Mungkin ada PhD, ada master yang ada di sini. Saya nak berucap panjang lebar pun tak guna. Kerana semua ni lebih hebat, lebih handal daripada saya. Oleh itu hari ini yang pertama saya nak ucap terima kasih kepada pihak penganjur kerana sudi memberi saya peluang untuk bersama dengan tuan-tuan dan puan-puan sekalian. Dan yang kedua, saya nak mewakili Kerajaan Negeri Johor untuk mengucapkan tahniah dan syabas kepada pihak penganjur kerana sudi kerana berjaya menganjurkan satu program yang cukup bagi saya cukup bererti dan cukup penuh dengan erti dan maknanya. Kerana hari ini kita menawarkan ataupun kita mengadakan satu platform kepada penyelidik. Hari ini adalah platform anda untuk membentang kertas-kertas penyelidik anda, apa hasilnya, dan hasil itu mungkin penting bukan saja bagi anda sendiri, tetapi ia mungkin membawa satu impak yang besar bagi rakyat jelata di luar sana. Dan tajuk bagi Research Day tahun ini 2024 adalah Transforming Healthcare Through Digitalization. Dan ini sangat, apa orang kata, signifikannya untuk pada zaman ini. Dan ramai doktor-doktor di sini ataupun pakar-pakar di sini saya pernah jumpa. Dan ramai juga pernah bentang kepada saya hasil kajian mereka macam mana nak menggunakan digitalization untuk membantu healthcare sistem kita khususnya dalam negeri Johor. Dan macam mana kita nak transforming healthcare system ini supaya lebih, apa orang kata ni, bukan lebih efisien tapi efektif. Dan isu lama kita, apa orang kata ni, isu lama yang kita perlu selesaikan khususnya di klinik-klinik kerajaan. Macam mana kita nak pendekkan waktu menunggu bagi pesakit yang mungkin lama duduk di kawasan ruang menunggu. Mungkin salah satu kaedahnya kita nak menggunakan digitalization untuk kurangkan waktu menunggu mereka. Dan bukan begitu saja. Sudah lama kita bincang tentang isu hospital information system. Tetapi malangnya sehingga hari ini kita masih lagi boleh, apa orang kata ni, zaman hari ini saya tengok pekerja di HSA ni masih kesian. Perlu merekod segala rekodnya secara manual, perlu kerja ke sini, perlu kerja ke sini, kerja ke sana untuk mengambil rekod secara manual. Mungkin inilah masanya kita nak buat satu kajian yang lebih mendalam macam mana nak membantu khususnya kementerian dengan menggunakan teknologi yang ada pada hari ini bukan saja efisien tetapi juga efektif. Yang penting bagi wakil KKM, yang paling penting cost efektif. Macam mana kita nak bantu sistem kesihatan kita supaya mencapai matlamat mereka. Dan bukan begitu saja. Sebagai wakil kerajaan negeri Johor, kami nak membantu hospital yang paling sibuk, paling besar dalam negeri Johor, iaitu HSA. Nak mengurangkan waktu menunggu. Nah, supaya apa orang kata ni, perkhidmatan kesihatan yang lebih efektif, kerajaan negeri sanggup memperuntukkan tahun ini saja tidak kurang daripada 7 juta ringgit daripada kerajaan negeri untuk bantu Jabatan Kesihatan Negeri Johor dalam pelbagai program. Salah satunya kita akan membekalkan HSA, satu smart queue system. Ini salah satu inisiatif daripada kerajaan negeri Johor. Dan mudah-mudahan mungkin nanti ada 109 research paper akan dibentangkan. Betul, kalau tak silap saya. 109 paper akan dibentangkan. Mungkin di antaranya ada cadangan yang lebih baik. Yang penting cost efektif dia. Kalau mampu, kerajaan negeri Johor bersedia untuk bersama dengan para penyelidik ataupun dengan pakar-pakar kesihatan dalam negeri kita supaya kita dapat membantu memberi banyak manfaat lagi kepada bangsa Johor. Itu yang penting. Pada CEO Newmac, we welcome you to be our Johorian. Bangsa Johor welcome you, don't worry. Okay? So sekali lagi saya nak ucap terima kasih kepada para hadirin dan hadirat sekalian. Saya dengan sukacitanya merasmikan Johor Research Day 2024. Sekian, terima kasih.
Terima kasih diucapkan kepada Yang Berhormat Tuan Lim Tian Soon, Pengerusi Jabatan Kuasa Kesihatan dan Alam Sekitar Negeri Johor. Yang berhormat dan hadirin sekalian, marilah sama-sama kita saksikan montaj. Hadirin sekalian, majlis pada pagi ini diteruskan lagi dengan mempersilakan Yang Berhormat Tuan Lim Tian Soon diiringi oleh Dr. Haji Mokhtar bin Pungut Elais Haji Ahmad dan Profesor Vishna Dewi Bina Daraja untuk penyampaian hadiah Piala Pusingan. Dipersilakan. Hadirin sekalian, penyampaian Piala Pusingan Johor Research Day 2024 merupakan cetusan idea oleh Pengarah Kesihatan Negeri Johor, merupakan elemen surprise bagi sambutan Johor Research Day tahun 2024. Bertujuan bagi meraihkan PTJ yang menyokong sambutan Johor Research Day dengan penghantaran abstrak yang tertinggi. Piala Pusingan ini akan dijadikan satu tradisi bagi sambutan JRD dengan menggalakkan anggota kesihatan menjalankan penyelidikan dan menggalakkan penyertaan research di masa akan datang. Hadirin sekalian, berikan tepukan yang gemuruh kepada penerima. Dipersilakan Hospital Sultanah Nora Ismail Batu Pahat. Tahniah diucapkan kepada Hospital Sultanah Nora Ismail Batu Pahat. Terima kasih diucapkan kepada Yang Berhormat dan para tetamu. Dipersilakan kembali kepada tempat duduk. Baiklah hadirin, kita minta tuan-tuan dan puan-puan yang berada di kanan dan juga kiri untuk memenuhkan ruang tempat duduk di tengah ini untuk kita sesi bergambar. Boleh berdiri pun boleh. Untuk rapatkan Di depan ni pun boleh duduk depan.
Video macam apa? Boleh?
Club isn't the best place to find the lovers, at the bar is where I go. Me and my friends at the table doing shots, tripping fast, and we talk slow. Come over and start up a conversation with just me, and trust me, I'll give it a chance. Now take my hand, stop, and the man on the jukebox, and then we start to dance. And now I'm singing like, girl, you know I want your love. Your love was handmade for somebody like me. Come on now, follow my lead. Me crazy, don't mind me saying, boy, let's not talk too much. Up on my waist and put that body on me. Come on now, follow my lead. Come on now, follow my lead. I'm in love with the shape of you. Push and pull like a magnet do. My heart is falling too. I'm in love with your body. Last night you were in my room. Video sheet smell like you. Every discovering something brand new. I'm in love with your body. I'm in love with your body. I'm in love with your body. Every day discovering something brand new. I'm in love with the shape of everything. We let the story begin. We're going out on our first date. But you and me are thrifty, so go you can. I gotta feel like a play. We talk for hours and hours about the sweet and the sour and how your family's doing okay. In the taxi, it's in the backseat of the driver, make the radio play. I'm singing like, girl, you know I want your love, somebody like me. Come on now, follow my lead. I may be crazy, don't mind me. Say, boy, let's not talk too much. Grab on my waist and put that body on me. Come on now, follow my lead. Come on now. Push and pull like a magnet. My heart is falling too. I'm in love with your body. It's like you were in my room. My bed sheets smell like you. Every day discovering something brand new. I'm in love with your body.
Hadirin sekalian, berikan tepukan yang gemuruh kepada Yang Berhormat Tuan Lim Tian Sun di atas kesudian hadir pada pagi ini ke Majlis Perasmian Johor Research Day 2024. Maka dengan itu berakhirlah majlis perasmian. Dipohon Yang Berhormat dan juga para tetamu untuk menikmati jamuan pagi yang telah disediakan. Dengan itu saya sudahi, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
My baby.
of the Institute Research Center of the National Institute of Health, Ministry of Health. ICR is a clinical research arm of the MOH and has a network of 37 scientists in the health system, group program in the Department of Global Health and Population at the Harvard T.H. Chan School of Public Health. Her area of research interest in healthcare survey, healthcare system, clinical epidemiology, and to date, she has coordinated 5 national healthcare statistics, and which has considered as the most important data collection effort in the Malaysia, involving both hospital and primary care provider. And during the COVID-19 pandemic, her team has embarked on the research involving the COVID-19 vaccine surveillance, and she is currently the president of the Association of Clinical Research Malaysia. And let's welcome her to deliver her speech on the enhancing investigator-initiated research in Malaysia.
Very good morning to everyone. I would like to convey my apologies for not being able to be there physically to give this presentation, but due to some unforeseen circumstances, I have to return back to NIH. With that, I would like to thank the MC for his kind introduction, and let me proceed with the presentation today. The title of my presentation is Enhancing Investigator-Initiated Research. The outline of today's presentation. This is the contents for today's presentation. I'll give a brief introduction as I'm quite certain that many of you all are not familiar with the National Institutes of Health. I will then proceed to have a brief introduction of the Institute of Clinical Research and its networks, and then moving on to ICR's journey in investigator-initiated research, sharing with you some examples, and then sharing with you some recent development in WHO about the resolution, and also our recent workshop with the Western Pacific region. So let me move on. The National Institutes of Health, or NIH, is its common. Commonly known, is situated now in Setia Alam. The oldest institute is actually the Institute of Medical Research. It's 124 years old. followed by the Institute of Public Health that actually produces all the NHMS surveys. I'm sure you're very familiar of the NHMS findings. I'm happy to report the Institute of Clinical Research, or previously known as CRC, it was established in 1998, but was operational only in the year 2000. The Institute of Health Management, which conducts a lot of our training and organizes the technical working group for training, is the fourth oldest institute, then followed by the Institute of Health Systems Research, and finally the youngest being the Institute of Behavioral Research. So all these four institutes now are based in Satya Alam, where I am actually going to make my move on Wednesday morning. Now, a bit of the Institutes of Clinical Research. The headquarters is actually located in Satya Alam. We have actually four centers and 2 units. The 4 centers, namely being the Center for Clinical Epidemiology, the Center for Clinical Outcome Research, which I was heading previously, the Center for Clinical Trial, which has the first in human ward, the Center for Coordination of Research, CCRN, and the Digital Health Research Innovation Unit, and not to forget the Strategic Governance and Management Unit. As I mentioned earlier, we have 37 hospitals. They're all located in all our tertiary and major hospitals, starting off right from Perlis, going up right down to the south, even embracing East Coast. And we have our ICRs or CRCs that are situated both in Sabah, Sarawak. As the southern region, we have 4 CRCs in Johor, the oldest being HSA, followed then by HSI, and then we have a CRC in War. Sorry, I need to correct myself. It's actually 3 CRCs in Johor. Yeah. Okay. Besides the establishment of our clinical research centers, what I'm proud to inform you all is we have the 2 first in human trial centers. The oldest being Hospital Ampang, and the later addition being Hospital Umum Sarawak. Hospital Umum Sarawak has already received its full accreditation. Hospital Ampang is on its way to hopefully getting its full accreditation very soon. So this is what CRC is about, and the strengths of our CRCs are our networks. A little bit about ICR's journey in investigator-initiated research. We started our journey, as I mentioned, in the year 2000. ICR was instrumental in establishing the clinical registries in the Ministry of Health. At one time, there were 35 disease-based registries based in the Malaysian Medical Association. Today, there's only about 10 or slightly more clinical registries that are still running. As we move on, what I'm proud to inform you, it was this initiative called the National Health Statistics Initiative that Dr. Lim Teck On, who was then the director, initiated, and I'm proud to say that I was part of this journey. This initiative managed to establish the healthcare systems surveys, which were the first national healthcare system surveys for the Ministry of Health and Malaysia. And we move on in the year 2012, we got involved in a study called the Action Study, which I will not be informing the details. And in 2015, we know that we've had a lot of healthcare reforms. And because of our initial work in the National Health Statistics Initiative, we were then, the Institute of Clinical Research, engaged heavily in the Malaysian Health Systems Research. This was a collaborative effort between the Ministry of Health and Harvard School in Boston. As we move on, I will be sharing with you our experiences, and this is a very important study, which is called the Remdesivir trial, which actually was conceived in 2016, and as we speak, it is still ongoing. I'll share with you some of how we initiated the study, and finally, we were heavily involved during the COVID pandemic, leading numerous investigator-initiated research, and we were also involved in WHO Solidarity Trial, and I will be sharing one of our very famous initiatives as I go on. So let me walk you through a bit about the Remdesivir. It was from phase 1 trial to clinical practice. It is one of the most innovative and investigator-initiated trials that Malaysia has partaken in. What actually transpired is this was developed through the Union. It was the first South-South collaboration between Malaysia, Thailand, and Egypt. We partnered with NGOs, especially with the Drug for Neglected Diseases, or more commonly known as DNDi, and Medical Science Frontier. As we are aware, many of these original patent drugs are very expensive. And our top leaders realized that we needed to make these drugs more accessible. And in this case, it's the treatment of hepatitis C. Remdesivir is a direct-acting antiviral and to treat hepatitis C. And what we did is we actually managed to develop a generic drug and combine it with sofosbuvir to treat hepatitis B in 12 weeks. As a result of this initiative, and ICR, Ministry of Health, together with Thailand, went through various stages from phase 2 onwards to phase 3. And we are now, we have just come up with the results of our phase 3B study. So a bit about remdesivir. Malaysia became the first country to grant conditional approval for this drug. We went on to actually announce full registration in the early of this year by NPRA. The interesting milestone is that we have actually managed to make this drug more affordable. Previously, it cost around 200,000 Malaysian dollars to treat one hepatitis C, and now it costs less than 1/10 of that. To date, we have actually managed to treat 70,000 patients in 2022, and this is a remarkable feat for an upper middle income country. I've just shared with you the experiences of how we started in dabbling in investigator-initiated trials. Let me move to something that is very close to my heart, involvement in the real-world evaluation of COVID-19 vaccines under the Malaysian National COVID-19 Immunization Program, or more commonly known as PIC. During the COVID pandemic, we realized that we were unable to secure the more expensive mRNA, and we had a plethora of vaccines being offered and landed on our shores. So what the team in the Center for Clinical Outcome Research did was that we decided to evaluate the vaccine effectiveness of our various vaccines that were being introduced in our armamentarium. The interesting approach, which I consider a very novel approach, is we actually then were able to link various platforms. I think I just want to walk you quickly through how the data was actually being captured in various databases. I'm sure you would have realized that from the manufacturing onwards, right up to the storage, all this was being captured in a telematic business network. Many of you all, I think most of you all would have received at least the primary vaccines. You remember the MySejahtera, you remember the appointments, all this was actually being captured on a vaccine management system. And if we move down, in the beginning stages in 2020 onwards, we had an e-COVID notification system. So whoever tested positive would then have to notify whether through in your MySejahtera or into this e-COVID, it would link then to the e-COVID system. And then this would capture those who were infected. The MyBus that we all remember captured all these demographics of the patients and when you received the vaccines. And what we went on to do is then we went on to link various databases. This included the ICU and death line list. I'm sure in the state of Johor, many of you all were actively involved in providing this information. You must have wondered where the information went into. Well, they went into these ICU and death line list databases, which then we all managed to link in together. There were times that we actually used the registry from the school health for different age groups. And the other databases that we actually went on to even link for us to establish the findings on the vaccine effectiveness included the GitHub repository, the COVID Now, and we then all combined this into what we call a CPRC analytics unit. So by linking all these databases, we were then able to generate various analysis, looking at various phases where the vaccine was rolled out. We looked at it when the primary vaccination was rolled out. Then we determined whether the vaccines, there was a need for the boosters to be introduced. We realized there was waning, and especially this was occurring for those who had taken Sinovac. And then we went on to look at the vaccine effectiveness in the adolescent age group, because then that was already phase 3 to see how the vaccines were working in adolescents. And then we also generated evidence for vaccine effectiveness in children. And we have, to date, at least 9 paper publications looking at the vaccine effectiveness in our country. This is real world vaccine effectiveness. I must mention to you the team, a very interesting team. We comprised of public health and ID physicians, people from the disease control division, medical development division. But what was more noteworthy is to mention this team that was in ICR, consisting of economists from Bank Negara, and also I'm sure you would know this gentleman who happened to work in CRC, HSA many moons ago. We together, this team did the data analytics and was supervised and guided by the previous director of ICR, me and also this gentleman who's in Dr. Ting Su from Bank Negara. So the novelty of this is we've won several awards. We've been referred by then the previous minister in not only in the parliament, in many occasions. And we've been referenced by the Institute in the International Vaccine Access Center, IVAC, which is Johns Hopkins. So this is a remarkable achievement for something that we wouldn't have imagined we could do by linking national databases and coming out with generating with timely and evidence-based policymaking. This could only be done because of the good communication. Establishing trust was very imperative. As you can imagine, we were working with Bank Negara economists and then our coordination, because this was all being done during the COVID pandemic, especially during the thick of Delta and the comment at top level. So that's a bit about the investigator-initiated research that we've done in the past. There are many, many more, and I'm so sorry because the interest of time, I will not be able to share this with you. Let me just share with you how the phase one, I'm sure you've been hearing that there's a national initiative for vaccine development. And again, ICR will be playing a major role, especially when these vaccines reach the FIH ward and in the course of vaccine development, because we will be using healthy volunteers, this will be something that is novel to us. Subsequently, after the phase one is completed, then we need to look into phase 2 and phase 3 clinical trials to assess the safety and efficacy. This is as far as vaccine development, something closer to the theme of this Johor Research Day. I thought I would walk you through a bit more about what digital health does. The next two speakers are actually from the Institute of Clinical Research, and they will be sharing with you their more detailed experiences. In the development of digital research, there are various technology readiness levels. There are 3 phases that I would like to point out here, which is the research phase, then it moves on to the development phase, and finally it ends up with the deployment phase. The Digital Health Research Innovation Unit was established in ICR in the year 2000. Within this period of 4 years, it has actually initiated and conducted many interesting and innovative research. Just sharing with you, and I'm sure William and Aizudin will be taking you through some of these studies. Currently at the research phase, there is the study called the BREATH study, which is a novelty. There is scientific merit, but no one has actually innovated on this. We have CODIC-MY, which is actually an initiative that was conducted during the COVID pandemic. And we're moving on to decentralize and use this tool to help out in the treatment of those patients who are seeking care from their homes. And then we have this other concept, which is Dr. Mata, which is the PI is actually already Datuk Nur Fariza, the Deputy DG for Research and Development. And she's currently deploying this initiative that will expedite the readings of the fundus cameras, fundus readings for diabetic retinopathy. Now, although they are situated in the Institute of Clinical Research, we aim to provide service for all spectrums of service. That means right from primary care to hospital to community and improving hospital care. So these various initiatives addressing various aspects of our facilities and services. And eventually we hope to then commercialize these innovations, which is now occurring at least in the case of COVID-MY. So one more initiative that I would like to share with you. This is an interesting development. Actually, it's a very senior pediatrician who brought it to our ears. It's an innovation called Toy 8. It's a tool that's used for screening of those children with delayed development. Currently, we estimate that development delays are occurring from 10 to 15% in our preschool. There is no current service that actually offers for the age group of 3 to 5 to detect the development delay. We have a very good initiative, the immunization program for newborns right up to the 3 years old. And then we have, of course, the school health team that will detect development delay. But this is the age group that we really want to pick up. There is this tool or a digital tool that has been developed by this group of ex-Nintendo experts that is being validated currently against the gold standard, which is called Griffith 3, to ensure that it is a good screening tool The results look rather very positive. If we find this instrument to be as equal or even better than the Griffith 3 diagnostic tool, we will then move on to using this screening tool to develop an AI intervention program. So not only are we going to use this to screen, but we will propose to use an interventional program via mobile games and deploy this into the community. This is very exciting times for us, and we are actually at the brink of demonstrating the results from the validation study. This collaborative effort is a collaboration between our CRC Hospital Cebu. The PI is Dr. Toh Tek Hock, pediatric developmental pediatrician, and is also encasing our the hospital Kapit and Hospital Cebu together with the involvement of researchers from the Digital Health Research Innovation and the Center for Clinical Outcome Research. So this is ideas, this is concepts that came to our ears, and we have actually moved it on, and we're really looking forward to bringing this into an interventional strategy. The last few slides will be sharing with you our experiences and involvement in WHO. It took the COVID pandemic for the World Health Assembly to decide to look at clinical trials. One of the reasons why this came to their attention was the major inefficiencies. There were numerous clinical trials that were being conducted in every country, including Malaysia. These were small, underpowered clinical trials. And the WHO realized that there was a lot of wastage, and we could have done this in a better way. So what happened in the World Health Assembly, in the 75th World Assembly, was the announcement by 195 members who passed the WHO resolution, and then in late November 2023, the first clinical trial forum was conducted. Both Dr. Saiful Safwan, the head of internal medicine, and also the CRC head for HKL, and I were privileged to attend this clinical trial forum. And the main agenda was actually to strengthen clinical trials to provide high quality evidence. What we left with was the vision emerging from the global trial forums was we always must be on, we always must be busy, and we must always be ready. That means we're talking about our clinical trial centers. We have had the opportunity to hear experiences where collaborative effort occur, especially in lower middle income countries, and they go in, they build the capacity, and once the trial is over, the whole team is then broken up, and they all go on to do their own work. So this shouldn't be the case. We should always have clinical trial wards fully functional and operational in case the next pandemic appears. We need to do well-designed and well-implemented trials. What I'm referring to is clinical trials are now very different from what it was before. Previously, we talked about simple randomized control trials. A lot has been developed in this initiative. We talk about adaptive and platform trials. And this is something that we are also looking at the Institute of Clinical Research. We're going to bring trainers over. What we need to do is large-scale trials embedded in the health system. This is especially for diseases that are very rare and conditions. We should be working with other countries in order to have timely results. Another thing that was pointed out is we should opt in our pregnant women and our children. We shouldn't have these opt-out policies, and this was very obvious during the COVID-19 pandemic, where the studies were conducted in a healthy population, and the elderly, together with the pregnant women, these vaccines were not tested. And finally, we need to have patient and community engagement before we start to do these clinical trials. And this is something that we in the Institute of Clinical Research need to improve. After the initiative in November 2023, the Institute of Clinical Research was fortunate to entice the Wipro region to have their first Wipro clinical trial workshop, and we managed to conduct this in the end of March, and it was actually held in NIH. Excuse me. The reason why we brought them here is to allow for more of our CRC heads to be involved. As you would have noticed earlier, only 2 of us could actually go to Geneva. And in this case, we had 4 representatives from the Institute of Clinical Research. This is follow-up actions from Wipro. We are going to have more training material for clinical trial guidance. We are all involved. There is a framework from the WHO that is measuring the maturity index of how ready is the country in rolling out clinical trials. We are looking for coordinated funding. That means those within the Wipro region, if a very interesting study that comes to maybe one country, they would then initiate and look at the Wipro region and see whether the other countries would actually want to participate in this. We will have more regulatory coordination between countries. This also would expedite the conduct of clinical trials between the countries in the Wipro region, where there's a talk to have a single IRB, Research Ethics Committee, but I think this will take some time, and we're developing master contracting. This is my last slide. So what do? How do we move forward? What we need to intensify investigator-initiated research, especially addressing research questions that are very important. We need you, especially from the state of Johor, to actually inform us what are the research gaps, and we then would have to sit down together and see whether we can develop better studies and better protocols that would then change evidence-based policy making. We need to reevaluate the clinical trial ecosystem. This is something that, as I mentioned earlier, that ICR needs to take the lead. We need to develop more innovative clinical trials, as I mentioned, pragmatic and adaptive trials. We need to encourage interdisciplinary cooperation. Research questions should not be coming from one fraternity. We need the surgeons to come up with, and we need the psychiatrists, and we need the oncologists from Johor State to actually come up with research ideas. And we need to avoid duplicating and studies and look at it at a more holistic and national level. So with that, I thank you for the invitation. I do apologize once again for not being able to be present. I really was looking forward to be partaking in the Johor Research Day, but I'm pretty certain that I will be visiting Johor more often. So with that, thank you.
Thank you for Dr. Shamini. Now I would like to invite our next chairperson. I think we do have the question. Good. I would like to invite Dr. Marina to chairing for the next session.
No, sorry. Very good morning. Okay, so let me introduce our next speaker. Okay, he's our keynote speaker for today. The title will be Future of Digital Health. Okay, so I think Dr. Shamini also introduced a few innovation which Dr. Mahesh were actually involved. Actually, he's a very important person during the COVID era. He was involved with MySejahtera, and also with the fact that was involved in the GitHub. Remember just now, Dr. Shamini was showing that GitHub, where they are collecting data for COVID-19. Okay, so he's very well known in the digital healthcare in Malaysia. Okay, and he's continuing his passion into developing more and more in the digital health so that it can improve the quality of healthcare in Malaysia. So with that, without further ado, I would like to invite Dr. Mahesh Wararao to the floor.
Right, thank you very much. A very good morning, ladies and gentlemen. Thank you, Madam Chairperson, for the kind introduction. Do you mind if I be a bit more casual? I'm so great to see clinicians, oncologists, and all that sitting in front of me. So my name is Mahesh, and I come from the Digital Health Division. It's a fairly new division that's developed within Ministry of Health to champion digital health. Very quickly, can I just do a quick survey? How many of you are proponents of digital health? Put up your hands. Oh my God. Less than 50%. How many of you think digital health is important? Put up your hands. Okay. So I used the wrong word, Daddy. Proponent means I love digital health. Okay, cool. How many of you think that we are far behind in the space of digital health? Wow. Okay, lah. Yeah, I feel like a rock star now. Don't you think that digital health is so important, or digitalization is so important? We live in an age of innovation, where digital technology is providing solutions to problems before even we've realized that we needed them. All of us now, if you don't realize, we are into this digital world. We order food through platforms. We book hotels through platforms. We book holidays through platforms. What else you do through platforms? Doctor's appointment. Not in hospitals yet. We breathe. We do everything digital right now. And we cannot be laggards anymore. We have to be early adopters. We do not have benchmarks in Malaysia. People probably, you have seen me before, but I had a bit more hair before COVID. Now, when people ask me my experience during COVID, I say I lost 15 years of my life. But I think 15 years of valuable time that probably I learned so much. Similarly, all of us learned so much. When you talk about digital health, we talk about digital transformation. We talk about AI and machine learning. We talk about cloud computing and big data. Now we talk about quantum computing. Digitalization is changing every second. If those of you think that we will have a plan, a 5-year plan, think about it again. In one of an interview session with Steve Jobs, the interviewee asked Steve Jobs, "Can you tell me what will happen in the next 5 years?" You know how sarcastic Steve Jobs is, right? He's like, "Are you kidding me? I don't even know what's going to happen in the next year. Why are you talking to me about what's going to happen in the next 5 years?" Oh, wait. All your pelan, pendigitalan, 2021, 2024, all can be. We have to move with the new era of how fast technology is moving. So is it an evolution or a revolution? Is it an evolution or a revolution? I would say in Malaysia, it's an evolution. We're always slow in moving, right? We're always one of the last. Do you all know that Malaysia is the first country in 1999 to have our hospital digital? Hospitals Layang, who knows? Do you know it was the first hospital in the world actually to go fully digital? And now, we are back to manual. You all know, right? We are back to manual. Why? Sama lah. Today you buat procurement for digital, after 3 years lulus. After 3 years, today you ask for i5, i9, i7. i7 computer, kelulusan dapat after 3 years. Lapuk sudah. Something's really, really wrong, right? So as we accelerate into the digitalization world, everything else has to come together lah. But it's not happening. It's not happening. Only 22 hospitals in Malaysia is EMR enabled. Only 150 clinics in Malaysia is EMR enabled. we have to start ramping up our efforts. I love this chart, ADEX 2017. Researchers don't say, hey, apa kau ni referring source of old source and all that, but look at this, and it's still relevant today. We have lots and lots of data, parked everywhere. It's now stored in a vault. How many of us are actually exploring the data? Why? We cannot. Because we do not have digital tools. We have My Health Data Warehouse, where data goes in but doesn't come out. I know researchers, I mean, especially ICR, CRCs don't really like, I mean, come on. And you, Kerah, our clinicians down there, make sure you see registries and all that, beautiful. But nothing comes out there. Why? If you want to refer to a very good industry, it's a gaming industry, where they combine technology, data, analytics, strategy, talent, and organization together. Then comes the finance industry. Although finance industry is highly regulated, but they are so much ahead in terms of digitalization. In 1997, Barry Silverman said this: the complexity of modern medicine exceeds the inherent limitation of the unaided human mind. True. Now there's so much new stuff, right? We need something to augment our decision making. As I walk through the journey of the future of digital health, I'd like to bring up few beautiful use cases, examples. This is one of them. This is not new. Any radiologists here? Oh. When I presented this way back in 2012, 2013, I got a lot of radiologist friends. Later we'll yamcha together. I said, you know what? There's AI in radiology already. He's like, no, bro, don't. You will take over my job. I don't know why doctors are so... Unlike other specialties, doctors or healthcare personnel are not replaceable, right? You have digital technologies to just augment your work process flow. He's like, no, I still want to read my x-rays. Then I gave him an example. How much you charge to read one x-ray? Say 6 ringgit. How many x-rays you can read in 1 hour? He's like, about 8. And you have to do reporting, what? Right, so 8 times 6 is 48 ringgit. Then I asked, how much you charge to read or do a CT scan? Few hundred ringgit. And how many you can do in 1 hour? Is it 2? I said, look at that. Why can't you have AI to help you read chest x-rays, where it can reduce your burden? You only look at abnormal ones, and why don't you focus on CT scans, which could rake in more money? Then it made sense. All over the world, radiologists don't actually look at chest x-rays especially. Chest x-rays, AI in chest x-rays is so advanced, correct? Yeah? AI in chest x-rays is so advanced. Is your department using any sort of AI for reading x-rays? Doctor? Funding issue. Always the case, huh? When I say digital stuff is better, it's not better. It actually gives you more power to do so many other things. This is another marvel for me. Prof. Ido Bachelet. He's an expert in DNA origami, nanotechnology, nanorobotics. How in 2013, not now, 2013, he spoke about how he's created nanorobots to go in and look for cancer cells, destroy and eradicate. 2013. Where are we right now? Funding issue. In 14.6 USD billion spent on AI. In 2028, $102.7 billion. That's a compound annual growth rate of 47.6%. spent on AI. If you look at it, North America accounts for the largest share of AI in healthcare market in 2022. So this just to show that how fast every countries all around the world is moving. I just got back from Geneva, not for World Health Assembly, but I spoke in World Summit of Information Society. You'll be surprised. There's just one stream talking about digital health. And you have countries like India, countries like America, countries like the UK, they're moving so fast ahead. And thankfully, because of COVID, like Sir Albert Einstein said, in the midst of every crisis lies great opportunity. That's when tiba-tiba Malaysia came up. We're one of the only countries who did really, really well during COVID-19. Whatever Datin Shamini presented just now on RECOWAM and all that, it couldn't have been possible if we did not have any digital tool. And now is the time for us to leverage whatever we have. When you talk about impact of AI in healthcare, there's so many different methods where you can have AI. Machine learning, natural language processing, rule-based expert systems, physical robots, and RPA. I come from the public health program, looking at public health digitalization. When we deploy something, you just don't deploy a system. You should look into your business process. Digitalization is just not from paper to computer. All of us think like that, you know, as long as I ada EMR cukup lah. Data entry. For what? All our 22 hospitals still have problems with patient waiting time. Why? All our patients in the hospital still have to come and see their surgeons for wound inspection. Why can't we reduce that burden from our surgeons? Why don't we start having telemedicine? I'm guilty as charged. The biggest or the toughest people to change is, you know who? Who? Doctors. I was like that. Because we want 100% perfection all the time. We don't need to be 100% perfect. You know the 80-20 rule? As long as you're perfect 80%, your 20% will come just like that, right? Opportunities for digital health. A lot. You have EHR data, you have MyHDW data. Yeah. He doesn't want to be associated with MyHDW. There's a lot of data in our world. When are we going to open it up now to start using the data? Can you imagine with that data, you combine with so many other data, your proteomic data, genomic data, your wearables. How many of you wear a smartwatch here? So little, Johor. Aduh, less than 50%. Oh gosh. So why do you use a smartwatch? Gaya. To be honest with you, I bought a smartwatch last time because suddenly I attended an Apple event. That guy was changing slides with his watch. So I thought, wow, let me get it. That's all. Now at least I've moved one step further, checking my steps. Do you know it collects so much more data? Your sleep pattern, your mood level. Who's analyzing those data? If you have allowed data sharing, Apple guys are analyzing. Or Google guys are analyzing. Not us. How if today, how today you can ask your patient to go home, right? And you can monitor his sleep pattern. Correlated with your symptoms of depression or whatnot. It's there. It's just whether or not we want to tap on it. A beautiful study done in the UK. Today, if any patients come into clinic kesihatan, too many patients. Too many patients, you know. I've seen my colleagues, I'm banned from seeing patients in clinic kesihatan because I see patients too slow. The nurses say, no, doctor, jangan datang. I see my colleague, I say, what's happening? As soon as the patient opens the door, ayah sakit apa, as soon as sit down, prescription slip ready. I mean, it's facts of life. You can't blame the doctor because there's just too many patients. And you know what? HbA1c, normal HbA1c, 5.7 to 6.4. Right? Everyone similar, correct? If you're a diabetic patient, 7% is okay, right? But if you have good EHR data like this, it's a machine learning paper. It looked through the entire EHR and it grouped the population into 3 different clusters: ascending, stable, and descending. And all these 3 groups had different levels or normal levels of HbA1c. That's what we want. My HbA1c level is different from yours. Could be different. It all depends on how we look into our data. This is what we want. Ovarian cancer. Asia is going to be one of the highest one. 1 in 5 women diagnosed with ovarian cancer have never heard about the disease before. They only come in when there's a mess, usually, right? Why could not have we identified much earlier? That's preventive medicine. During a simple question like if you've got family history of ovarian cancer, that should already give you some sort of decision support saying that, hey, Mahesh, see, high risk for developing ovarian cancer. Let's do something. Follow up the patient. And you do not have to constantly follow up. You can have reminders, you can have follow-ups, digital follow-ups, right? So these are the fields, the areas that clinicians should start exploring. A study done in America using UK Biobank's genomic data. How now they can start identifying Alzheimer's much earlier. Alzheimer's is such a debilitating disease, not only for the patient, but for the surrounding people. How we can identify much earlier and start having them not progressing to late stage of Alzheimer's. Research cannot stay as a research. You need to start translating good research into practice. So now, we have smartwatches which can detect heart rate, correct? Can it detect irregular heart rate? How now it just doesn't stop as a recording tool? How it can inform your clinicians that, hey, this guy has got an irregular heart rate. Immediately you get a notification saying that you have got irregular heart rate. Let's now refer you to a clinic. Get an appointment stat. Is this rocket science? It's not rocket science anymore. We've done this. We've done this during COVID. Now, we must maintain the digital momentum. We must maintain the digital momentum. Again, an example of how if you have everything smart at home. Who loves smart houses? Anyone has got your houses and all that smart? Oh, you, because you're a digital guy. Mr. Navin is a digital guy. Anyone who can, at home, you know, Gaia, everyone for Gaia, right? Open the app, gate opens. Go inside your house, lights open, curtain opens. Now, how if you can start getting medical devices which is Bluetooth enabled, which can link to somewhere. In the morning when you get up, when you look at your mirror, when you want to brush your teeth, suddenly your mirror says, you better take MC today, you can't do it. These are all smart stuff that we need. It looks like you got some loss of nasolabial fold. Please go and see your doctor fast. You know, things like that, right? I remember speaking about this in 2012. And there's so many solutions like this already available. Who loves this? Really? Nobody likes this. ChatGPT, the marvel of whatever. If only this was there during my doctorate, I would have GOT, graduate on time. Now every single thing we do, ChatGPT. Quickly, buat surat. The only thing, our surat in KKM is always go back and forth lah. Tak ada nokta, tak ada koma kan. Right? But this is a marvel. ChatGPT. How you have billions of data right now. Those were the days 20 years ago, or probably 10 years ago, just 4 or 5 variables enough lah. You're an Indian boy, bald, size not so big, probably would have heart attack in, okay? But now you have billions of data. How you can come up with much more complex prediction. But it's a double-edged sword. It may be good, it may be bad, right? But we can make proper judgment. All this data. When you put your data in the cloud, you can use a lot of cloud microservices. You can use a lot of analytics. You can do a lot of stuff. You can even compare your data with other countries' data. Come up with some sort of conclusive insight for your day-to-day practice. This is what I want later. Any housemans here? Oh, no housemans. Not enough housemans. I remember suddenly your consultant says, here, do a summary. But now I heard Amos does summaries. But how we have EMR later, I'll say, hey, like how we have Siri. Hey Siri, summarize patient's record. Oh, don't you all like it? We want this. Of course, I mean, there are some cons to this, but this is how the world is moving. Do you know EMRs now? You do not have to type. You just speak. Patient, 26-year-old gentleman coming from here and here, have past history of this and this. That is EMR. Then you tell the machine, EMR for me. It just doesn't do voice to text. It also classifies whether is it a personal history, medical history, past history, and whatnot. That's why I'm ensuring that we get the best EMR product. Health ministry is not a technology ministry. Why would you want to build products? Do you want to build products? You can build products if you have the capability. But our function in MOH is just two things: health governance and healthcare service delivery. Why do you want to reinvent the wheel? Unless I'm super rich, I've got a lot of tech offices. Because you see, digital health is actually currently a market-driven industry. Don't bother reinventing the wheel. You have so many products out there that can solve your problems. And using all this experience, during COVID, India, when they had Nipah suddenly, they could just pivot. Similarly, in Malaysia, during COVID, we had a monkeypox scare. Immediately, digitally, we could do something, right? Using all our experience to see how best we can continuously grow. Is it so difficult now? All of us have EMR. Who's from Hospital Sultan Ismail here? You all use Cerner, right? Right? How nice. You know my primary healthcare clinics? When a patient comes with fever, cough, hemoptysis, and I diagnose him as upper respiratory tract infection, immediately a pop-up comes. Doctor, do you want to think of tuberculosis, sarcoidosis, lung cancer? When I say I've got allergy to penicillin, and when a doctor prescribes a penicillin, we do mistakes, right? The system gives you an alert. He is allergic to penicillin. This is something we call clinical decision support. Those are the characteristics of EMR that we want. Not merely a paper to an electronic form. No. Go read up on EMR. Basic stuff, and it's not rocket science anymore. When you have electronic health records, you can put in algorithms. There's already a lot of risk scoring system, American Heart Classification. This paper actually talks about gestational diabetes mellitus, right? When you have got all these already risk scores, how you can have that embedded in your EHR and helps you improve your clinical decision making. We are moving towards precision public health. Precision public health is digital health, big data, precision medicine. But for me, precision medicine is you talk about genomics, right? Without even precision medicine, with big data and digital health, you can already do a lot of targeted interventions to your public. Ladies and gentlemen, we need a paradigm shift. Kita memerlukan anjakan paradigma. I don't know in Chinese. Because I don't know how else to go and speak to people. We have to move from being very institution-centric to population-centric, to individual-centric. This is going to be our new digital health ecosystem, where we have the individual as the centerpiece, as the heartbeat of your digital health ecosystem. How you connect the private to the government. How do you connect all online health platforms to the patient? And the patient is the custodian of their health information. When I come to another facility, the doctor says, can you share your records? You have the thing to actually select, or you have the option to share what you want to share, right? So this is going to be our new development for digital health in Malaysia. All of you will be thinking, this guy talking like that in front, I don't even have computers in my clinic. I don't even have proper internet connectivity, correct? It's not too late. I remember our previous KSU will say, do not come and ask me for manpower, money, or material. Now it's time for us to innovate. I'm sure we have a lot of networks where they can actually give us or, subsidized computers. We have a lot of 5G companies coming in, having a connectivity within our hospital. We should start embracing public-private partnership. Very, very important. We need to start seeing how best we can leverage on the private world. These are the imperatives. We need to be digital enablers. We need to have digital drivers. We need to change our minds from analog mind to a digital mind. Change management. My mantra is very simple. If I keep talking, nothing will happen. But if you can see, you can feel, then you will change. We have felt it during COVID, and I'm sure we will have to change. We need to start developing capacity and capability. I know a lot of doctors, clinicians, nurses, MAs in the hospital who's so digital savvy. You all develop, even using Google Sheets, coming up with business workflow process. Amazing, isn't it? How, if you give them a little bit more capacity and capability, they can do wonders. We need to start not reinventing the wheel. We need to get solutions that fits the purpose. Policy should dictate technology, not technology dictating policy. Just because I have this technology, you have to use. No such thing. Our policy dictates technology. I told you about democratizing healthcare services. Again, I would like to stress, digital health currently is a market-driven industry. Leverage on whatever we have in the market. Interoperability, again, none of the 22 hospitals can speak to each other. Why? Why? Because there's no standards. The patient has to undergo, again, all sorts of investigations when they move from one hospital to another. Digital trust, as we move on, as we accelerate digitization, we need to start building digital trust. Hence, data governance is extreme important. Before I leave, a beautiful, beautiful quote. Again, I love quotes, okay? Charles Darwin. It is not the strongest of the species that survives, nor the most intelligent, but the one most responsive to change is the one that would survive. Ladies and gentlemen, we love writing blueprints, purple paper, red paper, now white paper. After this, what color? Transparent paper. We need not have any more blueprints. We now need footprints. Thank you very much. Do I have any questions before or I finish my time?
Okay, thank you very much, Dr. Mahesh. It's very inspiring. I hope then it'll give us the ideas, the kind of inspiration to actually use the technology and innovate the technology. What he's saying is not to come up with new technology, but use what's already available. It's also okay. And technology is not just about collecting data, but translating it out and using it for our use, for our population, for our patient, okay, to make our life easier as well. So with that, I would like to thank you, Dr. Mahesh, and as a token from our Johor Research Day,
Good morning. I'm Dr. Suhaila. I'll be chairing the next session for our Johor Research Day, which is a symposium on the digital health research, making it work. So we are very honored today to have three of a very prominent speakers. We have two from NIH. We have one, Mr. Navindran, from our technology, from a private, our collaborative partner. So without further ado, I would like to introduce our first speaker, Dr. Muhammad Aizuddin bin Abdul Rahman. So Dr. Muhammad Aizuddin was previously a head of digital health and research and innovation unit from NIH. So he has been a vital person in the development of research digital health research in Malaysia. So he has involved in many research, including entomology, NCDs, communicable disease, as well as pathology, surgical, and other digital health. At present, Dr. Muhammad Aizuddin is furthering his study. He is also a double degree holder. He has a degree in Tadi dah hafal, tiba-tiba lupa, it just slipped off my mind. Okay, so he has a double degree. He has a degree in a biomedical, but then subsequently, after a few years, he suddenly decided, oh, I want to become a doctor. So dia buat MBBS pula. So now I would like to introduce, I would like to invite Dr. Aizuddin just for the first topic today. The topic that he will present today would be digital health research. Please, Dr. Aizuddin.
Hi. So Mahesh said different stage but I have to cower behind the desk there, and I only have 20 minutes. Okay, so a bit of thank you for the introduction. So I will just summarize what I do. I'm a medical officer who have interest in technology, and yeah, that's about it, I guess. So what we do from day to day work is thinking about research and how can we improve patient care from clinician perspective. And as someone now we are in management or middle manager, we trying to make your life easier when it comes to research. So that's the role of CRC. So I come from Institute for Clinical Research, essentially a central agency for CRC. So just the thing about technology, it fails when you want to use it. All right? Okay, so I wanted to my talk about the world and everything. I just want to bring everybody back to the local scenarios. Not that much local, just closer to us. So setting up a bit of landscape about well, when we talk about in digital health research, we can't run away from industrial revolution. Lambat sikit lah. Okay, so this is a chart. I think it's familiar to all of us about industrial revolution. So we take from first industrial revolution, talk about steam engine, mechanical manufacturing and all, and then goes to mass production and so on. Now, the thing about this chart is it doesn't stop after the start of second industrial revolution. It keep continuing, but it keep improving. As you can see on the, wait, let me try this. Okay, can? Okay, I can see this area of talent. These are talents that the industrial revolution tried to change or challenge. So these are talent that will be later on replaced by the revolution. Now, when it comes to Industrial Revolution 1.0, 2, and 3, and talk about more on labor, more on hard skills, hard, the thing that can be mass produced. Okay, so go to the next slide. So, okay, so this is a different fancy chart on the Industrial Revolution. It took about like 100 years from one revolution to another. But again, what happened is first three revolutions talk about these hard labors. But the fourth revolution, it capitalized on data. A lot of people will start asking what this have to do with me. Later on, I'll share that. Now, this is a very interesting work or career. Back in 1940, 1970, we're talking about, I think, second industrial revolution, where people, I'm not talking about the hunter-gatherers until we go to modern society. What happened is when the industrial revolution start, all of us start to have the same time, we have to, same routine. Means that every morning we have to wake up, goes to work and all. And at that time, it's not a norm. Of course, nowadays it's a norm. But during that time, there are few people that have natural ability to wake up earlier than the rest of us. Or I don't have that until today. So I need some knocker-upper. But anyway, this career was introduced during the revolution, and it also killed during the revolution itself. Almost overnight, this career was taken away by technology and innovation. Can you guess what the innovation? Correct, alarm clock. I have that at least 4. This morning I have 4 alarm clock to wake me up. I think I still need the knocker-upper. But anyway, so you can see that every revolution, it will take over the job. The fear of all us in medical field that this revolution will take over our work is not unique to us. Yeah, it's not unique to us because we only thought that these are the things that you can do, as a medical profession. And then when you start working, everything you teach is totally different. You got culture shock. And after 5 to 10 years, somebody come and say, hey, there's new technology that can do whatever you do much better than me. Now, let's go to another classic story of how revolution changed our work. So, have you watched this movie? So it's a Charlie from Charlie of the Chocolate Factory. Yes, right. So this is Mr. Bucket, father of Charlie. He worked as a manual labor operator in the factory that put up a cap on the toothpaste. So you can see from the previous picture, there's a lot of other friends and all. So when this second revolution come, it changed the entire automation in the factory. So what happened? Mr. Bucket lost his job. But he didn't sit there and, blame himself, these are things that I don't know, the machine just take over my work and all. But he learned, he upskills himself. At the end of the day, he now is an operator for this one. So drawing from this inspiration, I would like to encourage everybody to come together and see how can we utilize the technology. Like Mahesh mentioned earlier on, we are not going to reinvent the wheel, but you need to know what's the technology around you. I'll give another example. Do we have paramedics here in the room? I'm sure we have nurses that struggle with retin. During COVID, I'm sure it's easily created 20 extra retin on top of the 40 or 100 retin you have to fill up. At the end of the retin, you have to come up with a report. Do you know that we already have this, MOH now using Gmail, so we can utilize that Gmail to do some automation for us, summarize the report for us. What I always do is, champa the entire data to Google Sheet and ask question from that, derive conclusion from that. So back to the Industrial Revolution. So 1, 2, 3 talk about hard labor, but the fourth revolution specifically focus on knowledge worker, which is all of us, and skills. Some people say that human skills are not replicable. It's very valuable. We kind of hang on the small thread here because the rest of the world is moving forward. What we need to do is, one is to understand our basic work best, so that when technology comes, it will help us moving forward. If you have time, do read this report from World Economic Forum. This was launched in January 2024. So previously, it had a similar paper in 2017 predicting what are the impact on healthcare system. Still have time. Okay, so then we're talking about technology integration, big data and analytics, artificial intelligence, cloud computing, automation, and robotics. All these are buzzwords. But as a medical profession, you really need to know what are these and how does it will affect your work. For example, we're talking about radiologists and pathologists, how this new AI coming in to make diagnosis and all. So the system AI or big data or machine learning can do correlation, but they cannot do causation. Who knows about the patient? Who knows about the case? It's all back to you. So this is where we should play with our partners, the data scientists, all the technology providers, and give direction or meaningful inputs so that the system can help us. Now, other impact on healthcare system is how we deliver this healthcare delivery model. Previously, we were talking about, I think this sounds like deja vu, shift towards seamless continuum of care, more on prevention and early intervention. But now we see a lot of cases coming up again. What I can say is that this prevention and intervention still need to going on forward. But with digitalization of the system, hopefully we will have another AMR, but that's another topic. This will actually drive everything. It's essentially EMR on steroids, very fast. You may not realize that the change just happened the next day. So please be prepared ourselves, knows the technology, knows what we do well. And then I'm sure a lot of people is talking about, it's too expensive for us and all. But in the long run, the cost will again be settled. For example, we did a study using virtual reality together with clinician and our partners. When I think before we start, the cost of one VR headset is easily 5,000. I just quote from air, but it's there lah. But now you can get some VR headset which okay quality, somewhere less than 1,000 ringgit. Now the question is not about the technology. The technology will come and go. Or I mean, it's here to stay, one. But two is how familiar is you with the basic technology. Then we can improve our care. For example, I was talking about AI just now. If say AI come into EMR, you forced to use AI, you'll be struggling. That is unnecessary stress we want. So this is when we go and venture into technology. Don't waste your time or try a lot of other things. Just understand how it works first. And then, of course, there'll be regulatory and ethical challenge along the way on something that we don't know. For example, cybersecurity. The biggest cybersecurity threat come from all of us. Can I have raise of hand? Anybody never share their password with anyone? Yang tak pernah share, can angkat tangan? I have one or two yang tak pernah share the password with everybody. I'm sure Mr. Hans can vouch for me. When we do things in surgical last time, we share the password for department email. Okay. But sorry. Then what are the impact on healthcare workers? We're talking about the system and all. The first one is the workforce transformation. The nature of work will change significantly. This automation, this AI and everything will change the way you do things. Normal things you do every day, like for example, as clerking patient and entering data, that will change. Now, we need to be familiarize ourselves. Don't wait for the technology to come. Because I can bet you, the technology is there, it's just waiting for someone to say, or policymaker say, okay, this year we want to use AI in our EMR. Then we'll be struggling again. Maybe not many of us was in that transition period from manual to digital, but I can tell you it's a painful process if you're not ready for it. And talking and typing is totally different thing. Who can type faster than they talk? Not me. So that's why we need the AI now. And then training and education. We have our continuous professional development, but now we have to think about all these CME, CPD topics should be aligned back to how the technology will impact our work. And of course, cybersecurity awareness is something that we want everybody to have. Please don't share your password. Not in social media. Okay, this is some of the field of digital health. This is by no means exhaustive list, but as digital health research and innovation, we work on a few of these topics. We did IoT, IoMT early on during the previous part of the pandemic. We have some work on additive printing, but it stopped somewhere. We have extended reality. Some of the AI works also we have. Now, from the earlier montage, we see there's, like a movie like Minority Report, you can manipulate and all. It's not just in film, it's real now. There are a lot of universities start using this extended reality to help their student to learn. Later on, I'll share a case study where people actually use this for a healthcare delivery. Of course, during pandemic, we are very forced to use the telemedicine. Love it or hate it, you have to use the telemedicine either by Zoom, Google Meet, or whatever you can call it. Now, there's a significant improvement in terms of sensors. Now we have small sensors that can do wonders. iPhone, it's okay. This is teleradiology. This is nanotech, and this is digital pathology. Okay, so like I mentioned earlier, it's not science fiction anymore. It's already here. You just need to use it. Wait. Tak ada suara. Tak jalan. Okay, so this is a video about yeah, it's a video, but it doesn't work. Anyway, the technology fails you at the most critical time. So this is a conjoined twin back in Brazil. This is, I think, end of last year. So what happened, the team of surgeons from Oxford and this from Brazil, correct me if I'm wrong, but what they did was they using virtual reality to help them to plan for the surgery. So they trained for months. This operation takes a lot of planning, and it involves very delicate areas that you have to understand in order for you to have, well, surgeon always have the confidence to move forward, but if this is very complex case, it needs 100 medical staff to work on this process. So what happened is they combine technology using CT scan and some of the imaging that reconstruct in 3D, and then use virtual reality to help planning the surgery. And the surgery is successful. Baby still, the operation was like less than a year. Baby still alive today. So this is things that, it's in action now. It's no longer in the science fiction. Okay, so I have 4 minutes. This is some of the reference. Please read the World Economic Forum. And I wanted to end my part with this picture that I use AI to generate. So this Malay saying that bagai katak di bawah tempurung. So what says that, you can remain ignorant. There's a lot of things happening around you. But as a katak in tempurung, you can't really see outside world. We have internet now. Your phone, the things in your mobile, your pockets, is even powerful than the satellite that, the away from Earth. Voyager kot yang paling jauh daripada Earth. Your phone is powerful than that. We have all the information we want. We lack of action. So I would like to have everybody here to start not just talking about AI, not just talking about VR, not just talking about technology. Try that. We are here to help. You are clinical research. We have CRC. I'll just dump that to CRC team. You can contact them to have a collaboration. Yeah, thank you.
Thank you, Aizul. Right, we move on to the next speaker, you see. Before we move on, I would like to inform you that, me, Dr. Aizuddin, Mr. William and Mr. Navin has been embarking, and Dr. Marina has been embarking in a VR visual reality GAD studies. That is the first in Malaysia. So it is actually a critical trial. So these are the themes. So right, without further ado, our next speaker, Mr. William. Mr. William is, when I read through his profile, I would say that he is actually like a fortune teller. Why am I saying that? Is because, Mr. William, he has a vast experience in predictive analysis. So he is actually involved so much in a COVID analysis, in predicting the COVID movement during the MCO, as well as the predictive and the survival with the use of a vaccination in Malaysia. So today he is with a Digital Health Research and Innovation Unit. So he will be speaking in the AI in the health services. So if you guys have any questions, we're going to save it until the end of the symposium. So let's welcome Mr. William.
Very good morning to everyone. My name is William. So first I have to declare I'm anak bangsa Johor. Yeah, thank you. From Batu Pahat. So my career as a pharmacy actually started in JB, Hospital Sultanah Aminah. For 1 year, PRP. For those who are pharmacists, you know what PRP is, professional pharmacist. Then I joined HSI, Hospital Sultan Ismail, in 2007 until 2010. Then I ventured into research. So now I'm a full-time researcher. Okay. So anak bangsa Johor, Okay. So in 2020, I joined the Digital Health Research and Innovation Unit. Okay. So after I zoom down, I start chairing the unit, leading the unit to venture into research and innovation using emerging technology. Okay. I'm glad to come back. And I'm glad to be invited to share some insights about AI in health services. Okay. So it's going to be a difficult topic because AI is very popular now. I'm sure all of you know how AI, you use AI, but probably many of you still don't know how AI works, right? You know, how AI learns. I have 1 or 2 slides explaining about AI, how AI learns. Then we look into various AI applications in health services. And I'm using AI innovations from my unit to probably explain how we can create AI solutions to help improve health delivery and services. Okay. So how much time I have? It's not fair, right, for me to present fast because of the first 2 presenters. One here and another there. So I choose to stand here. I don't know where to go. Okay. Okay. So this is my presentation's outline. Okay. First, I will talk about what is AI. Okay. Give you some definitions to bring you into the topic. Then next, I would like to explain about how AI works by using a regression model. I think that is easy. Then when we do AI, we train AI, we develop AI. Next, we have to consider deployments of AI. Okay, so we explain about what deployment is all about and what is the most important considerations. Then AI as a computing program is classified as a software, right? Okay, we talk about one category of software as medical device by the US FDA. Then we talk about AI in radiology and also AI in other fields. Then we talk about future of AI in healthcare. So this is my presentation. Okay, for the next 20 minutes. Okay, so let's look into the definitions of AI. Out there are so many definitions. When you open up, you know, even you ask ChatGPT, they will give you some form of definitions. So today, I choose one which is pretty straightforward and direct for the participants. AI is a machine-based system that can do predictions, recommendations, and decisions, okay, for a specific purpose or intentions. Okay, in medical, it's for medical, solving medical issue. And interestingly, those prediction, recommendation, and decision made by AI can actually influence or impact our real environments or even virtual environments. Okay, let's look at the first diagram here. Okay, wow, technology. Up here, up there. Okay, so we human beings, right? We make decisions and choices every moment, right? Okay, have you wondered how you come up with those decisions? First, based on our senses input, what we see, what we hear, and how we feel, right? Combining our experience and knowledge, then we come up with the best decision for an intended outcome. So what AI is doing is really to mimic this process, okay? But they are using data. Let's not forget senses input, what we see, what we hear, our knowledge, our experience, all can be transformed into some form of data, okay? So in theory, if AI is making those decisions based on data, it should reach similar decision as we need. Therefore, the outcome, okay? So AI are good in predictions, classification, and clustering. And under AI, there is a subclass called machine learning. So what is machine learning? Machine learning refers to technique that can be used to improve the accuracy and performance of AI based on data over time, okay? So there are many machine learning out there. And one particular one, deep learning, which is why there are so many AI innovation in radiology. Later, I will explain a bit more, okay? So are we clear about what is AI now? So then we will see how AI works. Okay. So to explain how machine learning or AI works is not easy, okay? It's not easy. That's the reason why many of us are still wondering how AI can learn from data and reach certain decisions. Today, I'm using a multiple regression model and trying to explain to you, okay? Do you know multiple regression model? How many of you know regression model? Can you put out your hand? You don't know, right? Okay. Okay. The diagram here, up there, is actually a multiple regression model. It's a mathematical formula, okay? In this regression model, we have two parts. The first is the predicted value. The second is a set of predictors, okay? So in statistics, the predictor value is also called dependence variables, okay? Because its value actually depends on what are the predictors that you put in, you use in the equations. And if you look at the predictors, you have two components there. One is coefficients, another is independent variables. Oh, okay? So what we do when we say training or developing AI is to fit this model to a set of data, okay? So that the model can find a set of coefficient value that give you the predicted or prediction with higher accuracy or lowest error. And once that is done, we lock it. We will lock the coefficient value, okay? So in theory, that is how AI learns from data. So it learns from adjusting the coefficients and lock it, okay? So we say, when we say developing AI, training AI, usually we will split our data set, a non-data set, into two parts. One is training data set, another one is a testing data set, okay? Once we've done that, we will set our AI model, right? First, we fit our AI model to the training data set for the AI to update the coefficients. Then we lock it. In order to know the performance, we will test the AI using the testing set, okay? So once we have tested, we get some predictions, some predictive value that can be compared to the ground truth. So by organizing ground truth and prediction into a confusion matrix table, we are able to determine the accuracy, sensitivity, specificity, predictive value, positive predictive value, and negative predictive value, okay? So this is how we evaluate AI, how we train and develop AI, okay? So are we clear about that? Okay, simple enough. Actually, it's quite complicated because there are hundreds of machine learning out there. Every machine learning model has a way of setting the coefficients and lock it. So this is how AI learns, okay? So next. Okay, once we have developed and trained an AI model, we have to consider deploying an AI model into the productions, into our environment. And deployment of AI refers to integrating trained AI model into the existing environment to start making decisions or to augment decisions. And there are two types of deployment, batch deployment and online deployment, okay? We can deploy an AI into a medical device. We can also deploy an AI as a standalone application online so that people can request real-time predictions, okay? And deployment of AI or deployment of AI are not cheap, actually it's costly. Why? Let's look at the back-end components for doing AI research or developing an AI solutions. We need server first to host the AI model, to host the database, to host the user interface, okay? We need to set out the database, we need a data dictionary, and because of the patient's data, we need to have a security protocol to avoid hacking or also cyber security attack. In order to use AI, we need to develop the user interface as well. And we need to subscribe to API service, applications programming interface. It's like a code. They can connect all these systems together so that we can start using it. Okay, these are all infrastructure costs. Not mentioning the development costs, data-related costs, operational costs, and also human costs needed to get the whole system running. So it is costly. Okay, so one of the biggest consideration in developing AI solution and deploying is what is the return on investment. So much money you put in, what are the value created in order to justify that investment? Return on investment means has a formula. Okay, it is equal to the gain of investment minus the cost you put in divided by cost over a period of time. Okay, so there are two parts about ROI or return on investment. First is generating income. Another one is saving your operational cost or hospital cost. We can achieve cost saving by improving efficiency, reducing processing time, improving accuracy, or making early diagnosis, so that we don't have much more complications to handle in the future. So should you build your own AI solution or use an existing tool? That will depend on many factors. Most importantly, resource that you have, and also what problem you're trying to attack. Okay. Okay. So AI as a software, right? A computer program. And in medical, under the US FDA, it can be classified into three categories. The first is software in a medical device. Second is a software used in the manufacturer or maintenance of medical device. Okay. And AI specifically fall under, majority of them fall under software as a medical device. The AI itself can be classified as a medical device. Okay. So for software as a medical device, they are standalone and serve multiple medical purpose. Of course, it can also run on various platforms, including incorporating into a medical device platform or also virtual platforms. Okay. For medical device under US FDA, it can be further classified into class 1, class 3, and class 2 and class 3, depending on the risk to patients. Okay. So here I'm presenting to you example of medical device. Hearing aid, class 2. Back braces, class 1. Baby machine, class 2. Insulin pump, class 3. Okay. So depending on the risk to patients, AI can also fall into these three classes. And internationally, there is a regulatory body or there is a working group creating a harmonized guideline and principle to govern medical device, especially for software as medical device. So the purpose of that group is really to promote safe innovation and to ensure patient safety while using those medical software as medical device. Okay. They also provide harmonized quality management principle for regulator worldwide, including FDA. That working group actually consists of multiple countries around the world. Okay. And as of July 2023, more than 692 AI medical algorithm or model has been approved by US FDA, and more than 77% are in radiology. Why? Because radiology has so many modalities, all involving images. Okay, and AI really can improve image analysis and also interpretations. About 10% in cardiology. Okay, So when we talk about radiologists, we have a radiologist right there, right? It's all about, the main role is all about detection of structural abnormality and classify them into disease category so that we can formulate some plan, treatment, decisions, and moving forward. And there are so many modalities here, okay? As you can see, AI has been proven that can reduce false positive and false negative result, improve accuracy, improve productivity, and addressing a human resource limitation, especially in Malaysia and in other countries where we have a limited radiologists, okay? And also take away or removing repetitive tasks, okay? One particular AI model that actually contribute to this advancement, which is called deep learning, okay? Let's learn a little bit about deep learning. So when we talk about deep learning, first we need to define what is neural network. A neural network is an organization of AI, artificial neuron, that can process a huge number of input and to produce an output, okay? And a deep learning model consists of multiple layers of neural network. The word deep actually refers to the capacity or capability of the AI model to learn and to discover complex features within data, okay? So in here, I'm presenting to you our biological neuron. Okay, I hope you still remember your neurons when you are doing biologies, right? One single neuron can receive multiple inputs, right? And then produce an output to trigger other neurons. And mathematically, this has been put into equations like this, where you know a single mathematical formula that can process multiple input, assigning weight, okay, to produce an output, okay? You see the equation there, okay? So I want you to take the W or the weight as some form of coefficient where the mathematical models are being optimized to learn the feature, okay? So by organizing all these artificial neurons into a matrix, we form a neural network like this, okay? And this architecture is the reason why we have so many useful and accurate AI model in the radiology service, because it has been proven very effective, very accurate in extracting feature from radiological image or any image that can relate to outcome. Okay? So here are some successful cases about the use of AI in radiology. So every year we have about 7 to 8 million women diagnosed with breast cancer. And nowadays, research has shown that AI can detect breast cancer signs in mammogram that are even not visible to many trained radiologists. Okay, so I think nowadays all the mammograms, most of the mammogram machines come with some form of AI interpretations. Okay, and recently, University of California developed an AI model that can detect Alzheimer's disease based on PET scan output with up to 92 accuracy. Okay, so and AI has been shown that can can classify brain tumor in less than 150 seconds, it's faster than the process, as compared to 20 to 30 minutes for conventional method. And in those optimizations, AI achieved dose reduction between 30 to 70%, and with the potential to go up to 95%. And this can reduce harmful effect of ionizing radiation on children. So there's so many benefits offered by AI: early detection, improved accuracy, faster diagnosis, improved reporting, improved access to care, optimizing dosing, and also reducing radiation exposure or harmful effect. These are the benefits offered by AI in radiology only. Of course, all these benefits we are receiving, there are also challenges that we need to face. For example, poor ICT infrastructure. So I think many of you agree with me, internet are, not so good how to embark into AI research or even AI applications. Human reluctancy, our guidelines are still not updated with the needs to incorporate AI into services. So many doctors are still refusing to probably embark into AI solutions. Data security, we're talking about patients' privacy data, where the server is, where the data goes. All these are still in discussions. And there are many more. For example, poor data quality cause AI model to have inherited biases. Okay, So that is radiology. Now I want to talk about AI applications developed by my team from NIH. Okay. So my team started from 2020, embarked into various AI applications, developments, and innovations, trying to help the health system. I think in 2021, when we are still in the COVID-19 pandemics, we worked with a private university to develop an online screening solution for detecting COVID-19 infection through our cough sound recording. So we have an online application where you can record, where you can use it to record your cough sound recording. Then you submit to the AI for the interpretation. Then the AI model is able to tell you whether you are high risk of contracting COVID-19 infections or not. We use a neural network model, and we have achieved 87% accuracy. And that piece of work is published in international journal. Okay. Now we are developing AI screening solution for detecting leprosy infection through skin lesion. Okay. And we want to enhance our capability to screen leprosy. I think recently we have a concern that leprosy prevalence is increasing. Okay. And recently we embarked into the creation of an AI medical device for lung disease screening, monitoring, and predictions. We use our breathing pattern. Every one of you breathe right. So your pattern of breathing can be a new biomarker for prediction, for asthma prediction, for COPD predictions, even to monitor other diseases that may affect breathing pattern is possible. And this project is in development. Okay. In ophthalmology, we have embarked into AI screening solutions to detect different degree of diabetic retinopathy. As I think as mentioned by one of the speaker, my Pengara. Okay. We have coordinated a project called Dr. Mater, which is an AI solution for diabetic retinopathy to enhance the screening capacity and early detections of diabetic retinopathy. And that model has been trained on more than 14,000 images from 7 centers. Okay, you use an object detection model and achieve more than 90% accuracy. Okay, currently it's being deployed in a selected primary care center for clinical validations. And also we are developing an AI online screening application to detect and differentiate different type of corneal ulcer. Okay, this project also is under development. Okay, you see, the potential for AI is beyond what we can imagine nowadays, because it's good at analyzing unstructured data, which in the past not possible to be analyzed and used. Okay, therefore it has already opened up another avenue for improving health services. Okay, so what is the future of AI in health service? Okay, I think the next thing we can expect is multi-modality AI, an AI system that can process, understand, and generate output based on different type of data. And this system integrates different type of data processing capability within a single AI system, enhancing the capability of AI to interpret output. This is so-called the next big thing in achieving artificial general intelligence. Okay, currently at this moment, we are still in between narrow AI and general AI. The ChatGPT generative AI are more toward general AI. And to close my presentation, I asked ChatGPT or Copilot a simple question: what is the future of AI in healthcare? You guys can do that, huh? Because you have access to ChatGPT, right? And this is the message I get. First, multi-modality AI. Second, personalized treatment. Third, timely prevention. Fourth, virtual health assistant. Fifth, AI, medical device or tool, and then real-time predictions and also informing. Okay, so this is the future of AI in service, given by the AI itself. I can't predict, so I asked the AI to predict. And with this, I would like to thank your attentions. Thank you very much.
I'm going to make a small announcement first. We're a bit overrun on time, but for the poster presentation competitions, we will proceed as planned at 11:30 in the Iskandar room. So can I get the 8 finalists for the original research posters and the 8 finalists for the case report posters to make a move over to the Iskandar demonstration theatre now? And also for the poster presentation judges, if you could make your way over to the Iskandar demonstration hall as well. For the 8 finalists for students also, you could make a move over to the seminar rooms 2.2. For students who are interested in watching their peers present in front of judges, you can also make your way over to seminar rooms 2.2. All right, with that, I would like to get Dr. Suhaila to introduce our next speaker.
All right. Thank you, Mr. William. So I understand that, you know, some of us, you know, we are in a clinic, KKM. I think what William has presented just now, it was very mouthful and very, you know, mind-blowing actually. We are at the receiving end, kan kita, we have a little bit of a problem of understanding about, you know, how to develop this AI and how to actually log all the data in and then get it done. So we're gonna leave that to the experts. All right. So the next expert, the next speakers, you know, we have brought all the way from Kuala Lumpur, Mr. Navindran, my guest warrant. So Mr. Navindran is actually a CEO from a Spark Developmental company. He is this young chap, you know. He has 13 years experience in a technology, and he has been very, very active in the NGO, both in NGO, government, and as well as a lot of other things. He is also involved in a lot of technology involving education, financial, healthcare, technology as well. So without further ado, you know, let's invite Mr. Navindran. Thank you.
Yes, thank you, Dr. Suhaila. Thank you. I got a scare earlier as everybody was moving. I thought we're just going to be left with a couple of people, but it's still full. So I'm glad. But I think this session would also benefit the students that left, but I hope you can share with your peers later on. I'll just go on to the first slide so I could introduce myself. My name is Navin. I am currently the CEO of the Center of Excellence for Extended Reality Technology and AI. We started including AI as one of our key pillars since last year. So extended reality technology includes virtual reality, augmented reality, mixed reality, and all this emerging tech. That's where it is. So the first 2 slides, I'll really just talk about our center. Been in tech in the last 12 years or so, working very closely with healthcare in the last 4 or 5 years. Just to check, so the Center of Excellence was something mooted together with the government of Malaysia in the year of 2017. So this was done together with EPU, Economic Planning Unit. So we have a base in Perak now that is going to be emulated to Melaka and Pahang real soon. And we have a satellite base in Sabah as well. So the focus is to really do R&D, come up with cutting-edge technology that uses the technology I just shared to create value for Malaysians in general, right? So that's where it is. So this is among the areas we work with. We started very small. We started with just focusing on visualization technology, but visualization technology is supported by big data, AI, IoTs, and then that came along the way. So the way we're going to do this presentation or the sharing today is really, I'm not going to go very deep into tech, but I'm just going to share our journey so far in how we have enabled the usage of this tech in real life solutions, real life practical areas. So that will give you a better understanding of where we are coming from, right? So sebenarnya semua ni ada animation, but I think I'm playing it, it's just coming out outright, so it's on your face immediately, but it's supposed to come out one by one, right? But yes, so I just want to share some of the areas that we are working right now, and this is in Malaysia, so it's local products that we are working in. One of the more advanced one that we are working in is called VHealth, where we use extended reality technology to treat mental health. And we were lucky that ICR, DHRI, the wonderful people here, Dr. Marina, Dr. Suhaila, Dr. Aizuddin, and Mr. William, were the strongest champion to ensure that we actually managed to do clinical trial in Malaysian government hospital. So we did in 5 government hospitals using virtual reality to treat mental health. The trial went very well, really good results out of it. So we are looking at how that's going to be scaled to other government hospitals and benefit a lot more people. So that's doing very well. But that's only possible because KKM opened, or more so this wonderful team opened their arm to receive new tech, which they had no clue at that point of time. And they learned so quickly. I think they all have a unit of VR now at home. Dr. Marina was one of the first to actually get it, and she's been testing it on her own. So when physicians do that, I think the gap of technology and physician just gets that much narrower, right? So that's one thing that we are very happy with. The second area that we use XR technology is on rehabilitation. So we've been trying that out. We're working with Perkeso now. How can we do remote rehab? So if you go to all these state-of-the-art centers that Perkeso has or anybody has, right? It's very expensive, few hundred million. But what do you do when you go home, right? Bila balik rumah, do you do your exercise? Do you do your rehab? And most of the time, you don't have the ways to do it. So you don't do it, so the relapse happen, and then the recovery time drop. So how can we increase the recovery time? Next is an initiative we work with University Malaya, BCare. It is how we want to reduce the usage of opioid over a long period of time. So you reduce that, we increase the usage of virtual reality to be a therapy. So that's being done. The other one also very interesting to Malaysia is called VH. It's a XR-powered aged care platform for our senior citizen. We all know where Malaysia is heading towards. We're going to have a large population of elderly people. And then these elderly people will need better quality of life. So VR is proven in many countries to offset dementia, Parkinson's for later stage if we deploy them well. So this is all have to be validated in local settings, and that's where we are very open to work together with ICR on these areas. And while we are doing all these different initiatives and hitting the ground, talking to psychiatrists, talking to physicians, one area that the feedback we got was that while we want to treat them remotely, one thing that the physician don't have eyesight on was their vitals. Right? So when I want to treat a patient on stress or depression or any other areas remotely, what I don't have is I don't have their standard vitals. I don't know their BPs. I don't know their temperature. I don't know their pulse. I don't know their BMIs. I don't know this. And how do I do better by connecting this? So what we did is we developed this smart kiosk or smart health kiosk called Sihat Express, which I will touch slightly more later, where it is a IoT-powered device, medical devices, is connected to the tablet, where if you go in, you can do all your vital checks, BP, pulse, SpO2, blood sugar. We are introducing blood cholesterol as well, and do your BMI. It sends all the vitals to your phone, to your app, so you actually can track over a period of time. So every time you go in, you can do that. So we're going to place this kiosk in office space free of charge. Right? So we are working with Perkeso to do that. We are already rolled out in few organizations. So pagi ke, petang ke, you take a toilet break, whatever it is, just go to the kiosk, you do a basic health checkup, you already got your vitals. Next week you get your vitals, right? You kind of have a pattern over a period of time. So when you see your doctor 6 months down the road, 1 year down the road, your doctor has a better understanding of how are you performing over the last 6 months or 1 year. So that's the area that we are doing. I'll share an interesting story about Sihat Express when you come to the Sihat Express slide. So I'll skip this portion because the people in front of me, you're all much more well versed about the current healthcare landscape. So who am I to share that portion? Right. So the topic that I picked when I was invited to speak was really to speak about precision healthcare, because that's something that we are really passionate about. And we feel that we are missing a huge opportunity by not tapping into this area, right? Precision healthcare essentially means giving the right care to each individual and to understand that there's no one size fits all. So I'll just draw an example that a study, a prominent consultancy from UK just shared, from US just shared. For every one beneficiary that takes the top 10 best-selling drugs in US, that dia dapat benefit. Top 10 drugs in US, he gets benefit. For every one person that gets benefit, there's 4 to 25 people that does not get benefit from the same top 10 drugs. But yet, those top 10 drugs are dispensed across every patient. So if we talk about expensive, that's expensive. We are giving drugs that is expensive, but it's not effective because patients' needs are different, right? So we don't have to go so much as far as US. That's pretty much here in Malaysia as well. But the difference is actions has been taken, right? So the UK very recently started their journey on precision healthcare. They are backing it with a 20 billion pounds planning to actually scale this up. So they started a program called Health for All. I'm sure many people here would be aware, where they want to get data sets or health data from 1 million Brits so that they can actually work on the model. So that's an area that they're doing that. So the speakers before me shared very much on digital healthcare and how it's impacting. So we will be sharing some examples of how it's being deployed and what are the impact. So today's presentation, I'll just touch 3 tech that we work with and the impact that comes from it. One of it is, of course, VR. That's the forefront that we were at. And then how we have incorporated AI into it. And last but not least is on the telehealth, which is the Sehat Express. So we'll just share 3 of this area for the presentation. So AI, Mr. William did such an excellent job going into the nitty-gritty of how AI is. It did seem quite deep, but not understanding how it works hinders or pushes away further from accepting how technology works, right? So probably one time, one session crash course tak cukup. I'm taking AI class every week, Thursday, with our counterparts from the US, and I feel like baru masuk sekolah, right? It's just so much to learn and know, right? But the key is how quickly we can put it into action, how quickly we can have small wins along the way, and how quickly we can get KKM to support this. So that's really where some of the battles that we are actually fighting, right? So AI, most of the things were shared from Dr. Mahesh to Mr. William and also Dr. Aizuddin. The essence of it is that it's going to make healthcare better by providing more intel or insights to the physicians and doctors to make better decisions, right? But on the other side, that we strongly believe is that AI will allow the rakyat or me, who's not a doctor, to take control of my own healthcare, right? So that I am also aware of my health current condition and I just don't rely on doctor per se. So that 6 months, once I had a checkup, the remaining 6 months, what do I do with my own body and my own health, right? That's where I think AI comes and play a big role. Next thing, of course, VR, our favorite topic. How many of you here pernah experience a VR experience? Can I see a raise of hand? Unfortunately, we did not bring a gadget here. This is the standard numbers. So imagine walking into hospital Kulim, right? Have you all been to Kulim? Right, I mean, Kulim is not that bad, Dr. Nadia, it's not here. It's not that rural, but it is semi-urban, right? So in hospital Kulim, we have been using virtual reality to treat patients who have issues with stress, anxiety, and depression, right? So that's how we can actually bring technology into one remote part of the country and actually start treating for a whole year. And then patients recovered, showed tremendous feedback out of it, right? So the talks about you need 5G, you need infra to be laid out, all there, but yet solutions can be deployed if we have champions like these amazing people who, despite all that, they fight through it, right? So makes our job as a private sector much more efficient. So VR is a very powerful tool for immersive therapy, education, training, and also empowering patient education. So currently in KKM, we are working with 4 different departments. So of course, we are working with digital health department with Dr. Mahesh. We are working with the psychiatric service department. Then we are working with the health education department under the division, and we are working with the technology development department, all talking about different elements of VR being used. So the education department wants us to use VR to teach about diseases. What is diabetes? What is heart attack? What is lung cancer? So using VR, you actually visualize that. So we're actually developing a module for them. The training department wants us to use VR to create better competent paramedics. In the time of emergency, how do you simulate that? So the high fiduciary mannequin that we have does not cut it in the next 10 years. So you need more combination of high fiduciary mannequins with AI and VR to make that whole learning experience much better. So we're doing all that, and we're doing all that on our own funds. It is everything that we are sharing here, everything that we have done is self-funded. So I just put it out there as well, so that we are hoping for KKM to open up a bit to spend as well, then the traction will become much faster. I mean, amazing people here understands our pain. So this was the one that we done a clinical trial, and it's already validated here in Malaysia. So there is proof it works with our local population. Since we have introduced an AI into it, we have also gotten it patent filed as well early this year. So while you are using a VR therapy, the back end will be able to assess how are you responding to the therapy. And what it can do now is suggest a better therapy if you are not responding to the existing therapy. So that's what the AI does. So the AI is capturing, for example, a patient comes in, we are doing a simple therapy, you're walking in the beach side so you can relax, but you're scared of water, right? So what it does is AI detects that you are actually getting more anxious with the environment that you're in. AI shifts the environment to be in a grass field that is more relaxing for you, right? So currently, who does that? Currently, the doctors does that. The doctors will be able to monitor that you are on a VR environment, you're on the lakeside, you are feeling anxious. The doctor will off the environment and open a new environment for you. So in the future, we have AI to be able to do that. So we have a patent filed on that portion, right? So very interestingly, oh, it works now. Okay, very interestingly, in 2021, the Ministry of Health wanted us to build a framework to move towards precision mental health care. That means we go towards therapy that we don't trial and error as much. We try to be as precise, and this is focusing on mental health care alone. So we did this framework for the Ministry of Health, whereby Malaysians in general, you access so it's VKase, it's called VKase because it's Italian Kase. You actually access the platform from your home if you have your own VR therapy, or you actually go to workplace, you have the gear, or in schools, local internet center, this is your MCMC, cyber cafes and all that. And then you also have the squad VKase that goes in trucks, in buses with the VR devices into the remote areas to provide the access. And then you have the other group, which is the therapists themselves. They actually use the platform to treat patients in hospitals and Mentari centers. So we got 2 groups that will be actually using VR to treat mental health. One, the users themselves, self-guided. They are not diagnosed with any mental illness, but they are stressed. I'm anxious. How do I get help? How do I get better? I don't want to speak to somebody just yet. I'm not going to speak to a psychiatrist. I'm not sick, but I still want to feel more relaxed. What do? I get onto the VR therapy, right? It relaxes you. It teaches you to breathe. It does everything a psychiatrist will do with you on your own. So the idea was to capture both of these and also integrate all the other registries like substance abuse, home abuse, suicide registry together, and we capture it into a main framework where we come up with precision mental health care. So this was proposed and shared in 2021. So we are still in a long way from putting the components together, but it's actually serving as our mantra. Every day we wake up, we want to ensure that we are able to deploy something like this. If it's not going to be in the Ministry of Health, this will be done on the private sector. It will be done either way, right? So if it's not going to be with government hospitals, then it will be with private hospitals, because we already have private clinics coming on board to use the second portion. So we are only waiting to deploy the first portion of it, where public, you and I, can actually benefit this on a larger scale as well, right? So when we say precision mental health care, what do? What we want to do is we want to be able to collect a comprehensive set of data on each individual, right? Where did they come from? Which sector are they from? How is their background? How is their history so far, right? Family history. And then we want to compare that person's data against hundreds and thousands of other data points. Why we want to do this? We want to be able to ensure that the machine learning model that we are building actually matches the right care for you, right? So how many times you have gone to a private hospitals and they run 20 different tests just to determine that it is actually a tonsillitis, right? I'm telling you this because last week I was in a private hospital with my son, and unfortunately, after running all these tests, they say it's tonsillitis. So tonsillitis bill was 1,500 ringgit. So in layman terms, sakit tekak 1,500. And all they gave us augmentin, that is 40 ringgit, right? So you are not be able to give that kind of care, right? So same with mental health, it gets much costlier. So I was shown the time sign, so I'm going to go slightly faster. So the next initiative that supports mental health that we rolled out is called, it runs on telehealth and mobile health. We call it the Sehat Express initiative. So the Sehat Express initiative actually is a smart health kiosk that has all these IoT medical devices and a telehealth where you can speak to a doctor anytime. So what we have done with this was, we want to be able to put this in every organization that has large users, universities, corporates, so that you can have a sense of your own health, have a detection on your current health. And we are providing this kiosk at no cost, as long as the organization is of a sizable size. Like currently, if we are looking at 700 to 1,000 size, then we provide this for you. So, and the usage also is free for now. Only when you talk to doctor, there's a charge to the doctor. So the interesting story that I told you at the beginning was that we have partnered with MEASAT on this initiative. So what MEASAT tells us is that in Malaysia, there's 2 million unconnected people that stays in the most remote space. So 5G, 3G, 4G, semua tak sampai. So what happens is MEASAT have their satellite running there. So they have about 4,000 villages currently have their satellite. So they have taken our kiosk together with them. We have deployed it in these villages. And since we have deployed it in these villages, we have seen our Pachi and Machi here on a daily basis comes to our kiosk, do the saringan, and talk to the doctor. So this is the epitome of digital health, because the whole federal government was so surprised that they can actually do it on their own. There's no one manning this, tak ada orang jaga. There's videos to show how you actually do your BP, do your glucose, do SpO2, do temperature. Of course, we did some training at the beginning, but since then, they've been doing on their own. So about 1 month back, 80 officers from federal government, MCMC, even KKM, KPM, Digital Community, semua datang melawat. How is this possible that is happening? Because they are communicating with our doctors from KL, right? So that's happening. So we have all this blood pressure machine, SpO2, blood glucose, weight machines, all IoT connected, so that when the doctor comes online, they actually see all these vital signs. So they'll be able to better answer them. Don't ask me how do you deliver medicine, because that's the next phase that we are doing. Because when I say this, always people say, macam mana hantar ubat, right? So ubat is always something that we are trying to work out. So this kiosk is not replacing your clinic. Emergency, tengah muntah-muntah nak pingsan, this is not where you go to, but this is where you go to for consultation right before your primary healthcare, right? Few more slides, I'm done. So we talked about data. So since the last 2 months we've launched it, we have seen the villages coming and testing more than 883 times across all the different devices, have done more than 16 teleconsultation sessions from a village that is at least 4.5 hours from KK, 1.5 hours from the nearest KK. KK tadi tu Kota Kinabalu, this KK is Klinik Kesihatan. So 1.5 hours. So the biggest challenge for the people here is something that we are not so used to. Because walaupun klinik tu 1 jam, tapi cost one way to go to the clinic is 70 ringgit. Kena sewa kereta, 4-wheel drive. Pergi balik 140 ringgit just to go to KK. So imagine there's a pregnant woman in this village who is going to do glucose and BP, but doesn't do it because the cost is too much for them to just do that basic. But since this is deployed, they're actually doing the whole thing in the kiosk. So we've been getting data. So we shared this data to the ministry. We've been sharing this data to digital ministry. So far, we have seen 47% at pre-hypertension. So as a private entity, our question is, I have this data. I already know this community is at a pre-hypertension now. In 3 months or 6 months, they are going to be NCD patients. How do we work together to intervene this? What kind of interventions can we do as a whole, as a community, to actually help them? Because this data is coming in from all villages that my kiosk is now. So what's the next step that we can do? So same with all the other areas. So actually,
sebelum ada ini kan, pemeriksaan tekanan darah saya sangat tinggi lah sebenarnya, tekanan darah tinggi. Tapi bila ada ini, pagi dan petang saya pergi periksa sini, dicek sini. Dan saya bercakap dengan dokter melalui online. Nah, bila saya mendengar dan buat yang terbaik, di mana itu nasihat ke dokter kan. Jadi sekarang tidak sudah tekanan darah tinggi saya sehat sudah.
That is her personal view. So she's the Ketua Kampung, one of the strongest proponent. So every 2 months once, we bring in the doctor from the nearest KK to go and support them. So that completes the whole loop. So the plan is to actually expand this to 200 villages, bringing on board 500 doctors to answer the calls and digitalize 1,000 clinics. So this digitalizing 1,000 clinics, MCNC has just given us a grant to bring on board the clinic. But all the other journeys, we still need partners, and we hope to work together with people here in Johor as well, because I think healthcare is across all. Unfortunately, I won't have time to go through all the other areas that I've prepared to share. So I will end it with that. Do not be afraid of the tech, right? It can be low tech, still have high impact. So embrace it when a private sector approaches you to have a discussion, because we are tech guys, we are not doctors. We want to work with you doctors to make the life of the people much better. So with that, I will end my session. Thank you very much. Thank you.
Thank you, Naveen. That was so enlightening, isn't it? It will be very great to have it if we have it in Johor itself then. But of course, I would like to address certain things, when we said about, AI going to replace doctors, AI going to replace paramedic, simply it is not true. I think, again, the message that comes cross over again and again here was that, AI is going to help us to make our works much better, and it actually going to help with patients' care. So, thank you so much to my Mr. Abstract, Dr. Aizuddin, to my fortune teller, the mathematician, Mr. William, to my technology guy, Mr. Naveen, for a very wonderful symposium. Unfortunately, we don't have time for Q&A. That is very unfortunate. because we have to move on to the next session. However, I just would like to summarize what we have learned today in this symposium. So, of course, digital technology is a very vast and a huge things that we have not explored yet in Malaysia, and we are still, how to say, we are still in a baby step. I don't think it's a baby steps, pun. We are just embryo lagi kat dalam tu. So we are still at a very premature phase, you know. We have introduced you guys to Dr. Aizuddin. We have introduced you to Mr. William. These are our research people, you know. So we can communicate if you have certain ideas on how to on research. Please tap to Dr. Aizuddin and Mr. William. Of course, we have our technology guys to actually help us as well in the development of research, and subsequently, you know, the mathematician would do his wonders, and of course all the innovation and the technology would take place. So this needs a lot of collaboration. So this needs the work of you guys, the paramedics and the medics. So thank you very much. Let's end our symposium in our way. Please give a hand of applause to our speakers. Thank you so much. So without further ado, we're going to move on to our next session. You know, this is a sponsored session by Novartis. I'm going to introduce you to Ms. Noel Wong. She's going to speak up on ethical collaboration in evidence generation. So Ms. Noel is actually a pharmacist graduate. Currently work with Novartis. She has a very vast experience in working in a medical field, and especially on a scientific education and research, particularly in oncology and hematology. So her main portfolio is in breast cancer. So without further ado, I think I would like to invite Mr. Noel Wong. This is going to be a video recording, video session, if I'm not mistaken. So let's proceed with the next session.
Hi, good day, everyone. I'm Noel Wong, the oncology medical lead from Novartis, Malaysia. Today, I'm going to speak about ethical collaboration in evidence generation. My disclosure here, I'm a full-time Novartis employee, been with Novartis for almost a decade, and have always been in medical affairs department. Novartis medicines are sold in more than 155 countries, and we have touched the lives of millions of people worldwide. Our program to promote access to medicine and healthcare, such as the Malaria Initiative, Healthy Family, and Novartis Access Program, has reached 66 million of patients worldwide. In year 2023, Y4 Institute had conducted a health and social economic analysis for Novartis, which quantify our social, environmental, and economic impact in Malaysia. In short, we call it SEEC. The monetization of the impact reflects the social value, allowing comparison of benefits and costs to society in monetary terms. So the finding has shown that Novartis International Medicine's total C impact last year is about USD 312 million. The total patients that we have reached is around 1.2 million, with a total quality of 11.6 thousand gained because of Novartis medicines. That's 1.9 times of social return on investment, ROI, which indicates that every 1 ringgit spent on Novartis medicines, it benefits the country economy by 2 ringgit. In Novartis itself, there's about 600 own FTE in terms of job security, and in total of 3,145 jobs secured in the country. The social impact of medicines demonstrates the added value brought by Novartis medicines to society, and it supports the paradigm shift to health as an investment. All this stems from the fact that Novartis being an innovative research company and the effort that we put in research and development. So let's take a closer look of Novartis biomedical research, in short, NIBR and IBR. What you're seeing here is a world map with 3 NIBR hubs of Novartis where drug discovery takes place. So we have 3 core hubs here located in United States, in Europe, and also in Asia. Novartis has an interconnected teams of over 5,600 scientists, physicians, and also business professionals working across the globe to solve some of the world's toughest health challenges. Globally, there's more than 20,000 experts and professionals working together, with more than 300 early discovery programs in the pipelines, about 160 projects in clinical development, and more than 20 advanced platform therapies. Now, all this inspiration comes from a common goal to continuously finding solutions and replace current standard of care by looking at disease area with high unmet need and the aspiration to be the first in class through research and development. Over the past 20 years, NIBR Lab itself has been enriching Novartis pipeline with new medicines in disease area with high unmet need. And I believe some of the molecules here would be familiar to you. These are the examples of Novartis drug approvals since early 2000 with the proof of concept bred and born from NIBR Lab itself. Taking a more granular look of what's happening in Malaysia, Novartis was awarded as top sponsors in sponsored clinical trial in Malaysia from 2015 to 2021. Collectively, up until this year, we are still the top sponsors in total of sponsored clinical trials that we have brought in to the country. With current 81 active ongoing studies globally, the estimated lifetime cost on all these clinical trials is estimated to be about USD 3.1 billion. That translates to Malaysian ringgit of 14.6 billion. And it is all with unknown success rate of the molecule compound. Drug discovery always comes with high risk, but also it could be highly rewarding if the molecule is successful. So if we look at the whole clinical trial journey from preclinical phase to phase 4, which is post-marketing approval phase, it takes us about average of 14 years with USD 2 billion that comes with 97% chance of failure. Most of the costs incurred during phase 2 and phase 3 experiments because of large sample expansions. There's a slim chance of 3% success rate for the drug to be proven effective and safe to the patients in real world. This number is not the most recent one, but we only expect that it actually will increase over time in tandem with the inflation. Therefore, we now start to see more and more innovative study design approach, not only to make the drug discovery more resource efficient, but also we would like to shorten the development time for the medicine to reach to the patients who are in need in the market. That also includes real-world data collections. One classic example that we have experienced recently is during COVID crisis when COVID-19 vaccines is being rolled out. In fact, there is now an increasing need for real-world evidence RWE due to various factors. Apart from the one that I've mentioned previously, there's also demand from payers to allow more evidence-based decision-making for drug reimbursement purposes, for patient-centric outcomes such as quality of life in real-world setting, and also to enable personalized medicine based on individual patient profile. In general, these are the 4 main types of RWE, studying either safety and efficacy of medicine in real-world setting, market access related initiative in the form of disease burden registry or health technology assessment, and lastly, also to look at patient-centered outcome, focusing on the need and the well-being of the patients. Now, let's take a look at what's happening in Malaysia. In Novartis, research is largely classified to either industry-sponsored, ISR, or IIR, investigator-initiated. For ISR, it is pretty straightforward. It can be either global sponsored study or a local sponsored study. And for IIR, clearly, it is a locally initiated study by our own HCPs. Regardless whether it is ISR or IIR, there's always an opportunity for local research collaboration. And to date, we have a total of 31 local studies ongoing or completed from different therapeutic areas. As you can see very clearly here, cardiovascular champion the number of local studies that is happening right now in Malaysia with a number of 13 studies, followed by oncology. We have 9 local studies happening. That includes both in solid tumor and hematology. And immunology, we have 4 studies, ophthalmology, 3 studies, and neuroscience, 2 studies. These are some of the examples that I extracted across different therapeutic areas, all looking at real-world data collection and in collaboration with various institutions, whether it is a single-centered study or a multi-centered studies, whether it is with MOH or with MOE, or it could be even through professional societies such as College of Ophthalmology. My MPN RWE is one of the most recent one, and also with relatively much higher sample population. This study is a non-interventional, both retrospective and prospective study design, looking at MPN patients in MOH across the country. This study is aiming for more than 2,000 patients of data to be recruited into this registry. So far, there's about 16 centers participating, with 13 of the hospitals approved by ethics committee already. The study is planned to run until 2027 with the aim to publish and establish the epidemiological data of MPN, understanding patients' characteristics and their treatment pattern. Now, here's another innovative example that I would like to share with all of you, and currently we are undertaking. It is a patient-centric real-world data collection through mobile app. This mobile app is called I Can Care mobile app. It is developed as a patient support app by a third party for cancer patients with the objective to empower our cancer patients with the disease knowledge throughout their journey. Information such as diet and lifestyle, drug-drug interactions, directory, and medication reminders are some of the key features of this mobile app. What is important right now is in this upcoming phase for this mobile app is to implement quality of life related survey through this app to the user and for them to respond. The data management system is fully integrated into this mobile app, and therefore it allows more seamless, structured, and effortless data analysis later on. However, what we have learned so far is that none of these research collaboration or RWE studies comes easily. It takes a lot of the effort to be at where we are today. And the key challenges that we observe are largely fall into these 3 main categories. Number 1, human resources. Number 2, data availability, whether it is a medical record or a paper record that we need to trace, and whether those information are being captured over time. And lastly, which I consider as the most challenging one, is the trust. Almost 99% of the time, a research collaboration involves multi-stakeholders engagement. The diagram here shows the key players in the world of research. We have industry, we have academic, we have patients, and we have society, which is known as public. Different party has different perspective and interests, and therefore making the partnership or collaboration in the form of research slightly more challenging. Therefore, it is actually very important for us to establish a climate of understanding and trust, especially when it comes to public-private partnership. Local institutions should really consider to provide and nurture an environment that encourages research integrity through education, or it could be through a clear policy guidance. One good example here that I would like to share with all of you is the Singapore Consensus Statement on Research Integrity. Now, this Singapore statement defines the global fundamental principles and responsibilities of researchers and those who involve should adhere to. The consensus statement highlights the need of high ethical and legal standards in research conduct, which certainly has helped to improve and create more trust in the public, among the patients, researchers, and even authorities. This statement actually was released in year 2010. So this is my final slide, and I just would like to wrap this whole presentation by saying that drug discovery is a long and challenging journey with high expenditure and risk of failure. Averagely, we know that it's about 3% of the molecules eventually will be successfully managed to enter into the phase 3 or even marketing approval. Therefore, real-world studies are very important in drug development process because they provide invaluable information that clinical trial couldn't. For example, safety and effectiveness, or even patient-centric outcomes in real-world setting. All these could facilitate evidence-based decision-making for reimbursement. We need to work out collectively to address the key challenges to enable us to conduct RWE more effortlessly and efficiently. Public-private partnership and research collaboration between institution and industry may be guided by different interests and perspectives, but it is a must for the advancement of medicine. With that, I thank you.
With that, we finished the morning session. We're going to proceed with oral presentation competition. We would like to thank Novartis for their for participating in Johor Research Day. By the way, before we start the oral presentation, I would like to actually sebenarnya terlupa. I would like to actually give a token of appreciation to our speakers. Mr. Navin, jangan pergi lagi. Hold on. All right. So I would like to invite Dr. Aizu, William, and Navin to receive the token of appreciation. With that, I'm going to pass the floor to Karen.
All right, thank you very much, Dr. Suhaila, for chairing the symposium just now. I will now pass the baton over to our wonderful team from CRC Hospital Pakar Sultanah Fatimah, Muar, to handle the oral presentation session.
Assalamualaikum warahmatullahi wabarakatuh. Perhatian kepada peserta oral presentation competition, sila pergi ke belah kanan dewan dan duduk di tempat yang kita sediakan. Ada tempat duduk yang kita dah label oral presenter, boleh duduk di sana. Terima kasih.
Attention everyone, a very good afternoon to all. Before we start our oral presentation session today, please note the following. We are thrilled to have our judges to sit in the judging area today, which will be assisted by our wonderful floor manager, Miss Amalina. And then for the participants, please make sure you are all ready at the left-hand side, my left-hand side of the lecture theatre, as we are going to take your registration list. And for the timekeeper, please take your designated seats as we will begin shortly. Everyone, please make sure that your phones are set to the silent mode in order to prevent any interruptions. And also, please be advised that the ongoing concurrent original research poster and case report presentations in Iskandar Demonstration Theatre and also Classroom 2.2 and 2.3 are not open to the public. So everyone, please remain in this lecture theatre to prevent any disruptions at the mentioned locations. Thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan salam madani. Ladies and gentlemen, distinguished guests and esteemed judges and also participants, a very good afternoon I bid to all of you. Welcome to Johor Research Day 2024 held here at the Newcastle University Medicine Malaysia, located in Iskandar Puteri. And thank you to all for taking your time to come here and join us today. And for those joining us virtually, thank you as well. Welcome to JRD 2024. And we are thrilled to have you with us. My name is Fatin and I am the member of the competition committee, and it is my honor to serve as the moderator for today's sessions. And today we have the opportunity to witness some of the most innovative and insightful research projects presented by our talented participants. And this event not only showcases their hard work and dedications, but also fosters a spirit of academic excellence and collaborations. So this year, our theme for JRD 2024 is transforming healthcare through digitalizations. As we continue to advance in the digital age, the integrations of digital technologies into healthcare is becoming increasingly crucial. This theme emphasizes the potential of digital tools and innovations to revolutionize healthcare delivery, improve patients' outcomes, and enhance the efficiency of healthcare systems. We are excited to explore how our researchers are contributing to this transformative journey. So before we begin, I would like to extend a special thank you to all the organizers, committees, and participants for making this event possible. Let's give them a big round of applause. And now it is time for us to listen to the oral presentation session in this Bailey's Lecture Theatre. Okay, so before we start, it is my pleasure to introduce our esteemed panel of judges who will be evaluating the presentation today. So please join me in welcoming the head judge, Datuk Dr. Ghazali bin Ismail, CEO of Pusat Dialisis Ikhlas Kota Tinggi. Datuk Dr. Ghazali is a highly respected figure in the medical community with a wealth of experience as the former head of Clinical Research Center at Hospital Sultan Ismail. His leadership and expertise in healthcare management have been instrumental in advancing medical research and patient care. Thank you, Dr. Ghazali, for being with us today. Next, welcoming Dr. Nurhaliza Muhammad Ali, consultant endocrinologist in General Medicine and Nephrology Department at Hospital Sultanah Aminah. Dr. Nurhaliza is the former head of CRC-HSA, and her dedications to patient care along with her expertise in medical specialties make her a valuable additions to our judging panel. Welcome, Dr. Nurhaliza. And last but not least, welcoming Dr. Hans Alexander Mahendran, consultant surgeon at Hospital Sultanah Aminah. Dr. Hans' surgical expertise and commitment to excellence in patient care have earned him widespread recognitions in the medical field. We are very honored to have you with us today. So thank you to all judges for generously contributing their time and expertise to this important event. So now let's go over the guidelines for the competitions. I think the participants need to be aware of these guidelines. So first, each participant will have 10 minutes to present their research. They will be supervised by our wonderful timekeeper who ring the first bell.
at the 8-minute mark to indicate that 2 minutes are remaining, and participants are advised to start preparing to conclude their research at this point. And the second bell will ring at the 10-minute mark to signify the end of the presentations, and following each presentations, there will be a 5-minute Q&A sessions. The timekeeper will ring the bell at the end of the 5 minutes, at which point no more questions will be allowed. So participants will be evaluated based on 3 main criteria. First, on the presentation content, which includes the introductions, objectives, methodology, results, conclusions, and also the overall impacts of the research. And next, on the presentation skills, which includes the clarity, delivery, and appearance, also mannerism. And last but not least, on the slides, which includes the organizations and visual appeal of the presentation slides. And our judges have been provided with a marking sheet consisting of each participant's name and the title of their research. Judges will use these sheets to evaluate the presentations based on the aforementioned criteria. This year, we received a total of 100 abstracts, out of which 30 were shortlisted for further considerations. And from these, 6 outstanding abstracts were selected for the oral presentations for the professional category. And we have a total of 6 presentations lined up for today. After the final presentations, our judges will be escorted to the judge holding room for marking calculations and to deliberate on their evaluations. Without further ado, let's begin our first presentations. Please join me in welcoming Dr. Zulkifli bin Zulkifli, Medical Officer from the Outpatient Department of Klinik Kesihatan Parit Raja PKD Batu Pahat, with his research title, Prevalence of Suspected Obstructive Sleep Apnea OSA among Diabetes Mellitus Type 2 patients in primary care health clinics and its associated factors. You may begin your 10 minutes whenever you are ready, and kindly reminder to abide with the time. The floor is now yours, Dr. Zulkifli.
Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Saya Dr. Zulkifli bin Zulkifli, Pegawai Perubatan daripada Pejabat Kesihatan Daerah Batu Pahat. So this is my colleague, Dr. Amir Ayuni, Dr. Sasi Kumar, and Dr. Logan Nathan. So my research title is Prevalent or Suspected Obstructive Sleep Apnea or OSA among diabetes mellitus type 2 patient in primary care health clinic and associated factor. So this is my introduction. OSA and diabetes mellitus have been shown to increase risk for cardiovascular disease. Among the non-risk factor for OSA is obesity, hypertension, family history of OSA, male smoking, alcohol, large neck, and lactose, heart and kidney failure. The gold standard for diagnosing OSA is to attend overnight level 1 polysomnogram or PSG. It requires the patient to be admitted overnight at a medical facility which has a sleep study center. The Berlin questionnaire is a validated instrument used to identify individuals at risk of OSA with a sensitivity of 86% and specificity of 77%. The sleep heart study, a community-based cohort study, observed a 58% prevalence of OSA among participants with type 2 diabetes. Similarly, in a subset of overweight and obese diabetic participating in the loop heart trial, the prevalence of OSA was over 86%. So my problem statement is more than 30% of Malaysian population have diabetes mellitus type 2, and most of them come to government health clinic for the regular diabetic follow-up. OSA is not routinely screened during diabetic follow-up due to lack of training, module times, and they often miss. Patients also are not aware regarding OSA, thus they're not complaining regarding their snoring problem. OSA can be screened using validated Berlin questionnaire. This study was conducted to determine the prevalence of suspected OSA among type 2 diabetic patients and its associated factor. So this is my objective. My general objective is to identify prevalence of suspected OSA among diabetes mellitus type 2 in selected health clinic in Batu Pahat district. So my specific objective, first, to identify socio-demographic or suspected OSA among type 2 diabetic patient. Second is to identify prevalence of suspected OSA among type 2 diabetic patient. And third is to find association between socio-demographic of type 2 diabetic patient with prevalence or suspected OSA. So this is my methodology. My study design is a cross-sectional study. My study location is at Klinik Kesihatan Perak Raja and Klinik Kesihatan Senggarang. My total sample size is 232. My sampling method is using systematic random sampling, and my data analysis method using SPSS version 29 with descriptive univariate analysis, univariate and bivariate logistic regression done. So this is my inclusion criteria. First, all type 2 diabetic patient with age above 18 years old. My exclusion criteria is patient with mental condition, illiterate patient, or patient not consented. My data collection tool using validated Berlin questionnaire. So this is my descriptive result, my demographic result. So for our study, predominantly female with 62%, predominantly Malay in race with 90.52%, predominantly have secondary school with 54.74%, predominantly are married with 95.26%, with 12.93% are smoker, with BMI with more than 27 is 35.78%, obese, with by average BMI numerical is 28.43 our mean. Hypertension, 92.24% have hypertension, and our results show that from Berlin scoring, 15.9% have suspected OSA. So then we've done a univariate analysis. From our univariate analysis, we done an ANOVA test. And from there, we found that gender have association for suspected OSA with p-value of 0.027. Race does not have any association. Education have borderline association with 0.058. Marital status does not have any association. Smoking does not have any association. BMI categorical does not have association. But for BMI numerical, we have association with p-value of 0.03. Hypertension does not have any association. So from there, we done a univariate and multivariate logistic regression. From there, we found that male have relationship for suspected OSA with p-value of 0.017. Education does not have any relationship for suspected OSA. BMI numerical have a relationship for suspected OSA with p-value of 0.008. And hypertension does not have any relationship. So from what we can learn from our study is that from the previous study, the sleep heart health study and loop head trial show prevalent or suspected OSA is 58 and 86% respectively. But from our study, we only get 15.95%, even after we take into consideration that our male participants are half of the female. And our study show the relationship that male are 2.5 times higher risk for suspected OSA compared to female. From my literature review, there is no other previous study show this relationship. Another good finding is that for every increase of 1 BMI, there is 9% increased risk for suspected OSA. And from my literature review, I do not find any previous study show this relationship. From our analysis also, education seems to have borderline association for suspected OSA, but no previous study showed this association previously. And despite many studies show association between OSA and hypertension, our study did not show any association between hypertension and OSA. So in conclusion, based on our result, we suggested for further study regarding this title should be done in a much larger population with more proportionate mix of gender and race. For the meantime, we would like to suggest for OSA screening to be done among diabetic patients, especially those with high BMI and male patients in view of constraint on time, at least for yearly OSA. Awareness regarding OSA should be increased both to health staff and public, and partnership between ENT team and primary care should be strengthened for better OSA screening and further management. In addition to this, I have another ideas. In view of our JRD theme today is digitalizing healthcare. So from Berlin questionnaire, we can digitalize it. They can calculate it, they can give the result whether the patient have high risk or low risk. So this can be easily done. So from there, it's like from there, the healthcare at the clinic consultant will know which patient have high risk. So they can just prepare the form to refer to the ENT team. So this is my references. With that, thank you very much.
Thank you to Dr. Solihari for your presentations. We will now move on to the Q&A sessions. Mic will be given to the judges for asking the questions. Okay, so you can test the mic first. Yes, it's a wireless mic. Okay, so now we will begin the 5-minute Q&A sessions. Judges, you may begin asking your questions.
Could I trouble you to go back to your results slide?
Sure. My result, okay.
The earlier part where you got a male, female part. Yeah, this one. Yes.
This one?
Yeah.
Yes.
So you realize here,
Mhm.
looking at your percentages,
Mhm.
your percentages are based on how many percent low risk are male and female versus the other way around, is it? I'm a bit curious.
So from from here, we can find that for men, for example, for the high risk, which let's show. Okay, so the male have high risk for 54%, 54.05% to develop OSA. Meaning that from the 15.9% prevalent for suspected OSA, 54% are male, and another 45.95% are female.
So the funny little thing is, usually when we present our data, how many percent of the males were high risk versus how many percent of the males were low risk. So this one's a bit funny the way you looked at it, don't you think?
Maybe I'm new in research, so I will accept your opinion.
That's just my comment. Don't stress. I'm
Okay.
not criticizing you.
All right.
So that was the first thing. So then with regards to your obese patients over here.
All right.
So BMI, the obese and non-obese, was it divided by gender? Did you look at it that way? how many percent of the males were obese and how many percent of the females were obese? Did you look at that?
From gender, because this is categorical, obese and non-obese. So we look whether non-obese are more highly to develop OSA compared to obese. But I did not divide within male and female. But if you suggest that, we can do a further analysis for that.
Because when you say that the males had a higher risk of being at risk, the question that will always arise is, were your male patients more likely to be obese than the females? Because OSA is very strongly tied to obesity.
All right.
Okay.
Okay.
It's good.
All right. Thank you.
Prevalence is low, is it, compared to the previous studies?
Correct.
Okay, why do you think is prevalence being low?
Okay. First, because our participants are predominantly female, with 62.07%. And smoking is also a risk factor to develop OSA. So with male lower compared to female, so the chances to develop OSA, for suspected OSA will be lower because the male are predominantly smoking. So, and we have a low participant from male.
I think it's due to your questionnaires.
Okay. May I know why?
Whether they understand the questionnaires or not.
Because
this Berlin questionnaire, is it being validated?
yes, it's a Malay, in English, and Chinese also available.
Okay, it's being validated.
Yes, correct.
Okay. This test, Berlin test, the
Yes.
sensitivity is about 77%, I think.
Yes, I can show.
Yeah, 70%. The sensitivity is about 87%,
Alright.
and the specificity is
Alright,
about 86%, sorry.
Yes.
87%, okay. Now you have been incident about 15.9%, okay. This is screening test.
Yes, correct.
We would like to, I was looking forward for confirmatory of your screen test to see their effectiveness. Okay? See your result based on your study.
Yes.
Yeah, okay. And but you have not validated with your confirmatory test.
Sorry?
Confirmatory test mean by the ENT, right? You don't have it, right? You are just doing a screening test.
Yes, correct.
Okay. So of all these patients that you had, which was screened to be positive, you sent to ENT clinic, am I right?
Yes, correct.
Okay. Do you have any news about what is the outcome like?
Unfortunately, I don't have time to follow up on that.
So it will be very good if you add something. Yeah, you add sugar to it so that it can become has more flavor lah.
Yes.
So screening test is, with the sensitivity and sensitivity about 86%, I would say it's not really very high lah. If you get a sensitivity about 99% and above,
Alright.
then it will be good. So we are looking forward lah. Maybe the next presentation you can show us about their outcome like from the NT, because you need to confirmatory test.
Yes.
Anytime we find that when we screen, when you do confirmatory test, it doesn't, the positive value is positive negative is bit low.
All right. Thank you. Thank you for all the judges. With that, I end my presentation.
Okay, thank you to Dr. Zolihari for the very enlightening presentation and for sharing your detailed research finding with us. And thank you to judges. Next, let's welcome our second presenter. Encik Muhammad Zulkifli bin Arfah Alias Asman, Assistant Medical Officer from the Hemodialysis Unit of Hospital Sultanah Nura Ismail Batu Pahat, with his research title, Factor Determining Level of Occupational Safety and Health, OSH, Awareness Among the Assistant Medical Officers in Hospital Sultanah Nura Ismail Batu Pahat. You're welcome to begin 10 minutes presentations when you are ready, and kindly remember to keep to the time. The floor is now yours.
Testing. Assalamualaikum and good morning for esteemed judge and all audience members. My name is Muhammad Zulkifli bin Arfah Alias Azman from Hemodialysis Unit Hospital Sultanah Nura Ismail. Today, I will present our research on a factor determining level of occupational safety and health awareness among assistant medical officers in Hospital Sultan Anura Ismail Batu Pahat. This study is a collaborative effort with my co-authors, Muhammad Aidil bin Musa from Satellite CRC HSNI, Sazuri Muhammad and Mulyadi Ahmad from Hospital Supervision Department HSNI. Let's begin our topic with an introduction. Sorry. Back macam. Di mana? Yes. The well-being of healthcare personnel and their ability to provide a superior patient care are directly impacted by occupational safety and health awareness within healthcare system. The study aims to assess the factor influencing level of awareness in occupational safety and health among assistant medical officers in Hospital Sultan Anura Ismail Batu Pahat. Literature review. Healthcare workers face various occupational hazards, including physical, chemical, biological, and psychological risk increased stress level, as noted by Frank et al. 2010. And effective OSH management measures are critical but often inadequately implemented, leading to high exposure risk, as noted by Muhammad Rose et al. 2021. In addition, the training program enhanced OSH awareness among healthcare workers, according to Dicieri and Lazarova 2021. Furthermore, organizational support significantly influenced OSH awareness and practice, according to Dicieri Al-Hassan and et al. 2018. The problem statement. The well-being of healthcare personnel and their ability to deliver high-quality patient care are significantly affected by their awareness of occupational safety and health risks. However, there is limited research exists on factors influencing OSH awareness among assistant medical officers in specific healthcare settings. Research objective. Our primary research objective is to determine level of OSH awareness among assistant medical officers. We will focus on key factors such as OSH training program, job roles, perceived organizational support, and self-reported workplace stress. Research methodology. This is a cross-sectional study involving 120 assistant medical officers in Hospital Sultan Anura Ismail Batu Pahat, as selected based on Christie and Morgan table. We use a structured questionnaire with a 5-point Likert scale for data collection. We use SPSS version 25 for data analysis, and we exclude other professions among healthcare workers and assistant medical officers work less than 6 months. The data collection was carried out from 1st July 2023 to 31st July 2023. Here is a flowchart illustrating the research process from the participant selection to the data analysis. On analysis technique, we use descriptive statistics for demographic data, regression analysis to determine predictors of OSH awareness, correlation analysis to explore relationship between variable, and ANOVA test. Here is result and analysis. For training and promotion, our analysis indicate a strong positive linear relationship between training and promotion and OSH awareness level, with an R value equal to 0.751. The training and promotion explain 56.4% of the variance in OSH awareness. For the job roles, our result indicate a moderate positive linear relationship between job roles and OSH awareness level, with an R value equal to 0.421. The job roles explain 17.7% of the variance in OSH awareness. For perceived organizational support, our result indicate a strong positive linear relationship between perceived organizational support and OSH awareness level, with an R value equal to 0.631. The perceived it explain 39.9% of the variance in OSH awareness. For the self-reported workplace stress, Our results indicate a moderate negative linear relationship between self-reported workplace stress and OSH awareness level, with an R value equal to, sorry, sorry. The self-reported workplace stress explain 34.9% of the variance in OSH awareness. Discussion for training programs, continuous education enhance OSH awareness. This is supported by Eldisuki et al. 2019 and Al-Hassan et al. 2018. For the job roles, some roles naturally demand higher OSH awareness. Customizing of OSH training for different roles improve compliance. This is supported by Risk et al. 2019 and Khalid et al. 2019. On organizational support, strong support enhance safety culture and awareness. This is supported by Desiri and Lazarova 2021. For the self-reported workplace stress, high stress reduce OSH knowledge. Emphasis on reducing workplace stress to improve safety awareness. This is supported by Al-Hassan et al. 2018 and Khalid et al. 2019. In a conclusion, continuous education is crucial. Customization of OSH training enhance effectiveness. Organizational support improves safety awareness. Increase workplace stress, reduce OSH awareness. Lastly, implication for healthcare organization. Healthcare organizations should invest in specialized training programs. Identifying and addressing job-related issues is crucial for improving safety. Promote strong organizational support. Manage workplace stress collaboratively. Last but not least, aim to establish a safer and healthier environment for healthcare professionals. Here is some key references that inform our study, including works by Desiri and Lazarova 2021, Al-Hassan et al. 2018, Frank et al. 2010, and Muhammad Rose et al. 2021. These references provide a robust foundation for our finding and conclusion. Thank you. Methodology. Tak boleh, back. Tak boleh. Dia macam loading. Ni live kan?
Tengok yang dekat sini.
Hello, testing.
No.
No, is it mentioned anywhere about the how was the questionnaire made actually? What was the questionnaire?
Questionnaire.
Questionnaire dia.
Oh, can I answer in Malay?
Yes, definitely.
Kita tak provide in slide ni. Sorry.
So the question is
Standard questionnaire. From UTM study. I take from UTM study for this research. Oh, kena mention sikit. Okay. Yes.
I understand that there are a lot of problems, right, at the working, right, at work regarding the environment, you know, workload, a lot of stress suffered. And I think what you have from your research, you have proven it. But it is stuck there, you know? It is stuck there. Reality that we face a lot of problems in our staff. And just to find finding about its existence is not enough.
Yes, not enough.
That's why
for
when I
the
look at your
short study.
study about 1 month,
1 month only.
it is not enough to deliberate something. You propose a lot of things, no?
Yes.
Whether it can be done or not. Okay. So the intervention is not there, no? It's just an observation. Okay.
Yes.
It is. I would say it's a half-work job, lah.
Yes.
Okay.
Not
I would
complete.
really look forward for something interventional. You have found the findings, and then what you should take it. They're just findings remain findings forever, or you have to be for betterment. So I think if you can go forward, to explore in this, that will be very promising. To look into whether it is workable or not workable. Sometimes what you display your suggestion A, B, C, D, E.
Yeah.
Sometimes it cannot be taken up by the managers, right? And then the story continues till ... which means don't know when. Okay.
No end up.
No ending story, right? So it will be good, when this kind of awareness and then continue with some outcome.
Yes.
As I noted from the first presenter, we don't see the outcome. You screen, but then we don't know how effective your screening. We need to confirm screening with the kind of sensitivity, specificity is not really good. You need to do a confirmatory test so that we can know false positive, false negative on the screen test before you embark on that system. Because you can, when you do screening and you got the result, and then you do you got awareness, you screen. You're screening, the awareness, and you found that is the result. And then what's next?
Just in general research.
So it's just a findings.
Yes.
So that's my comment.
Okay.
So your application of the questionnaire, semua ni berdasarkan ada tak apa-apa aktiviti awareness sewaktu kawasan ini? Did you do any activity? Just
study activity, just questionnaire.
Just tanya aja lah.
Just tanya
apa
je.
dan sebagainya. So that was the thing you did. Okay, thank you.
Sorry, sir.
No,
Thank you.
No need to apologize.
Okay. Okay, thank you everyone.
Thank you to Encik Zulkifli for the great presentations. Okay, so next, let's continue with our third presentation. Please welcome Ms. Lim Ailing, the pharmacist from the Pharmacy Department of Hospital Pakar Sultanah Fatimah Muar, with her research title, A Cohort Study of Virtual Counseling on Patients' Medication Understanding, Adherence, and Satisfaction. You may start your 10-minute presentations when you are ready, and please be aware of the time constraint. The stage is now yours, Ms. Lim.
Afternoon to all the audience and judges. My name is Lim Ailing. I'm from Hospital Pakar Sultanah Fatimah. So today I would like to talk about a research with title, A Cohort Study of Virtual Counseling on Patients' Medication Understanding, Adherence, and Satisfaction. We are recovering 6 topics today, which are introduction, objective, methodology, result, discussion, as well as conclusion. So let's start with introduction. What is Virtual Medication Counseling Service, or in abbreviation, VMCS? VMCS, or known as telepharmacy, where you can see from the picture, is a virtual, interactive, live medication counseling between pharmacist and patient with the use of suitable communication devices such as
smartphone, or laptop. It was introduced in 2021 by Ministry of Health, and it is made available to those who are unable to physically attend the counseling session. Through the literature review, VMCS show high level of acceptance from public and healthcare professionals in local Malaysia studies. In addition, in overseas studies such as in Thailand and Philippines also show improved patient treatment outcome, such as in patients' medication understanding and adherence. However, there are currently no local studies on patient outcome, and that's the reason we choose to conduct the study. There are three objectives in our study, where first is to determine the social demographic and type of medication or devices counseled among respondents receive VMCS, to study the VMCS outcome on their satisfaction level, medication adherence and understanding, and third is to investigate the association between social demographic with the VMCS outcome. Next is the methodology. Our study was a retrospective cohort study conducted in Hospital Pakar Sultanah Fatimah. Our study population are all patients and their caregiver who have previously received virtual counseling on their medication or devices. Sample size we calculated using Russell calculator with confidence interval setting at 90% and margin of error set at 10%. We have recruited a total number of 69 subjects. Statistical analysis, we did it with IBM SPS Statistics version 25. And when we tested our data with Shapiro wheel, we found out that our data was not normally distributed, and hence we use chi-square and non-parametric tests to analyze our data. There are three study instruments where we use to assess our three study outcomes that I mentioned just now under objective 2, which is first, DFID, where we use to assess respondent medication understanding level, MyMAT, where we use to assess respondent medication adherence level, and the satisfaction level of the respondent was determined with a Likert scale adapted from a study conducted in Thailand. Let's move on to the result. For the result, I will present in accordance to our three study objectives, where first we look at the social demographic distribution of our respondent. They have a median age of 36 years old. Majority of them are Malay, female, had a secondary educational level. For the type of medication or devices counseled, majority of them were virtually counseled on anticoagulant, followed by insulin, inhaler, and lastly others such as nasal spray or Fortrans. When we look into the three VMCS outcome, our respondent has a median satisfaction score of 4.5, median MyMAT medication adherence score of 56, and lastly, median DFID medication understanding score of 100. For the three VMCS outcome that have been mentioned just now, I would like to highlight there are only three variables that are significantly associated with the satisfaction level, which are age, gender, and inhaler. And for the medication adherence and medication understanding, there are only two variables that are significantly associated with it, which are anticoagulant and insulin. Here come to the discussion. For your information, under the discussion, I will highlight those variables that have significant association with VMCS only due to the time constraint. And for the discussion, I have divided into two parts. For the first part is about the satisfaction level, where remember I have mentioned there are three variables that have significant association with it, which are age, gender, and inhaler. So we will elaborate one by one. First, we look at the gender. Younger respondent who aged 18 to 30 years old was reported to have a better satisfaction level than older respondent who aged 61 years old and above. This was similar with the finding conducted by Orange et al., where their younger respondent also reported a higher satisfaction level. So why younger respondent reported a better satisfaction level? It might be due to the amount of exposure to the technology in different age group, where younger respondents tend to be more familiar with the newer technology and hence more aware with the newer service that has been offered. Besides that, it might be also due to the perception of the older population, where they are less likely to think that the healthcare purpose can be achieved at a distance. Second, when we look at the gender, we found that female respondent was reported to have a higher satisfaction level, and this was supported by the study conducted by mentioned et al., where you can see their female satisfaction score was higher than their male. Lastly, unexpectedly, we found that those who were virtually counseled with inhaler tend to have a lower satisfaction level, and this is because, as according to XLS, there are critical steps in inhaler technique which require pharmacy to teach about face-to-face counseling. For the second part of the discussion was about the medication adherence and understanding, and there are two variables that are significantly associated with it, which are anticoagulant and insulin. And we look at anticoagulant. Interestingly, we found that respondents are 3 times more likely to adhere, but medication understanding level was only moderate. Our study finding was different from the one conducted by Senon and Zhang in China and Japan, where they use a smartphone app to provide virtual pharmaceutical care to patients, and this has shown improved patient adherence and awareness score. So why there is a differ in the finding? It might be due to majority of our respondents was virtually counseled on short-term parenteral anticoagulant instead of long anticoagulant therapy as reported by Senon and Zhang. In addition, we conduct virtual counseling service via phone or video call instead of a virtual app. Lastly, insulin, we found that those who were virtually counseled on insulin was less likely to adhere, but surprisingly, you can see their medication understanding level was satisfactory. Our study findings were similar with the systematic review done by Ifnik et al., where a review of 8 articles about the implementation of telepharmacy among the diabetic patient, 3 of them did not show significant impact on adherence, and also the study conducted by Mistral, where 74% of their respondents was able to follow insulin injection instruction as assessed after 2 weeks of tele-education. The reported low adherence level towards insulin might be due to 2 reasons. First is the insulin itself. It is a medication that requires regular education and follow-up to improve patient treatment outcome and adherence, either physically or virtually, especially for those with multiple insulin injection. In addition, in our study, we only provide one-time virtual counseling session to patients prescribed with insulin without any subsequent virtual session. So in brief, I would like to highlight VMCS should focus on specific population as multiple factors influence the service quality and counseling outcome. VMCS in hospital MOA currently limited to discharge after office hour, and COVID patient, it should be expanded to others like youngster. Follow-up session should be implemented among those counseled with inhaler and insulin. And before I end my session, I would like to say that all in all, strategic planning is essential to ensure virtual medication counseling service quality is on par with face-to-face counseling. Thank you for your attention.
Thank you, Ms. Lim, for your presentations. We will now move on to the Q&A session. Judges, you will begin asking your questions.
Hi. With regards to the patients being selected, because this one retrospective, isn't it? What sort of patient normally you all will select for which one?
We set our inclusion and exclusion criteria. So we will include those who have 18 years and above adult, and then those who was virtually counseled previously was virtually counseled on the medication. So like that, and then we exclude who don't understand Malay or English, who have cognitive impaired abilities, and those who reluctant to participate in our study. This is how we select our participants.
Okay, but this is retrospective, isn't it?
Yeah, this is retrospective, yeah. But this one retrospective, sorry, I don't get what it means.
How do you know that the patient will not agree to participate when this is retrospective?
This one actually is like that. We first identify our patient through the PHIS system, right? And then we noticed that they have appointment in HPSF, either doctor appointment or they come to collect the medication. And then according to our inclusion and exclusion criteria, then we found out that if they fit our inclusion and exclusion criteria, then we'll approach the patient and then we ask them whether they are agree to participate in our study or not. If they agree, then we let them fill in the consent form. Then after that, we access face-to-face for the medication understanding, and for the medication adherence and satisfaction, we ask them to fill in the form, the collection form.
Can I just look at the methodology again? Sorry, I'm more confused now. Retrospective cohort,
retrospective cohort study.
Was the patient being seen by the same pharmacist or?
No, not seen by the same pharmacy because it's a retrospective cohort study, right? So we cannot actually set which a pharmacy, a particular pharmacy to see the patient. So we will just.
But you get consent, retrospective, but you got consent.
We get consent, yeah. We got consent from the patient. That means actually there are patients that have been previously counseled, right? So we approached them, but because we couldn't call them because due to the ethical issue, right? So we recruit them by like, we noticed they have the appointment, then we approach them, we ask for the consent first before we collect their previous data, their previous, like ask them how was your last experience with the virtual counseling, whether you understand medication or not with the defeat score. The defeat, the one I mentioned just now for the medication understanding.
So it's not retrospective, right?
Retrospective mean you already started the visual.
Yeah, already started the virtual.
And then you are now asking the patient the feedback.
Yeah, the feedback, yes.
Right.
Yes.
And then when is the question coming out? The questionnaire.
The one actually we don't use questionnaire. We just use the study instrument.
Instrument.
Actually we have.
Which means you have already implemented the visual monitoring, the counseling method. Am I right? You already started it.
Yeah. I already started it.
And then you start seeing the result.
I start to see only see the result. Yes.
Okay. And then you have the instrument tool to see whether.
Yeah. Yes.
That's what it means.
It's a bit confusing lah. So yeah.
You can just always rephrase. The other thing I want to ask you, you have so many variables, satisfaction and compliance. But can you tell us, you are talking about satisfaction or unhappy? I feel better. But in terms of compliance from your study, because so far there was no such study done here, am I right?
Yeah. No such study done in Malaysia.
So in terms of their compliance and the outcome, do you make any comparison?
Sorry, I can't.
Do you make any comparison? No, you are.
Comparison.
Yes.
The one we plan actually, we did it like because our sample size also limited, right? Yeah, because it's a district hospital and actually it's not a known. So
no, I mean is that this is nice sample. You can always look at the end of the result, outcome.
Okay.
You only look at the satisfaction, but the outcome does it help in terms of the outcome of the patient, compliance. That is your indicator actually. Your last indicator for it.
We do study the medication adherence and understanding.
It's okay. It's a good study at the start, but don't end there. Right? Okay. Don't end there. Because why? A lot of the project I've noted for many years. I was involved in CRC for the last 20 years over. Right? Okay. And I found that it always ends there, it's stuck there. And then the next time, the next event, it just dies off. And they cannot move. So most of the citizen study cannot move forward because it ends there. Just an observation without, something like that. Okay.
Thank you. Thank you to the judges and thank you to Ms. Lim for the wonderful presentations. So now let's move on to our fourth presentation. Okay, our fourth presentation is by Dr. Fariha binti Ishaq, Medical Officer from the Surgical Department of Hospital Mersing. Please join me in welcoming her with her research title, A One-Year Experience of Colorectal Screening in a District Hospital. Are we there yet? You may commence your 10-minute presentations at your convenience, but please be mindful of the time.
Bismillahirrahmanirrahim. Assalamualaikum. I'm Fariha. Will be presenting. My topic is 1-year experience of colorectal cancer screening in a district hospital. Are we there yet? So disclaimer, this is a self-funded retrospective audit, no sponsors and no conflict of interest. So why did we choose this topic? It's because, as we all know, colorectal cancer is the most common cancer in male and second most common cancer in female. And the predominant age is, and the predominant age is more than 50 years old for both gender. So based on National Strategic Plan for Colorectal Cancer, the aim is to raise screening rate for this target age group from 10.8 to 40% in 2030. So why does we need to screen this patient? Because colon cancer is actually preventable and treatable if we manage to detect it earlier. So how do we screen? So we screen basically first via immunococcal fecal blood test, or we call it as IF4BT. If IF4BT is positive, then we proceed with colonoscopy, which is the gold standard. So how does colorectal screening being done in Mersing? So basically we work in tandem with the Pejabat Kesihatan Daerah Mersing. So this healthcare worker will distribute the I4BT kit, and if it turns out to be positive, they will counsel for colonoscope. And if patient keen for colonoscope, they will be referred to surgical department, and we will then recounsel the patient and prep for bowel prep. If patient really keen, then we can book the date for colonoscope in HSIJB. So what's the issue here? The issue here is that there is no licensed officer inter-department. So we as a in-hospital nursing are unable to trace the result from the HSIJB. So we don't know if the patient is defaulted or the colonoscope is being postponed due to poor bowel prep or the result of is it malignancy or polyp or just hemorrhoid. So why is it important for us to trace the result? This result is because there is a study shown, they say that if I4BT positive, the follow-up for colonoscopy must be within 10 months. If it is more than 10 months, it associated with a higher risk of colorectal cancer and more advanced stage disease at the time of diagnosis. Hence, we decided to proceed with this study. So this is our method. Our method is a retrospective study involving Pejabat Kesihatan Daerah Mersing and Hospital Mersing. We took the time from January 2023 to December 2023. The inclusion criteria is patient asymptomatic, age more than 50 years old, keen for screening. And the exclusive criteria is those who not underwent non-communicable disease screening. So this is the result that we get. So around 709 participants, 18% presented with positive I4BT. And around this 18%, only 46 agreed to underwent follow-up for surgical department clinic. And from the 46.9%, after we recounsel for the colonoscope and bowel prep, only 20% agreed for colonoscope. And then we trace the result from HSIJB, turned out 23% defaulted follow-up. So we don't know what is the causes for them to default follow-up. And 15.4% turned out to be malignancy. So back to the discussion. As earlier I told that National Strategic Plan is to raise the screening rate from 10.8% to 40% in 2030. So are we there yet? In rural area, Mersing. So let's calculate together. So based in 2030, population 2023, population Mersing people aged 50 years and above is around 15,800. And we managed to screen around 709 patients, making a total of 4.48% screening for colorectal cancer done in 2023. So are we there yet? Actually, we are not there yet, but much more percent compared to the initial screening rate, which is 10.8%, but we managed only to get 4.48%. So we are not there yet. So we would like to know what is the causes, why we are unable to reach the screening target for this patient. So barrier resulting in the delay or defaulted follow-up can be actually divided into 4 issues. We got logistic issues, poor inter-hospital communication, psychological and ethic of healthcare workers. So main issue is logistic issue. Would like to remind of all of you, in nursing, basically those who age more than 50 years old, they tend to live with their partners, and the children usually are outside of nursing, because the work chance, the job chance there is not much, so they have to go outside. So they tend to live with partners and not with their partners. So what is the issues here? First of all, because of age, they may be 75 years old, 80 years old, patient presented with positive I4BT, and they need to be sent to HSIJB. Because of old age, some of them unable to have transport issue. So because transport issue, they don't want to go to HSIJB for colonoscope. Other than that, if they got child to send to HSIJB for scope, they tend not to go because of the cost issue. You also got transportation and also the accommodation to stay. Next is the poor inter-hospital communication. Basically, the pejabat kesihatan daerah and hospital nursing, they lack of communication, in which PKD will only refer to us, the I4B positive, if patient keen for colonoscope. If they don't keen, then they will not refer to us. Second issue is that from the hospital nursing to hospital HSIJB, we are unable to trace the result in view of there is no licensed officer in between department. That is the psychological issue. Basically, we divided into 2 issues lah, before and after. Before, regarding I4B screening, some of them elderly did not keen for screening in view of they are asymptomatic. So why bother to do so? And second issue is after positive I4B, need to proceed with colonoscope, but they don't want to proceed with colonoscope in view of perception lah, scared about the complication, and also because they have to expose certain parts of the area where they need to insert the scope, so they don't want it to happen. And then the ethic of healthcare workers, in which the healthcare worker does not work hard enough to actually trace the result and also call the patient who defaulted. So basically, the solution that had been implemented post-study. So we worked the study in January to February 2024, and because of this poor result of the screening, we immediately come with solution lah for the study. So we did an I4BT nursing, which is a hospital nursing have a licensed officers with clinic kesihatan from all clinic kesihatan in hospital nursing. So if I4BT positive, they will immediately put in Google Sheet, and the licensed officer will give the date for surgical follow-up, and then the date for colonoscope, and then if the patient come defaulted, then the clinic kesihatan have to call back. If not, what is the result of colonoscope? What is the HPE result? Basically, that is what happened since February until now. And second solution is that we did cancer awareness. It's not a fun run, it's a fun walk, because we involve also the elderly. So it's just around 3 kilometers, but it's just a starting point for us to actually inform and explain to patient regarding this colorectal cancer. And the most important thing, and the one that we are really grateful after this study, is that we managed to get scope for this patient for hospital nursing. Even though it's just an old scope, already 9 years being used and then been passed down to hospital nursing, but we still managed to be used lah. Initially, we planned to be used 1 OGDS and 1 colonoscope patient. However, due to high request, so sometimes need to around 3 to 4 scope lah. Initially 1 to 1, but extend up to next year. So we just compact the name. So what is the strength, limitation, and future direction for our study? Basically, after the study and after we implement the solution, we noted that our strength is we do have endoscope and we do have resident specialists to help in enhance the screening of colorectal cancer. However, the weakness is that I4B kit is not enough. Basically, I4B kit is only being given to those patients who went for non-communicable disease center, and that is when we screen patient who keen for colorectal cancer screening. And then manpower. Basically, in hospital nursing, we got only 1 scrub nurse who know how to actually manage the scope. So this 1 scrub nurse have unable to actually have a good rest lah, because got some emergency scope and elective scope some more. And the third issue, we got blood product. The blood product only pack cell available in hospital nursing. We got no platelets. So if the patient have low platelets, they have to be sent to HSIJB to proceed with colonoscope. So what is the future direction of this study? Basically, after we with the presence of endoscope resident specialists, Together with improvement of the weakness, we would like to re-audit in 2 years' time to look the efficiency of the colorectal cancer awareness screening. And then we would like to integrate with healthcare clinic system, is that possible to general screening for the patient above 50 years old, not only for non-communicable disease center. So for the conclusion, the aim for National Strategic Plan for colorectal cancer has not yet been achieved. Instead, it is much more lower. So we think that endoscope is needed in rural areas. Why? Because most of the elderly live in a rural area. So easy access to colonoscope causing early diagnosis and early treatment. And joining effort between primary healthcare and surgical team is really important to improve the quality of the patient. Thank you.
Thank you to Dr. Fariha for the presentation. We will now move on to the 5-minute Q&A session. Judges, you may begin asking your questions.
So quite well done. Problem is your title is actually Are We There Yet? Actually, so your title doesn't really reflect all the nice work you've actually done. So maybe that's but otherwise quite well done.
Yeah, I agree with Mr. Han regarding your finding. It's just that this is an early findings, right, about the screening test for colorectal cancer, right, in district hospital.
Yes.
Okay, all right. Now, what you were saying is that about the causes of this patient, because your pickup is quite low, right, about 5 point something, right? Okay.
True, boss.
Okay, and then and you seem to be stipulated due to A, B, C, D, patient doesn't want to graph the other side. But it's just, is it a hearsay or you have numbers?
This one,
Or your presumption?
No, it's not presumption. When we meet patient at the clinic, usually we counsel patient for colonoscope and bowel prep. So most of them.
I understand. What I'm saying that the one that you've been telling us about the reason why people don't come for screening is due to A, B, C, D. Do you have the numbers or it's just a presumptive?
We have no numbers.
You cannot. If you would do that, I don't think you will find the root cause of problem. For us to do a root cause of problem analysis, we need to produce facts. When we do research, we talk about facts. Fact means numbers.
Okay.
Right? Number means how people out of the 69 patients, am I right?
790.
Quite a number of patients you have
quite a
screened.
number.
Okay? Out of this number of patients, how many of them actually due to transport problem? How many is due to this? How many is due to that? When you know the main cause, which is manageable, there are things you cannot manage. For example, patient who are recalcitrant, refuse to. It's very difficult. But if you can manage the other numbers, for example, due to awareness, you have done the awareness, you have done everything. And if you want to look at the root cause of problem, then you have a better result. That's what happened to us when we tried to improve screening for cervical cancer. Okay? We failed. We didn't really look at the root cause of problem. It's all about discussion due to A, B, C, D, E. But when it comes to the exact numbers, we don't know. So when we do an analysis, right, about the numbers, then we know how to tackle this group. So that's my suggestion to you, how to improve your screening. Okay. Otherwise, you will not achieve what you wanted.
I think yours more of like a clinical audit, isn't it?
True.
Because there's, you analyze, after that you make some changes. So the limitations, probably you should mention about this being retrospective or this kind of thing, rather than limitation. The way, I think you have to learn how to identify the limitations, not, I mean, the way you present it is more like an audit, I think. Yeah, like.
Thank you.
Thank you to Dr. Fariha for the amazing presentations. Now, let's move on to our fifth presenter, Dr. Lau Zi Hao, Medical Officer from the Radiology Department of Hospital Sultanah Nora Ismail Batu Pahat, with his research title, Intra-Abdominal Injury Requiring Computed Tomography CT Imaging, a Retrospective Descriptive Study of Injury Pattern and Outcome. Dr. Lau, you can begin your 10-minute presentations whenever you are prepared, and friendly reminder to stay within the time.
Good afternoon to the judges and audience. I'm Dr. Lau. Today I present my research topic on intra-abdominal injury requiring computer tomography, CT imaging. This study was conducted in Hospital Sultana Nora Ismail, HSNI. In this study, we are looking on the injury pattern and clinical outcome in our local context. Traumatic injury poses significant healthcare issue, often leading to hospitalization and in severe cases mortality. In Malaysia, motor vehicle accident is the most common contributor to trauma cases. Traumatic intra-abdominal injury is particularly concerning because it is often associated with mortality. The injury pattern can be single or multiple organs affected. Imaging, particularly CT scan, is useful to detect the injury, grade the injury, and subsequently guide the management. Early and accurate clinical diagnosis is important to provide effective management and to improve patient outcome. Looking on the previous study, abdominal trauma is the third most common injury after head and extremity. Previous study by Larson et al. In 2022 mentioned that 6.2% of the trauma patients sustain intra-abdominal injury. The most common injured organ is spleen. Suspected blunt intra-abdominal trauma is defined as any patient requiring exploratory laparotomy or computer tomography of the abdomen and pelvis during in-depth admission. As mentioned just now, grading is used to estimate the severity and also to guide the management. Focal assessment with sonography for trauma fast scan is a quick initial bedside tool for assessment. However, it shows variable accuracy. CT by far is the gold standard for stable patients with a reported accuracy of 84 to 100% by Karim et al. In 2020. Nowadays, conservative management is gaining much popularity, especially for stable patients. However, surgical management is still needed for those patients who are unstable or sustain severe injury. Previous study by Daniel et al. In 2012 mentioned that less than 20% of cases with intra-abdominal injury in CT scan require surgery. The average length of hospital stay is between 12 to 16 days, whereas the mortality rate varies between 10 to 36%, depends on multiple factors such as facilities. Our study aimed to describe the CT finding of patients with traumatic abdominal injury and also study their outcomes. We specifically describe the CT findings, determine the prevalence of organ involved, assess the role of fast scan, as well as evaluate the clinical outcome. To achieve our objective, we formulated a few problem statements or key questions. We wanted to know what is the proportion of patients with suspected intra-abdominal injury with positive CT finding, the distribution of different organ injuries, the overall clinical outcomes, as well as the accuracy of fast scan. To answer our research question, we conducted a retrospective descriptive study at HSNI. Our study population involved the trauma patients who underwent CT abdomen in 2021 and 2022. We employed a convenient sampling method in which all eligible data were included. All the data collected was then recorded in a medical record review form. For our data collection process, we start off with identify the cases through the CT report in the radiology department HSNI. Subsequently, we look into their medical record and gather the necessary clinical data. All the patients 18 years and above with suspected traumatic intra-abdominal injury with CT done prior to intervention are included in our study. For those with no CT scan performed prior to surgical intervention, those OR in charge or transferred to other hospitals for further management are excluded. After we collect the data, we review back the CT report to ensure the consistency of our data, and we do a final data cross-checking to measure the completeness of our data. We gather a total sample size of 124 cases. After the data collection, we transcribe the data and we analyze the data using the descriptive statistics to uncover the pattern and trend before our eventual report write-up. Moving on to our finding, out of the total 124 cases, there are 63 of them show positive CT finding of 50.8%. Additionally, there are 2 patients with reported negative CT finding underwent operation, noted the patient to have a small bowel injuries. We also noted that there's 2 patients with reported CT finding of grade 2 liver injury underwent operation. Subsequently, noted the liver is normal with no sign of injury. Hence, we come to our sensitivity and specificity of CT in diagnosed intra-abdominal injury in our cases to be 96.8% and 96.7% respectively. For the 63 patients with confirmed intra-abdominal injury, 38.1% of them treated surgically and the remaining are treated conservatively. We also noted another 30.2% of patients with proven intra-abdominal injury to sustain intracranial bleed. For the management and outcome of the patient with intra-abdominal injury, for those who are treated surgically, 3 or 12.5% of the total 24 patients passed away due to polytrauma, whereas for those who are treated conservatively, only 1 or 2.1% of the total 39 patients passed away. The cause of death is aspiration pneumonia. For the fast scan, there are a total of 122 patients out of the total 124 cases we have has a documented fast scan performed. Among them, 58 of them show positive fast scan, 64 show negative fast scan. For these 122 cases, 62 of them has a positive CT finding, and 38 of them also show positive fast scan. For those with negative CT finding, which is a 60 cases, and there are 40 of them show negative CT finding. Hence, we come to a sensitivity and specificity of for fast scan to be 61.3% and 66.7% respectively, whereas the positive and negative predictive value is 65.5% and 62.5%. For the organ involved in our cases, most of our cases involve the spleen and liver as the source of injury, making up 29.5% and 24.4% respectively. This is an example of grade 2 liver injury and grade 4 and grade 2 spleen injury in our cases. The grading of injury in our case, so we use the AAST classification. This classification is used to analyze the liver, spleen, and kidney injury in our cases. The grade 1 is considered the most minor, and grade 5 is considered the most severe. In our study, most of the cases fall into the category of grade 2 and grade 3, making up 34.5% and 27.3% respectively. For our finding, we noted that CT scan has a high detection rate with a 96.8% sensitivity for clinically significant intra-abdominal injury. This aligns with previous study which mentioned 84 to 100% of accuracy. Fast scan, on the other hand, only saw moderate performance with 61.3% sensitivity and 66.7% specificity. Previous study also mentioned that fast scan accuracy is quite variable depending on the operator's skill. We also noted 2 patients with negative CT scans, however, confirmed injury in surgery. This highlights the limitation of CT, particularly for bowel injury. Clinical judgment and serial examination is still important to avoid missing important injuries. Spleen and liver are the most commonly injured organs in our study. This aligns with previous study where mentioned that spleen is more susceptible. AST classification is used in our study to grade the injury. This is a widely used system and influencing surgical management. The majority of cases in our study who underwent surgical intervention involve severe spleen injury, with AAST classification grade 4 to 5. We also noted a substantial amount of patients with intra-abdominal injuries also had intracranial bleed. This emphasized the need of a thorough and comprehensive assessment for head trauma in trauma patients. In conclusion, we concluded that CT scan is crucial for the diagnosis of intra-abdominal injury. Fast scan can be useful as an initial screening tool. However, a negative fast scan doesn't rule out intra-abdominal injury. CT scan remains the gold standard. We acknowledge that our study has some limitations, primarily due to our study being a local single-center study with a retrospective design. However, our study still provide important useful local data in hospital setting, particularly regarding the injury pattern and clinical outcomes. Our study reinforces the importance of CT scan for definitive diagnosis of intra-abdominal injuries and promote judicious use of fast scan, emphasizing the need for CT scan in high-risk patients. The knowledge we gain from this study can improve patient care by optimizing diagnostic strategies and guiding treatment decisions in suspected traumatic injuries. Here I end my presentation today with a list of references that I used in my study. Thank you for your attention.
Thank you, Dr. Lau, for your presentations. We will now move on to the Q&A sessions. Judges, you may begin asking your 5-minute Q&A session.
Overall, a very nice presentation. I'd like to ask you one interesting concept would be, what's new from your study? Because like a lot of you presented, we already know that CT scan is the gold standard. We already know the problem of fast scan. You've also highlighted how CT scans can fail, which is why it's never 100%. But with all this said and done, just curious, is there anything new you'd like to throw at us?
In our study, actually, we focus on local data. So far in our hospital, we don't have a local study to prove how good is the accuracy of CT scanning in detect injury in our local center. This study proven that in our local center, we also can provide a similar accuracy. And also, it also highlight again, the fast scan is quite variable. Like in our study, it's only around 61% sensitivity. We do previous study, they mentioned also ranging between 62 to 88%. And particularly this relies on the operator skill. So from our study, we know the fast scan in our center is still of moderate performance. And in the future, we can look for we can do other study after, for example, if our operator in ED undergoes some training, we can see whether there's an improvement in the fast scan sensitivity in the future. And here also we noted there's a missed small bowel injury, which is not diagnosed by CT scan. And again, we can highlight the importance of clinical judgment also in diagnosing the intra-abdominal cases.
Thank you. The fast scan has some limitation, see?
Yeah.
It's an operator dependent, right? Operator dependent will also depend on the machine, the quality machine that you have, right? So with the sensitivity of about 61% or 65% in a traumatic injury, right? Can be very devastating, you know, if you miss, right? Okay. So that's my finding. I think CT scan is still the gold standard. You cannot achieve 100%. There are some errors, you know, human errors sometimes, or technical errors. Okay, that's why you can never achieve 100%. But at least it's much safer when it comes to if there's any delay in your intervention, you'll be answerable. That's all. Thank you.
Thank you.
Thank you, Dr. Lau, for the amazing presentation. Finally, let's welcome our last presenter for today, Mr. Wong Ming Kui, Medical Laboratory Scientist from the Pathology Department of Hospital Sultanah Nora Ismail Batu Pahat, with his research title, Fewer Images, Better Results, Deep Convolutional Neural Network with Few Short Learning for Malaria Detection using Full Blood Count Differential Scattergram Images. Feel free to begin your presentations when you are set, and kindly adhere to the 10-minute time frame.
Good afternoon, everyone. My study explores a novel approach of using deep convolutional neural networks, CNN, with few short learning, FSL, for malaria detection using full blood count, FBC differential scattergram images. This concept, fewer images, better results, is key to our approach in these studies. Hi, I'm Wong Ming Kui, the principal investigator, along with Noor Azlina Ahmad. We are both from Hospital Sultanah Nora Ismail, HSNI, and also Raja Saidatul Nadia. She is from Hospital Sungai Siput, HSS. Previous studies have shown that FBCs, there are detectable anomalies in FBC data from malaria infection. These studies rely on human interpretation to detect malaria. But they are only able to achieve low sensitivities, 49 to 86%. So these low sensitivities hinder their effectiveness as a reliable screening tool for malaria. As our speakers mentioned earlier in this morning, deep CNN has been proven successful in analyzing medical images, especially for tumor detection from radiological images. Our research takes a different approach by introducing two key innovations. We were the first to apply deep CNN to analyze FBC images, FBC scattergram images to detect malaria. We also leveraged the FSL technique to address data shortage challenge often faced in medical AI research. Malaria laboratory diagnosis depends on microscopic blood smear examination, which is time-consuming and requires expert interpretation. The current solution for this problem is by using malaria RTKs, rapid test kits. However, RTKs are expensive and they don't cover all malaria species. One of the major malaria species in Malaysia is Plasmodium knowlesi, and it is not covered by RTKs. Our objective is to study the feasibility of applying deep CNN with FSL to diagnose malaria using FBC scattergram. We intend to answer the following questions. Can we do it? How to do it? And why should we do it? This research was a quantitative retrospective cross-sectional studies involving 2 hospitals from January to June 2023. For every positive FBCs identified, we collected additional 2 negative FBCs as negative controls. These negative FBCs were collected 30 minutes before and after positive FBCs. We also built supervised machine learning models using labeled data to differentiate malaria cases. We also use established data splitting techniques to reduce bias and overfitting. Standard metrics, i.e. binary cross entropy and accuracy, was used to evaluate the performance of our data, of our model. A total of 14 positive and 28 negative FBCs were collected in our studies. HSNI contributed 4 positive and 8 negative, while HSS contributed 10 positive and 20 negative FBCs. Data from HSNI are used for training and testing purpose, while data from HSS was reserved exclusively for validation purposes. During training, the model learned to recognize patterns that differentiate malaria positive from negative cases based on the FBC. Now let's take a look at the result. This graph shows the model's training loss, training and testing loss over training cycles or epochs. The aim here is to minimize loss to improve performance. As you can see, loss decreased steadily, indicating that accuracy is improving. This reached a point of diminishing returns at around epoch 16, whereby further testing, further training will not produce any more significant performance gains. After that, we validated our model using the unseen data from HSS, and here is the result. Our model achieved remarkable performance, 100% sensitivity, 87.5% specificity, and 91.2% overall accuracy. This means that our model correctly captured all malaria positive cases with 0 false negative. The low false positive rate also translates to reduction, significant reduction in unnecessary follow-up malaria testing, thereby saving times and resources. I also like to highlight that our model made 34 predictions in under 10 minutes. Under normal circumstances, my lab will require at least 8 hours to examine 20 slides. This time saving translates to potential cost reduction. And here, I present a cost analysis, a simple cost analysis to quantify the impact of our AI model on resource allocation. Let's assume a hypothetical scenario where we need to screen 111 specimens with 10% disease prevalence. Our model offers significant cost advantages and potential cost saving of 4.6 to 6.5 times compared to the traditional methods. These studies successfully explore the application of deep CNN with FSL to diagnose malaria using FBC scattergram. Our AI model demonstrated high accuracy, indicating its potential as a valuable and efficient screening tool. FSL is the key innovation in our study that enable us to overcome the major challenge often faced in medical AI research, where large data sets is impractical. We only ever use open source resources and algorithm in our study. This open source nature will promote wider adoption and collaboration within the medical research community. Our study offers a promise for real-world application, real-world application in resource-limited settings due to its cost effectiveness and efficient use of readily available data. This research offers a promising glimpse into the future of AI-powered malaria screening. By leveraging FBC data, a readily available and routine test, our approach has the potential to revolutionize how we screen malaria, how we screen and diagnose malaria. I invite other hospitals and universities and industry players for further collaboration, research and development to refine and validate our model for real-world implementation. With that, thank you for your attention. I'm ready for the Q&A session now.
Thank you to Mr. Wong for the amazing presentations. Now let's move on to the Q&A session. Judges, you will begin asking the questions.
For your programming, how many was your positives that you used to train the AI?
For training purposes, actually, we use two positive FBCs and two negative FBC only.
That was enough to train the system?
Yes, that will be enough. And that is the power actually of few short learning, FSL. We don't need hundreds of thousands of data. We only need two.
But in what scenario do you think that your AI may fail? Is there any scenario?
Excuse me.
Say for my exposure to AI is for endoscopic imagery. We have noticed that when sometimes the lens captures the images with a little bit of offset color, the AI can misdiagnose ulcers. So we have to train and make sure that whenever we send the images, it has to be the same color scheme and that kind of things. So there are a lot of factors for training of machine learning. When you just say 2, I'm not quite familiar. Is your spectrogram red, green, blue, white kind of thing? I'm not quite sure. So in what scenario will you see that your machine may potentially fail? That's just my curiosity asking.
The data from the FBC analyzers, they are already in digital images. So it's I directly download the images from the machines. So there are no issues with lens image capturing or anything. But then it is limited to the brain of the hematology analyzer used. So if it is a different brand, the image will be different. So it's limited to that brand.
I would like to congratulate you for this presentation, right? This is something very new, right? It's something to revolutionize. I remember many years ago when we were asked to look into how to identify area for dengue, right? They are trying to adopt AI on it. I remember on that, and I don't know to what extent it has been successful, but it's something that you need to you have to develop a better system to detection rather than too late lah. Right? All right.
Thank you.
With that, we would like to end our presentation here. Thank you to Mr. Wong for the enlightening presentation. So ladies and gentlemen, that concludes our presentations for today. We would like to thank all the participants for their excellent presentations and hard work. Our judges will now be ushered to the judge holding room for marking calculations and to deliberate on their evaluations. Judges, you can follow Miss Amalina, who will guide you to the holding room. Okay, thank you all for attending the oral presentations for Johor Research Day 2024. Your presence and participations have made this event a great success. We hope you found the presentations insightful and inspiring. Let's give a big round of applause to all our participants, judges, and organizers. While we wait for the judges' decisions, please feel free to enjoy the exhibitions, lunch, and network with fellow attendees. Before we adjourn our session to the afternoon session, here are a few housekeeping notes for your attention. Kindly be informed that lunch is served at the cafeteria downstairs, so please present your coupon in order to take your lunch. And next, Iskandar Demonstration Theatre is now open for public to view the e-poster exhibition. For Muslim participants, you can go to the prayer room downstairs, opposite to the elevator, to perform your Zuhur prayer. And to the virtual attendees, we are now going to enjoy the lunch break and we'll resume our event to the afternoon session. With that, I would like to conclude my role as the moderator for these oral presentations. I apologize for any errors that may have occurred. Thank you and goodbye.
I think it's been next. And so my name is Ahmed Mullah, Dr. Ahmed Mullah. I'm a consultant diabetes endocrinologist. I'm working at NewMed and also from the UK and England. And it's a pleasure to be here today and helping host the day. We've got a fantastic talk coming up from Dr. Luqman Ibrahim on digital health in diabetes care. I think it's a subject very close to my heart. 20% of Malaysians suffer from diabetes, adults. That's 1 in 5, so approximately 5 million adults in this country. And of those 5 million adults, only around half, 50%, have actually got the diagnosis of diabetes. The other 50% are undiagnosed. And then we haven't even touched on the pre-diabetes prevalence, which is another couple of million people. So it's a big, big problem. And it's a very exciting time to be a diabetes doctor at the moment. There's lots of new medical therapies and so on, and technologies that we're going to be talking about. And Dr. Luqman Ibrahim is a fantastically placed person to talk about that. So Dr. Ibrahim is a consultant endocrinologist and physician at Regency Hospitals in Johor. He's also a visiting consultant endocrinologist at University of Malaya Medical Center in KL. So he's got his master's in internal medicine at UM and also did his subspecialty training at the KKM hospitals. He's a member of many learned societies. He's published a lot of peer-reviewed academic journals in diabetes endocrinology. We're just about to get up his slides, but I think it's going to be a fantastic session about diabetes care and technologies.
Sorry, we're getting the slides one. Yeah.
No problem.
First, I can start first. Thank you, Mr. Chairperson. And I would also like to thank the organizing committee for inviting me to talk about today. The task I've been given today. Okay. So the task that I'm given today is to talk about digital health in diabetes care. So I would take it in good faith that when the organizer wants me to talk about digital health, I think they want me to talk about the recent advances, especially in the technological areas when it comes to diabetes care. I shall start mainly by covering these 4 areas. So we are going to talk about glucose monitoring, advances in diabetes therapeutics, in clinical decision making, as well as in diabetes research. So what are the advances? Keep in mind that I am a clinician. I'm not a researcher, at least not anymore. So I'm not going to talk much about diabetes research, but I will tell you how the current research trend is going in the diabetes field. Yeah. Okay. So this is sort of like our pet subject, glucose monitoring, or namely or specifically technological advances in glucose monitoring. Yeah. So there are quite a few advances. I will start with the very basic things first. I think all of us have smartphone, right? Okay, so I'm going to introduce a concept called mHealth. mHealth is a concept introduced by WHO, where it's a concept where you want to integrate your healthcare into your mobile phone using mobile apps, obviously. So we do have some tools when it comes to diabetes care. So of course you've heard about all these apps that counts your calorie, about your fitness app, right? But these are among the app that we personally use a lot, and I will show you some of the data as well. So here in this picture, I show you one is the My Sugar app. This was by Roche. Actually, Roche bought over this app from a developer, and this one is a what we call as a contour diabetes app. This was developed by Essentia. Okay, there are also other apps. I think you might have heard about Have to Sync, and there are apps by Bionime. They are available in Malaysia as well. But these are the two that we use most often, that we have the most experience on. So currently in our practice, all our patients, if let's say they don't have a glucometer, right, we will tell them to buy a glucometer with a Bluetooth function. So we don't recommend glucometer without a Bluetooth anymore, because we don't want them to write on pen or paper anymore. If they don't have, or if they already have a Bluetooth, if they already have a meter without a Bluetooth function, what we do is that we will just swap their meter, because we collaborate a lot with the industry. So they will provide us with their own meter. So we just swap the patient's meter, and then we install the app in their phones. Okay, so what our team will do is that we will make sure the patient get a Bluetooth enabled meter, get the app, and synchronize it into their phone. So next time when patient comes to our clinic, all the readings will be in their phone. So there's no more reason to say like, oh, I forgot to bring my diary. So, and they don't need to transcribe it back from their meter. Why use this app? So I would just want to show you, there are a lot of data, or a lot of studies that has been done. I'm just going to show you two studies, mainly the real world study. This was done using the My Sugar app, okay, which shows that after the patient started using the app, right, the mean blood glucose actually improved from 8.5 to 7.8, okay, with a significant p-value in reduction. The estimated HbA1c also dropped from 6.7 to 6.3 with test in range. Test in range means the numbers of tests that are within the range of 3.9 to 10, okay, which increased by about almost 10% from 64 to 73, yeah. So it shows that just by telling your patients to use the smartphone app, right, you can actually improve their checking frequency, you can improve their glucose parameters as well. And bear in mind why this is a big deal, because these apps are all free though. Okay, they're all FOC. You just need to make sure that your patient buy the correct meter, which is sold at the same price as all other meter in the market also. And you just need to install the app and synchronize with their phone. It's like technically a free intervention that you can do and you get free benefit out of it. Another app that I want to show you is by the One Touch Review, but actually this is not available in Malaysia. The meter is available, the Bluetooth meter, but the app itself is not launched in Malaysia yet. So what it does, it shows that in people with type 1 diabetes, the mean glucose improved from 174 to 160. The readings in range from 3.9 to 10, right, improved from 58 to 66. And if you can see in people with type 2 diabetes also, the mean glucose improved from 157 to 139, and the readings in range from 3.9 to 10 also improved from 72 to 83. Okay. Again, if as much as possible, if your patient uses a lot of BG meters, right, I will sort of like make this an opportunity to make a call that try to advocate for the use of a phone app, so that so that their patient's life are easier, and it just make your life easier, the patient's life easier. You have more data at your fingertip and in the phone that you can make better decision making later on. Yeah. Okay. Come forward. Most of our patients now, we use CGM. We use continuous glucose monitor. There are two types of continuous glucose monitor. One is a flash glucose monitor. The other one is a real-time glucose monitor. Here, this picture is the flash glucose monitor by Freestyle Libre. This flash glucose monitor comes with a sensor that you patch at the back of the arm, and then it comes with a reader as well that you need to sort of like flash it. The company called Flash it. So, or the actual term is intermittently scan CGM, the actual technical term. Yeah. So in publications or in my lecture, I will use the word ISCGM, but some people also call it as a flash CGM. Yeah. So in countries where they have a Libre Link app, so they don't need to use this meter as long as their phone has NFC. So this sensor uses NFC technology. So as long as their phone has NFC, they can use their phone as a replacement for their reader. And this app, for example, if you have a patient whose phone is registered in Singapore, for example, they can install Libre Link and can use their phone as the reader. Yeah. The flash CGM has been shown. There are a lot of studies that have done on CGM, like plenty of studies that was done on CGM, both flash and real-time CGM. It improves HbA1c, it prevents hypoglycemia, it improves PROs, or patient-reported outcomes. Yeah, patient-reported outcomes are an emerging outcomes in trial. So now we don't just measure HbA1c or hypoglycemia outcome, right? We also measure how patient actually feel about the intervention. Yeah, so it does improve patient-reported outcome. It prevents hospitalization for both type 1 and type 2 diabetes, and more importantly, it prevents DKA for both people with type 1 and type 2 diabetes. There are a lot of real-world studies that shows that the incidence of DKA dropped tremendously after patients was started, especially in a national program like in Australia or in the UK and France, for example. Yeah. A second type of CGM is a real-time CGM. In this type of CGM, a person does not require flashing. Means that the CGM, instead of using NFC, it actually uses Bluetooth. So this Bluetooth reading will go direct to their phone, and the reading will go directly to their phone. So this means that this sensor will transfer information even if the person is sleeping or driving, for example, or in the middle of doing something else. Okay, and this obviously gives a clear advantage for people who has hypoglycemia unawareness, or people have nocturnal hypoglycemia where they are not aware of they're getting hypoglycemia at night, for example, and the app will give them alarm if let's say the glucose is high or the glucose is low. Okay. Again, there are plenty of papers done on real-time CGM. What we know is that it improves HbA1c for both type 1 and type 2 diabetes. It improves hypoglycemia for people with type 1 and type 2 diabetes as well. Again, it improves patient-reported outcomes. Importantly, it also improves pregnancy outcome as well, the real-time CGM systems. Yeah? And in general, in head-to-head trials, right, between real-time and intermittently scanned CGM, real-time CGM tends to do better when it comes to HbA1c lowering and preventing hypoglycemia. And for some people, especially with type 1 diabetes who uses automated insulin delivery system, I will tell you a bit more about this later on. This real-time CGM is a must tool for them, so that for the AID system to work, because it's part of the system itself. Okay. Now, so that patient can have their phone app, they can have their CGM, the CGM send data to their phone app. So what we do, we can monitor them remotely. It's a question what we want to do or what we don't want to do. Yes, we can monitor them remotely. So in this case, I will show you a picture of the Libre sensor with a Libre Link app, with a Libre View web portal. So for example, if your patient is using a Libre sensor, when they scan, when the data goes to their phone, it will be automatically uploaded to the cloud, and you can see the data from your clinic as well, from your office. Yeah. We also have this for pretty much all the real-time system. We have this for Glonovo. We have this for IDEX as well. And what we do now is that we do what we call as a CGM rounds. Yeah. So it means twice a week, we will go and sit in front of our computer with our team, and then we will go through all our patients who are on CGM. And we will see like who needs to be contacted. For example, those with persistent hypoglycemia, those with recurrent hypoglycemia, those who might have faulty sensor, for example, then we just call them to either advise them about how to modify their treatment, or maybe if they need to come back for immediate, let's say sensor replacement, for example, and we try to keep in touch with all our patients even after they have left our clinic or left the ward. Yeah. This is an even newer system. Although this is not a CGM system, this is a BG system. This is by Roche. They call it Roche Diabetes Care Platform. The interesting part about this is that the RDCP has also a machine learning component built into it. So when it detects your patient BG, right, because Roche is such a reputable company, they have millions and millions of glucose reading, the system itself can tell if your patient has certain types of hypoglycemia, post-meal hypoglycemia, nocturnal hypoglycemia, for example. The system itself can tell you what to do. Of course, it makes recommendation. At the end of the day, it's down to the clinician to make the recommendation. But I just wanted to highlight this because this is, I see where the future is going, where you have a tool there will be AI or machine learning built into the tool, and they will give us recommendation, and of course the end responsibility will be for us to make the final decision on how to advise the patient. Yeah. This is a very new paper. There are some studies, but this is the most recent one. Nowadays, people are looking at non-invasive ways to monitor glucose. All current CGM now requires skin piercing. So means when they patch, right, there will be a filament, a sensor that will pierce through the skin, and it will detect interstitial glucose. Okay. Now there are research to look at different methods to measure glucose non-invasively, and this is one of the methods. Of course, this is still very early, done in the animal stage, the DROS method, right? But I hope to see these methods in few years to come, hopefully, because what this means that the current CGM is limited by the skin interaction to the sensor. So for example, most sensor can last up to 2 weeks, because beyond 2 weeks, there will be some reaction from the foreign body reaction into the sensor. So you will need to replace sensor every 2 weeks, right? But if let's say you can come up with a system that can measure glucose non-invasively, which I hope we will eventually, then in theory, we can monitor them for a lot longer, and this will cut costs for most patients. Okay, now, second part, therapeutics. First, I'm going to talk about this hybrid closed loop system. This is the new kid on the block. Not to say new kid on the block. This is the hot talk of town. Yeah. Nowadays, all technology conference, right? We even have a dedicated conference for this. They call it Advanced Technology and Therapeutics in Diabetes, ADTD. Right? It's a 3-day conference just to talk about this technological topics alone, right? These are among the most hotly discussed topics about hybrid closed loop system. If you are all familiar how insulin pump works, okay, insulin pump delivers insulin into the skin. There's a pump, there's a catheter, there's a needle, it goes to the skin. How you set up the pump, you have to manually program the pump, and the pump will just follow your instruction that is already programmed into the pump itself, okay? How a closed loop system works is that you have a sensor, you have a real-time sensor that gives information to the pump, and the pump itself will decide, based on the sensor reading, how much insulin it wants to deliver. So it means the pump itself can increase insulin dosing, it can reduce insulin, it can even suspend insulin if it has to. Yeah? And studies have shown that in experimental studies and in real-world studies, the outcome, the glycemic outcome for people who use automatic insulin delivery system are much better than the current standard of care. So nowadays, we are really advocating patients to use automated insulin delivery system. Understandably, the uptake is a bit slow because of cost factor, especially in some parts of the world, but this is what we are trying to push for, equitable access for all these technologies. Yeah? Now, question, why do I call this hybrid? Okay, the reason why I call it hybrid is because it is not a fully closed loop system. Okay, means that it detects the glucose from the sensor, but it doesn't detect the glucose that comes into your mouth. Okay, so a person will still need to announce the amount of carbohydrate that they are going to consume. Okay, whereas in a newer system, in theory, you might not need to. So it means it can adjust by itself. But even this is not a fully closed loop system now. This is sort of like almost there. Okay, in the islet system, which is not, I think not available in most parts of the world except for maybe some trial centers in the US. The patient just need to announce whether they are taking a regular size meal, small meal, or larger than usual meal. And then the system itself will decide on how much insulin to give for those particular meal. Yeah. There are head-to-head comparisons that has been done on the islet system and the 780G system, where you have to announce meal and you have to announce roughly the estimate the amount of meal, the size of portion, size of meal, right? But they found that the outcome is the same, meaning that announcing your meal for some reason will sort of like work, or in other words, if I were to rephrase it, right, the algorithm in the current system is not as good as the person. It's not better. It's not better than the person with diabetes announcing his or her meal itself. Okay. So, but I'm not saying that the hybrid closed loop system will forever be equal or better than the fully closed loop system. It's just that the algorithm is not there yet. Okay, but we all know when the algorithm is not there yet, it's just a matter of time before we can build a better algorithm. Yeah, and then we can have a better system that can accurately predict even your meal as well, can compensate even your meal as well. Okay, this is new. I haven't used it, but I have attended their discussion meetings. The first picture here is called the InPen by Medtronic. The second picture here is called InsulCloud by a company called InsulCloud, but they are marketing it together with Sanofi, an insulin manufacturer. Yeah. So what these two devices are, they call smart insulin pens. What smart insulin pen does, it detects the amount of insulin that you give. You can even enter your glucose reading in the app, right? And then it will detect the amount of insulin that you give, and then it will calculate how much insulin for your next dose. So for example, if you give extra insulin now for lunch, right? For dinner, it can tell how much insulin you should administer for dinner. So you just need to dial that number and then it will inject that dose. Yeah. It will also detect if, let's say, you miss a dose, or you can come up with a log later on. There are trials currently looking up at what are the efficacy and the benefits of using such a system. Okay. I think we are all familiar with telehealth by now. Yeah, after COVID-19, we are all very familiar with what telehealth can do. I just want to recap a bit. Telehealth is a very broad topic. It can be an appointment, can be consultation, can be forum, social support, can be monitoring like what we do, lifestyle intervention, again, glucose monitoring, education, food diary, reminders. So there are a lot of areas in telehealth. I think most of us have used this at one point or another during the COVID-19 pandemic. I hope you still do this now, even after the pandemic. I just want to show a little bit of some data from the AMA Telehealth Survey Report 2021, where they show that most physicians, 85% of them report that they are using telehealth. 60% agree that telehealth allows them to provide higher quality of care. 93% physicians conduct live interactive video sessions. 62% physicians agreed that their patients are more satisfied using telehealth, which I also agree with that. I think they are more than happy to see me from home. More than 80% of physicians agree that their patients have better access to care, and half of physicians claim that telehealth has increased their professional satisfaction. Yeah. If your center do not like have a structured way for telehealth, I think maybe you can try to champion it in your center. Yeah. Okay. Now, online support. There are many online support groups, but I just want to show you one of the online support platform that was initially developed by Abbott, but now they handed it to MEMS, so now it's fully under MEMS guardianship. It's called the Diabetes Lifestyle Program. So this is a program, one of the programs that you can find online, that basically can refer your patient and they can have dietitian advice online. Okay. I think later on, when in August, when we have our Johor Diabetes Update Conference, we will discuss more about this. I will invite Prof. Nisa to discuss more about what are the current data, the current challenges, and the outcomes from the ongoing diabetes lifestyle program. Okay. I wanted to tell you a story about this guy. I know the topic is about digital care or digitalization, right? But I do feel that this is one of the areas in diabetes care that I think we should keep our eyes on. Okay. First, I will tell you the story about islet transplantation first. Okay. If you're all familiar about how solid organs are transplanted, like kidney transplant, for example, right? So you take from a donor, you give it to a recipient, and then you give the recipient immunosuppressive therapy, often including a glucocorticoid. Okay. But I think it would make sense that glucocorticoid is a big no in people with diabetes, because you want to lower glucose, not increase glucose. Otherwise, what's the point of giving them transplant organ, right? Okay. Kidney and pancreas transplant has been proven to work very well in people with type 1 diabetes and end-stage kidney failure. Okay. But in people without end-stage kidney failure, it is a little bit tricky. So back in the year 2000, a group in Canada, they introduced what they call as the Edmonton Protocol. Okay, in the Edmonton Protocol, they take cadaveric pancreas, they take a pancreas of a person who has passed away, right? And then they isolated the islet cells. Okay, so means they just dissolve them with enzyme and take the islet cell, and then they infuse this islet cell into the liver circulation. okay? And this islet cell will be embedded inside the liver parenchyma. What this islet cell will do is that it will start to act like a normal islet cells in the human body, okay? So it means that in the original paper, the Edmonton group transplanted 14 patients and all of them received insulin independence. All people with type 1 diabetes, all doesn't require insulin anymore. But then there's a catch, because they still have autoimmunity. So their autoantibodies will still kill off these islet cells. And eventually these islet cells will die. Okay, and they will be back requiring insulin. Okay. This is how the story comes into picture. This is why this is a big deal. The company called Vertex developed a way to differentiate islet cell, right, from a pluripotent stem cell. So it means nowadays we can actually manufacture islet cell in the factory itself. Okay, means you do not need a donor. Okay, or maybe they can take your own stem cell, right? They can differentiate it into an islet cell that you can use yourself. So it means technically you can have unlimited amount of islet cell as long as you can go through the repeated procedure. Okay. So this guy, Brian Shelton, is the first person in the world who received such a treatment. Okay, it was quite a big deal at the time in 2021 because he was the first person who received the treatment and he achieved insulin independence. And it was all over the news portal. Okay. In this particular trial, they received insulin islet cell, but they also received immunosuppression minus the glucocorticoid. Basically, they received a non-glucocorticoid immunosuppressant. Okay. Unfortunately, Mr. Shelton passed away end of last year, died end of last year. And from what we know from the company, they said that the death is not related to the trial product or not related to the intervention. So the trial was initially in January, postponed or paused, and then after that they resumed the trial. So now the trial is still ongoing, okay? And then Vertex come with the second version of the stem cell, which has recently been approved to be used in a clinical trial. So the trial not started yet, the stem cell itself has been approved. But this is an encased stem cell. So it means they take the same stem cell, they put it into a casing so the antibodies cannot attack the stem cell. Okay? But there's a bit of a catch with encased stem cell. It's not that people have not tried casing stem cells, sorry, not stem cell, islet cells before, that people have tried. The problem with casing islet cell is that you also restrict the blood supply. You also restrict the oxygen. You also restrict the glucose that goes into the islet cell. Okay. Then another type of company come in, Visite and CRISPR Therapeutics. Okay. So what they did was they developed the same stem cell. Okay. Developed the islet cell from the stem cell, but they genetically remove the gene portion that makes up the antigen. So it means they are creating a stem cell that is invisible to your immune system. Okay, this is not tested in clinical trial yet, but there are groups who are building these treatment methods, and I think there are really exciting research findings that we can look forward into in these next few years. Yeah. Okay. This is one of the areas that I think we often forget, but I also think it's important. As a diabetologist or as an endocrinologist, I often believe that at this point, our current treatment for diabetes is quite good. Okay, not perfect, good enough for us to achieve what we need to achieve in most of our patients, but our treatment system is not good enough. Our care delivery system is not good enough. We can have the best treatment in the world, but if the treatment doesn't reach the patient, right, it's not going to do anything. So it means our treatment is fairly good, but our system is not good enough. And this is another research area where people are developing what we call as a diabetes, they call it CDS, Clinical Decision Support System, CDSS, or DSS, Decision Support System. Okay. In a DSS system, what they do is that you have an algorithm who makes the decision for you. So in theory, you can work in a GP clinic, for example, right? You can have the system installed in your clinic. If the system is validated enough and compared with, let's say, experienced diabetes clinic or endocrinologist, right? The system can manage your patient as good as any other endocrinologist. Okay, so you just need to follow what the system says only. That's all. Okay. The exciting part about this is that I feel that this is very scalable, not just in the country, but throughout the world. As long as you have a computer, you have a system, you just follow what the algorithm says, I think you're good, you're set to go lah. Yeah. I just want to show you two papers that tested this system. So this is an example of a DSS that was done in the HPMG clinic. They call it diabetes wizard. So this is the example of how the DSS looks like. So the system will key in the A1C, the creatinine level, diagnosis of heart failure. It will show you what's the goal, what's the treatment, and then it will give you a recommendation on what you should do, what you should start the patient on. Okay? And what they found is that by using the system, you can actually improve HbA1c from 8.5 to 7.9, okay, just by using the system, okay? And then you can achieve more patient with target systolic blood pressure, because sometimes we stop at 140, you know, we don't often go to less than 130, right? So, but when you have a computer algorithm that tell you, hey, your blood pressure is 135, you should intensify antihypertensive, right? Then you get more patients who will achieve more blood pressure goal, yeah? Another system that was used for inpatient in the Pennsylvania state, they call it the Gluco Alert, CDS. This is a hospital-based system, and when they test it, they have a switch on and off in the hospital. So they have 3 months off, 3 months on, and 3 months off, and 3 months on, like that. And they found is that when the system is on, they have less hyperglycemia events in the hospital. When the system is on, they have less inappropriate insulin use in the hospital, and when the system is on, they have shorter hospital stay. So means even when it comes to the hospital interest for inpatient care, so CDS will still benefit your patient and your health system as a whole. Yeah. This is something I learned very, very recently. I went to a conference. This is my first time I ever attended the conference. It's something like a health economic conference, but they discuss a lot about methods lah. And one of the things that a lot of people are discussing about is how they use machine learning to improve the current CV risk stratification. I'll give you an example. I think many of you are quite probably familiar with Framingham risk calculator, ataupun score risk calculator, ataupun the AHA risk calculator. I'll give you an example. If let's say the AHA risk calculator is introduced in 2013, right? What they did was that they take all the clinical trial data and they compute it in algorithm, and they predict the risk of cardiovascular event in the next 10 years. Okay, but we know that cardiovascular risk evolves over time. When you get new treatment, your cardiovascular risk improves. Back in 2013, we do not have SGLT2 inhibitor. We do not have GLP-1 receptor agonist. We do not have, let's say, Entrestor, for example, right? We do not have the new treatment that will modify cardiovascular outcome. So the question is, what if we can also have a system that also evolves over time? Okay, like a risk stratification system that evolves over time. And this is what the research teams are doing. They are using machine learning to come up with cardiovascular risk calculators that will evolve over time. And of course, there are many groups that are trying to validate their findings. I do feel that in the future, the machine learning based system will replace the current system that we're using now. And I hope it will happen sooner than later. Okay, my last section, diabetes research. Okay, we are all very familiar about RCT and how we do research, right? But I just want to highlight two important trends in diabetes research now, namely the use of big data and as well as diabetes registries. So this is one of the more important findings in recent years in the area of diabetes. The group in Sweden, they have this registry called this NDIS cohort, where they take all newly diagnosed type 2 diabetes and they look at their phenotype and they come up with this new classification of type 2 diabetes, or new classification of diabetes, sorry. Yeah, because it includes people with autoimmune diabetes as well. Yeah, so this is just an example on how big data now allows us to see diabetes differently from how we see diabetes just a few years ago. And this is another example of a more nearer, closer to home registry done by Hong Kong. Some centers in Malaysia are also participating in the JADE registry as well. The JADE registry also has come up with multiple publications, especially to look at the risk of complications in people with diabetes, namely type 2 diabetes, especially in the Asian setting, because a lot of these registry come in the Western setting, right? So now we have a registry that represents our Asian population as well. Okay, closing soon. So what are the current challenges? Of course, just like everything else in health intervention, we do face our challenges. one of the things that I noticed that bothers me a lot is the lack of standardization. You will see like company A will have different standards than company B, company C will have a different standard, and they don't cross talk to each other. Okay, so it makes it very difficult. For example, if you are a doctor, you have a DCEMR, and there are 5 different CGM manufacturers in Malaysia. None of them talk to each other. How do you deal with that? So I think this is some of the things that we need to address in the future, which includes integration as well, how different system will integrate, because now some companies are going into the open system platform, like Android platform, right, for example. So some companies, they do crosstalk to each other. Some companies, they don't crosstalk to other people at all. So you just must use their ecosystem, like Apple, for example, right? So these are the issues that we are facing. Access, I think we all know this. Not everyone have access to all these technologies, but I do feel that should be a continuous work that we all should fight for it. We all should push for it and improve access to all these diabetes technologies. Expertise is another thing, because when we don't know how to use the technology, we are not confident enough to push for it. Okay, like for example, if I don't know how to use the CGM, I won't be confident enough to tell my management to set up a CGM system in my hospital or in my clinic, for example, or maybe ask for funding for CGM, for example. So I do think that it's kind of like a chicken egg thing, access and expertise, and I think we should try to work both at the same time. And lastly, hesitancy, because some people are still hesitant about using technological advancement. So I do feel this is just a matter of time before hopefully they will be more open to this in the future. So moving forward, I do feel that we should have more training sessions for HCPs, okay? And I look forward to a future where we have more equitable access to diabetes technologies, especially if we can have it all covered by our health system, if not all, but some. Singapore, yesterday, they announced that they are going to subsidize DEXCOM sensors to Singapore residents and Singapore PR as well. So some of your patients might come here with a DEXCOM sensor, especially if they're Singapore PR. They are Malaysians who have PR in Singapore. Yeah. And then, of course, collaborative research, importantly, yeah, so that we all share our data, come up with bigger registry, and we can have bigger data to analyze. So with that, I pass the mic back to the chairperson. Thanks.
Dr. Ibrahim, thank you very much for a really excellent, thorough talk. I don't know about everyone else, but I found that really, really interesting and fascinating. If there's one burning question, let's take one question if anyone has any burning questions. No, you've stunned everyone into silence, but I think that was a wonderful session. Thank you so much again. Thank you very much. Hand over to Dr. Marina.
Okay, Assalamualaikum and very good afternoon to everybody. Okay, so we're going to proceed to the second symposium. Okay, one endocrinologist, we're going to move to the other endocrinologist. Okay, but so let me introduce Dr. Ahmad Mullah, who was actually our chairperson just now. Okay, so sorry. So we are actually in this symposium, okay, we're gonna look into the views from the academician, because we've heard the views from all the clinicians. So next will be the academician. So with that, I would like to introduce Dr. Ahmad Mullah and invite him to start the first session.
Thank you very much. Thank you very much. Thank you very much, Dr. Marina, for a kind introduction. So my name is Dr. Ahmed Mullah. Today I'm going to talk to you about my journey in clinical academia. So I'm a consultant physician and also associate professor here at NewMed. I come from the UK, and I will, over the next few minutes, 20 minutes or so, I'm going to talk to you about my journey through clinical academia as a doctor and also as a academic. And I also try to put it into the context of the NHS and health research structure. And I think the question I'd invite you to think about, perhaps, and I was also thinking about as I was preparing these, is how to foster a clinical academic culture. So I think you're probably all very familiar with the Malaysian structure. So I think what I can provide hopefully today is an idea of what the UK structure was like that I went through and some of my learnings from that. And I'm sure there'll be a lot of parallels and similarities and perhaps some, some nuances and differences compared to the Malaysian structure that people go through at the moment. So I hope you find it interesting. So yeah. So I think this is the opening slide. So what I've done here, I've just tried to talk to you about the structure of the NHS and how the funding flows through the NHS. Because everything revolves around money, doesn't it, at the end of the day? So in the NHS, you have the Department of Health, which is similar to the Ministry of Health. And it has a budget roughly, this is 2022 data, of around £170 billion. The Department of Health keeps back a fair bit of that money for things like Health Education England, which controls all the postgraduate and some of the undergraduate training that takes place. So when you once you graduate, that's just the beginning of your journey because you have to do a lot of postgraduate medicine training. It took me 12 years to go from the doctor that graduated from medical school to my consultant career in the NHS. And I'll talk you through that in a bit. You've got the Health Security Agency or Public Health England. You have local authorities and social care. And then you have a few other government bodies like NICE, which is the National Institute for Health and Care Excellence, which recommend, what drugs should be prescribed in NHS. And then some of that money then flows down to NHS England, which keeps money for service development, central administration, pandemic planning, contingency planning, and so on, also direct commissioning of nationally commissioned services. And then you have about 42 integrated care boards, which then fund local hospitals across the regions of the UK. And this slide here is talking about health education. So how do you train a clinical academic? And I think if you just look at the different colors, you've got, essentially you have 7 areas that cover the geography of the whole of England. And we call them deaneries. And these are the deaneries that are responsible for postgraduate training of doctors across the UK. So that central pot of money that goes to Health Education England is then used to fund postgraduate training. So that money is separate to the main NHS budget. But I think it's important because obviously these organizations, academia, the NHS, local authorities also have to talk to one another. So you need to follow the money and understand how it works to be able to successfully build collaborative working and try to develop both research and clinical structures and infrastructures from which people can then flourish. So how does that fit into clinical academic training? So this is the NIHR guide, which is the National Institute of Healthcare Research, which is government-funded agency. So you have medical school, which is the realm of obviously the academia or universities who run medical schools. Depending on what type of person you are, whether if you're science-minded and want to learn about, be a good scientist, you'll probably choose a few different universities compared to more clinical universities. So a lot of universities offer integrated BScs as part of the offering. And you may well want to do MD, PhD combined programs as well. So some medical schools will offer that. And as we all know, there'll be also graduate entry medical schools as well, because in the UK it's mainly undergraduate entry, but there are a few, or more than a few actually, who do just postgraduate medicine, actually graduate entry medicine. So you do medical school, and then you go on to a foundation program, which is equivalent to the Malaysian housemanship program. In the UK foundation program, you can do specialized foundation programs, which you can take teaching tracks, research tracks, or other, specialist tracks like GP or psychiatry. And for research purposes, you have the academic foundation program, which is run jointly in collaboration with the universities. So not only do you get your clinical training, but also you have time protected to do your academic training as well. That's your basic training. Then you have your specialist training, which is what happens in Malaysia when you have your master's programs. And that specialist training can take anywhere between 5 years to 10 years, depending on what tracks you choose, medicine or surgery or psychiatry, whatever it is. And as part of that, you can also do academic clinical fellowships, which is the same thing. You can apply for competitively funded NIHR-funded programs that allow you to buy out some of your research time in the clinics to dedicate to research. So typically, you might, over a 3-year program, you might spend 9 months in the lab or doing clinical research. So these things are meant to be integrated. It doesn't always work, but this is what the theory is behind it. And then the idea with these things is that you then build up enough money and enough credit in your academic career. For those who are interested, because there's no point doing it to people who are not interested. It doesn't make any sense, as you can imagine. You then manage to get a fellowship to do a PhD, for example, or an MD, where you take time out of your training for 3 years or however long it is, just to focus on research. So these kind of academic clinical fellowships or clinical lectureships are there to kind of support you do your PhDs, or maybe even your postdoctoral, like a lectureship position, in conjunction with your specialist training. And eventually, when you come out the other end, you have senior positions when you're a consultant. You can apply for NIHR professorship pathways and so on, where you get fully funded 5-year blocks to be able to do medicine. So I think it'd just be helpful. I thought it would be helpful just to talk through the clinical academic journey and the way it's meant to work and how the universities fit in with the NHS and so on. I know we've got multi-professions in the room as well. We don't just have doctors, so the NIHR recognize this too. And so what they have is, they have NIHR career pathways for other professions as well. So nurses can certainly apply for PhDs, physiotherapists, occupational therapists, and so on, speech and language therapists. You name them, there'll be programs there that you can apply for to complete your doctorate, or do a period of protected research time if you don't want to do a formal period of study. Dentists also have the same thing. So there are multi-professional pathways that aren't just limited to doctors that have been developed over the past 10 to 15 years. Okay, so what's the focus? I think, it's all about improving people's quality of life. You have all this research, but you've got to make sure that it reaches the patient at the end of the day and it has advances patient experience and so on. And at the same time, if you're investing a lot of money, so at the bottom there at the side, I put there, the NHR budget in 2022-23 was 1.3 billion pounds, okay? So it's a lot of money. And you've got to show outcomes from that. So, there is an economic benefit from investing all this. And it's estimated that for every £1 that's invested in healthcare research, there's a return of around £19 to the wider wealth of the nation, which is quite a, it's quite a good return on the investment, isn't it? So 1.3 billion, you're getting around 20 billion back, in there or thereabouts. And a lot of the research also is very patient focused. They want to see direct benefits to the patients as well. Okay, so one last slide in theory. So who funds these things? So these are all the kind of the governments or government associated kind of some of them. So Health Education England does all the training and coordination of this. You have Wellcome Trust, which is a big charity. The MRC, Medical Research Council, is a big grant provider, which is funded directly from the government as well. And then you have charities as well, like the British Heart Foundation or Diabetes UK. You've got the Medical Royal Colleges as well, and the Academy of Medical Sciences, who advocate for doctors and clinicians to kind of make sure that some of these research programs are really embedded into the fabric of the NHS as well and the universities. So that's the theory. So I'll just talk you now through my journey as part of this program to see what I did to get where I am today. So this is me, medical school, back in 2006. I hope you like my hair, yeah. So I know my mum would laugh at this if I showed her this. This is me receiving the British Geriatric Society 2006 Amore Prize. So I was a BSc student at the time, and I did my research thesis on novel antioxidant agents. So this here is EUK 134, which is which was a well-known, which is an antioxidant that was being looked at for reversing Alzheimer's and so on. So I developed this thing called NMCX in the lab at Imperial College. I was doing lots of pipetting late at night and so on. And this is an X-ray crystallography image that I produced on the crystals that I made at Imperial College. But this was part of my undergraduate medical training when I did my BSc. So that's where I really got into research. I chose a university that was very science orientated. What else did I do at medical school? So this is my medical elective. So I went, I was really interested in, community medicine. I was interested in, helping people, talking to people. So I approached some of these people on the bottom left of the picture. That's me there. This is one of my mentors, Dr. Shafi, who works for the Health Protection Agency in the UK. This chap here is Professor Ziad Memes, who was the health minister for, one of the health ministers in Saudi Arabia, in charge of the Hajj pilgrimage. And so in 2008, I got funding from the RCGP, University of London, Royal Society of Medicine to look at disease surveillance at the Hajj. So I went out there as a medical student, and swabbed patients, looked at influenza-like illnesses, did health surveys and so on. And, it was really good fun. But it was because I went to a kind of sciencey minded university, medical school, which allowed me to kind of look at these things, apply for grants, gave me information of what kind of grants to apply for. And that's where I kind of really developed my love for academia as well as medicine. So that was the medical school part. So what about my foundation program? So based on some of those things and some of the prizes and so on that I got, I then went into a Imperial College NHS trust, which was very closely aligned to Imperial College University. And so what the UK developed about 15 years ago now is academic health science centres. So it wasn't just Imperial College London, which is the university. It was now Imperial College NHS Trust. They combined or collaborated very closely with the NHS Trust so that you'd have seamless, from clinic to lab, back to clinic in the afternoon if you wanted to. So I spent a lot of my time in an MRI scanner, looking at scanning the hypothalamus down here, to looking at obesity and appetite regulation. So I spent about a quarter of my time in the lab at the Hammersmith Hospital in London, doing some of this work in the lab. And then after that, I think academics have interesting journeys. I think we're talking about how all these things overlap. So what I did, I took some time out after my housemanship training and worked at the UK Department of Health as a clinical advisor to the National Medical Director for the NHS. So this allowed me to understand, how to formulate policy, how to write briefings and so on. So, I was writing briefings for Prime Minister's questions, for example. I was, looking at unwarranted variation in the NHS, how to improve quality whilst reducing costs. And so on, and looking at diabetes care, for example, and rates of amputation in the NHS vary by district. And if you have a service that works, you're doing far less amputations, and that's successful. So understanding how health policy is formulated and works, and I think is really, really important. So there's no one linear career journey. I think you have lots of different journeys that you can go through to understand where you want to be. So that was between my housemanship and my specialist training. And then when I went into my specialist training, I applied for one of these academic clinical fellowships that I was talking about earlier, which was allowed me to be employed by Barts, which is in central London, as well as Imperial College, where I kind of really developed some of my research ideas in obesity and diabetes. So I was on the wards getting my, doing my night shifts, doing my on-calls, getting harassed by my seniors, go and see that patient on the ward and so on. So I did all that and got my wings and my badges to do my clinical training. But at the same time, I had 9 months protected over the first 3 years to really think about fellowship applications and how to get research grants. And eventually Oxford University, along with Novo Nordisk, offered me a fellowship to do my PhD. And I put Novo Nordisk and Oxford there deliberately again, because talking about how industry can collaborate with academia. And I think it's all about collaborative working. And so Novo Nordisk, was giving a lot of money in diabetes back then to universities to develop new research and so on. And it was really interesting. And I made the right decision to move to Oxford from London at the time to do my PhD, because you've got to choose the right department. You also have to choose the right mentors as well. And mentorship is really, really important. So what I did at Oxford in my PhD, I did some clinical research. So this is one service improvement program that I did. So we looked at the outcomes from a multidisciplinary metabolic hepatology clinic. So a lot of people with diabetes also have liver disease. So we designed a service where the diabetologists would sit in the same room as the hepatologists to co-manage the liver disease and diabetes. And what we showed there, which we published back in 2018, I think it was now, is that if you have a hepatologist and a diabetologist sitting in the same room, you can see and you're prescribing the right medication, you can see an improvement in metabolic health. This is HbA1c coming down from 76 to 62 in about 160 people over a period of 18 months. So that was one chapter of my PhD, looking at service design and development in diabetes and how to improve outcomes for patients. This is a technology talk, so I thought I'd put a technology day, so I thought I'd put a technology slide in here as well. So another project that I did was looking at the liver disease in diabetes. How can we risk stratify patients with liver disease? That's a high risk, low risk, i.e. people who might well develop cirrhosis and liver failure or liver cancer versus people who won't, because you can't see everyone. So we used something called, we measured 32 steroid hormones in the urine on a spot sample, and we used generalized matrix learning vector quantization, which is a machine learning technique, to be able to separate out high risk versus low risk groups amongst patients. So So this was really, really interesting. And again, showing how technology can, improve outcomes or and go on. So that's the GMLVQ in fatty liver disease. And then finally, the third part was clinical trials. And again, Novo Nordisk were key in this in terms of providing a lot of funding for clinical trials. So I used the precursor of Ozempic. Everyone's heard of these days. I'm sure everyone's heard of Ozempic, GLP-1, which is semaglutide. So back when I started this PhD, semaglutide was not yet licensed globally. Well, it wasn't even licensed anywhere actually yet, still in clinical trials. So we looked, so I ran clinical trials that were registered with the MHRA and European regulators to look at the utility of these medications in treating liver disease, and we found, that they are very efficacious. So these were running clinical trials. So I did bench research, I did lab-based research, I did service development research, and clinical trials as well. So, I went through the full spectrum. And that was back in, so I finished my PhD in 2020. I then was appointed as a consultant in the NHS at the Royal Free in London, where, and then COVID hit. And then suddenly everyone became COVID doctors. All we saw was COVID. And it was hard work, as I'm sure it was here as well. So I spent 2 to 3 years there writing out some of my papers. I got a lot of papers published from the PhD and looking for the next step. And lo and behold, Malaysia came knocking, and NewMed came knocking as well. So the last few years, what I've been doing at NewMed, I've been doing a little bit of research, but a lot of my time has been in medical education. I should have mentioned, as part of my postgraduate training, I did a master's in education as well, which I was interested in education. So I did a master's part-time, and that stood me in good stead to come to NewMed to do a lot of clinical work here in conjunction with the local hospitals. So I spent a lot of my time at HSI and HSA teaching and training our medical students here, both to the Malaysian standards and regulatory requirements, but also to the UK standards and regulatory requirements. So, I do a lot of meetings with the UK and the regulators there to look at, how well we're performing, especially in postgraduate medicine as well as undergraduate medicine. So I've been doing a lot of work, but the highlight of my week is always going to the weekly, I go to a weekly diabetes teaching clinic where I go to HSI and sit with one of the endocrinologists there, and we see undifferentiated cases of diabetes endocrinology. And it's really good fun, and the students really, really enjoy it as well. So I've been using my medical education skills in that. Just briefly touch on, let me see if I've got enough time. I've got a couple of minutes. So I'll quickly tell you about some of the other programs that we run. So we produce doctors, and those who are Malaysian can then go and work in the housemanship here in Malaysia if they want to. So we run a system for the housemanship where we can give them dual accreditation, both with the MMC and the GMC. And those are 8 hospitals across Malaysia. So we have 3 in Johor, which are Kluang, HSI, and HSA. We've got UMMC in KL, and we've got Penang as well, and we've got 3 in Borneo, Cebu, Kota Kinabalu, and Kuching. So I jointly manage the program with the UK to, if the housemen complete their portfolio of evidence, we then run accreditation panels to recommend them for full GMC registration along with MMC registration as well. And then I think finally the most important part, move to Malaysia, was the opportunity to travel and explore new environments, makan and food, the people, the culture, the place. And I think it's been a really fantastic journey. I've really enjoyed my time in Malaysia over the past 2 to 3 years, and it's been a really, really interesting journey, and I've met some wonderful people along the way. So I'll stop there. I did have a couple of the slides, but I think what we'll say, actually I will talk to you about this slide. I think clinical academic programs must operate within a person-centered and mentored collaborative framework. So, you need to have this pyramid here. I think you need the clinician academic at the top, but you need to have the universities and the healthcare organizations, the clinical leads, in this case the NHS, being able to support you and work to support your goals. So it's a collaborative effort in academia between universities, the service providers, whether that's the NHS or the KKM or whoever it is, and you have the clinical academics. So the UK Clinical Academic Training Medicine programs have talked about this tripartite structure for clinical academic programs. So I think with the right support, you can then really develop good, strong quality clinical academics who will not only serve the patients, but also be able to, improve the research infrastructure along the way. So thank you very much for your time.
His journey, so each of each of us, if you look through our journey, it's always a certain sort of journey for us to reach where we are right now. But hoping that it will give us some sort of inspiration to kind of like looking into what are the opportunities that we might have, okay, into collaboration and also to kind of like do a cooperative kind of getting fundings and getting things done. Okay, so for the next topic, okay, I'm gonna invite Prof. Vishnu, who's the CEO for Newcastle Medicine, to give her topic, which is research perspective of a medical educator and also leader and manager. Okay, so without further ado.
Thank you. Terima kasih. And terima kasih for being here after lunch, right? We had quite a hefty lunch. So I'm going to give you a perspective that's a bit different, right? And I'm taking from a health professions educator and in terms of research as a health professions educator, right? So you may ask, for example, who are health professions educators? Who are they? Actually, all of us sitting in this room are health professions educators. So if you are in a healthcare setting, right, you are providing service to that setting, and you are actually training or working either with your peers or, for example, with house officers or with a pharmacy who's on PRP, for example. So depending, any kind of trainee, and you are giving feedback to them, you are a health professions educator, right? But health professions educators, they don't exist just in the clinical setting. So they exist in the university also, right? It's just that how do we see ourselves as a big community? Because we are a big community which the future of healthcare, I suppose, depends on, right? So if we do not collaborate and have the same expectations as what those in the healthcare need, then you will be saying, hey, dari universiti mana ni budak ni? You know, where did they graduate from? Why are they not prepared, right? So we need to make sure that the universities, the academics, and the healthcare system, and those like you are in the healthcare system are aligned, right? And I be frank, it's not the university that decides the curriculum. It is our community healthcare needs that decides the curriculum, right? So we need to know what is the healthcare needs, then we design. So when you're talking about curriculum design, talking about assessment, universities cannot do it alone. It needs to be together with all of you here, all of you who are practicing in the healthcare system. And that's why I say we health professions educators, we are the community here. So what research do health professions educators do? So if some of you want to just Google my name, you will see the kind of research I do. So I started my research career as actually a biomedical scientist, to be honest. I work on Duchenne's muscular dystrophy. I work a lot on pregnancy-induced hypertension, cancer biomarkers and all that. But for the past, I say 20 years, I have moved towards health professions educator. And that research is about, for example, let's say if we are doing a train the trainer program, train the trainer program. How do I know that training has impacted the persons who attended the program? How effective is that training? What psychological or educational psychological context are we using to do the training? So this is an example of research in health professions education. Another example would be if you are developing an innovative teaching learning method, you want to know how effective is the transfer of learning. Has the student developed competencies around that? So this is my new bidang, to be fair, my new area of new meaning about I've been doing it about 20 years, right? But I started off as actually a biomedical scientist. So that's what I'm going to share with you, and how my role from a researcher has now turned into actually a leader, right? So when we look at barriers for research, if we agree all of us are health professions educators, actually there are quite a few barriers for us to do research. You know why? Because we're doing multiple jobs. You are doing your clinical job, right? For us, I'm doing my administrative job, I'm doing some teaching job, I have to manage a university, a institution. Ahmad has to do his teaching balance with some of the admin work and then the clinical work and research work. So there will be some barriers. So the usual barrier will be time constraint, is it not? Time constraint where you have to balance clinical, administrative, and of course, very important, work-life balance also, right? You cannot be everything to the work. The second barrier sometimes can be the institution. Maybe the institution doesn't have the processes or support for it, or tak ada incentive. You know, so you do research, so what? If it's not recognized in your promotion, for example, or in your career development. And sometimes a lot of red tape. Research, sometimes can have a lot of red tape. The other thing is, a barrier is research training. We are all trained, see, I was trained as a scientist. You are trained as a health professional. So you may not have been trained to do research. You have to learn research lepas kerja je. You know what I mean? After joining the workforce, terpaksa, my boss asked me to do this project. And then you menggelabar, cari statistician, cari this, cari that, they're learning. So sometimes that can be a barrier. Lack of resources. So funding, maybe there's no funding. Semua kata buat research tapi tak ada funding. Then you don't have infrastructure. Sometimes you need some basic laboratories or depending infra. Most important, we all now know the new goal, right? Which is data. Actually, lack of data. So even though you may have the data there, but because it's not digitized, actually you cannot move your research as fast as what you want. So there are many reasons that we have these barriers. Of course, attitude can be also an issue. So for example, I know at least 25 years I've been teaching medical students. Actually, the fear of failure. They are good as doctors, but they are fearing research. They fear getting rejected by the journal. They fear getting rejected by the ethics committee. I don't know how many of you remember Tan Sri Abu Bakar. Some of you may remember him. He was the former DG of KKM. So he was my boss for many years when I was in IMU. He was the chair of our research and ethics committee for a while. As students go in, they come out, they will be like, sometimes can tell you, they will be in awe. I don't think Tan Sri would mind me sharing because Tan Sri asked the right questions, but the students were not prepared for that. So this can be quite a experience for students, right? And most important is, you don't know who to collaborate with. This can be a barrier. So the interdisciplinary approach. Are we just doing? So for example, if you are doing a study on mental health, but you don't bring any mental health specialist in the study, can be a challenge, right? If you are doing a study on diabetes management, like what you have been sharing just now, right? But you must bring the right people. Who knows? Some of the aspect of the study needs a dietitian, for example. So are you bringing the right persons in? So these are some of the barriers. Does this barrier look familiar to you? Right? So it doesn't matter whether you are in an academic institution or in a healthcare institution, these can be some of the barriers. But to me, barriers are always to be broken and to be removed or to be reduced, right? So I have that mindset. So I like to share with you how people remove barriers. This is the general way. They say, have training programs, make sure you got protected time, make sure there are mentorship programs, there is funding initiatives, and streamline processes. Okay, let me make a confession here. This is what ChatGPT told me. This is what ChatGPT, looking at all the whatever that is available on their database, said is how to remove barriers. Is this real or not? Yes, some of it is real. I think some of it, mentorship, protected time. But is it realistic? Because I know when I was working as a junior lecturer and senior lecturer, and was looking to do more research, I still had to do all my teaching and learning responsibility. I was module coordinator for this, that, and everything. Still, as a woman, I had to manage my family. It's not what protected time. There was no protected time. Kata je, oh, Wednesday got protected time. Actually, it's no. So what is the way for us to remove barrier? So before I give you the way, I'll tell you my journey a bit. All right? So I tak share gambar lah because I'm much older than Ahmad. So if I want to cari gambar, I have to really dig many, many years. All right? But definitely, Ahmad, I also had more hair before. All right? Okay? So I would start. I told you, my background is I'm a scientist. So actually, I studied in University of Malaya. But I was very fortunate. I did very well. I got a full scholarship to go to Cambridge University. So for me at that time, it was a good opportunity lah masuk Cambridge, my PhD training. And on the first day, my supervisor gave us 2 papers. Dia kata, take these 2 papers, read it. After 3 hours, come back and critique. You want me to critique? This is a paper already published, peer reviewed. Apa lagi I nak critique, right? But that is the mindset. So for me is, when I had the PhD training, it was really about looking at evidence-based kind of practice, having a systematic approach, being constructively critical, and having a problem-solving approach. So I would say my training provided me with that. Now, some of you may not realize actually your training did provide you with that. But you got it at the back of your hand. But you don't see that these skills is actually useful for research one day, right? And then what happened is, I also did a lot of clinical research. I tell you the truth. So I work a lot, and I worked in other countries, not only in UK, but also in Netherlands. And just to tell you, in Netherlands, they actually, it's a different language. You know, imagine you're in the clinical environment, and I used to take blood samples for Duchenne's patients, a lot of muscular dystrophy patients, especially a lot of genetic disorders in certain areas there. So I had to take blood sample. Nanti I tengok monster. I was thinking, what is this monster? Written there, monster. Just to tell you, sample is monster in Dutch. Right? So you have to adapt. But one thing was clear, when you were reading the cases and then you were doing things and everything, I realized clinical research is very, very regulated, and you're not just dealing with the sample. Actually, you're dealing with people. So even though I was in the lab, when I read the case studies, case notes to, get my data, patient data, I can see actually it's stories about families. With Duchenne's, it's really it's young boys, they are diagnosed very early. So this brings me the part that, research is not just about us getting the data, but it's actually doing and working with people actually, even though we are at the back end. So that was my first part of my life. Masa tu muda, and that time I got married. I also, by the end of my PhD, I had a daughter. Right? Because I had my eldest daughter, I decided also to come back to the country. Right? So I came back and I joined, at that time, I joined IMU. And that's where my medical education training had. In medical education training, I think I was in the right environment because that is a newer university, so they had many chances to try something new. We are not, we don't have history, to be honest. We don't have history to hold us back. But what was important is our willingness to learn and to apply what we do. So it's not just when I got a chance, I don't just teach, but I take a chance. Oh, they're going to introduce PBL. I also will kiasu lah pergi masuk dalam working group tu. So I take it as a chance to learn and apply. And it's very collaborative. But I realized I'm not an expert. I'm not an expert. How can you do all this? Then people will say, who are you? Who are you? Especially the professors. I think some of you all kenal lah, the professors there. Many of them MOH people. Who are you to tell me? We have been doing it this way. Then I think, I need to get some qualification, So it's not just about doing medical education as a practice, but you need to get a qualification. So what happened is, adalah rezeki, I got a chance to do my master's in health professions education. So I got the evidence. And I tell you, as a non-clinician, that was my advantage. Because by doing that and being one of the first people to do that in the country also, I think I'm the first Malaysian graduate from Maastricht University in health professions education. I had a different perspective and also, I would say, expertise on how to look at curriculum, how to look at assessment, right? So these two gave me what we call credibility. So you see, I'm taking you on a journey. First is what is influencing my thinking, being evidence-based, being systematic. Second is about my willingness, right? The third is about getting credibility. Now, because of that, it opened a lot of doors for me. So from a senior lecturer, associate professor, tiba-tiba orang minta you jadi dean. Because you had the qualification credibility, right? So then it's your chance at your institution to translate what you have learned, what you experienced into practice, right? Not just buta-buta with evidence-based. Remember the thinking of evidence-based. But as an institutional leader, you must show ROI. Tadi dia kata ROI kan? The return on investment. So for example, at that time, we invested a lot about online learning, e-learning portals, learning management system, including online assessment. And you know where the return on investment came? COVID hit, right? But the university was ready because we had things online. We also invested into simulation, especially for preclinical. But it helped us to transition during the clinical years. So you see the ROI was there. But I want to tell you, leadership is not just about institutional. We have to think about international, being global, and opening up and networking, right? So that's where I also made the effort to, go for meetings and this and that. And to be fair, the situation that I was in, the university that I was in, had a lot of these international contacts. So I developed it not only for myself, but with my colleagues, and then we formed community of practice. So this to me is the thing that made me see things differently. And because of that, remember the one I showed you with ChatGPT, how to remove barrier? I would share with you this. So you talk about training program. Yes, universities or institutions can have training program, but we as individual have to have reflection and know what is our needs. So just now I said, I buta-buta kiasu, go and do this training, that training, right? Do a reflection. Do what is exactly needed for you, and then select and plan for it. So you're talking about removing barriers. It's not just joining anything. See what is based on your needs. Protected time, I would say, is actually, the plate, they say, make your plate bigger, because if you have no time, make your plate bigger. I would say I would take the dietitian approach. Actually, you have the same plate, but your portion is different, right? So balance the time with your own personal and professional life. Please, no matter what, I can tell you, I think I can say I'm 50 plus already, so I've got some age to me, right? Nobody is going to be with you except your family. So do not sacrifice time with your family, right? So make sure there is time to be with your family. So balance that. Very important to be in mentorship programs. You seek to be mentored and be open to mentoring others too. It works two ways, and learn from the mentoring experience. Mentoring leads to future allies. So you will have a lot of allies. You build a community of practice, right? Funding and processes. Have a proactive approach. So university can have funding, but you must be proactive. Go and seek the information. Nothing is going to fall on your lap. Go and ask from respective committees, go to the secretariat, or ask other researchers who have gone through the process. So this is my additional tips to you, okay? Be authentic. This is very important. I think we Malaysians generally are very authentic. You can see us, we are an open book, right? Be authentic and with passion and integrity. So key to collaboration, if you want to build it, is trust and being respectful. Have a trusting and respectful working relationship. And most important, I would say in my journey, which has benefited me, opening the door to others is very key. So bukan saja the benefit for yourself, but for your staff, your team and everything. That's very much important. And don't forget for those who are maybe on the end of the career or last few years like me, actually your subordinate is going to be your boss one day. So role model to them what a good boss can be, you can be, right? So open the door for others, form communities of practice, and celebrate diversity, but respect our local context and culture. So this is my tips to removing the barriers. So it's not just what ChatGPT said, but this is what I add to it as a human being. All right. Thank you very much.
Thank you, Prof. So that was an interesting journey for a scientist into an academician and then also administration. Okay, I think we also have a similar journey in which we start, maybe at first we thought, okay, we're just going to do clinical work. And from then we noticed that, no, clinical work is not enough. We may get ourselves involved in research, or we might get involved in administrative as well. Okay, so with that, we're gonna move to the next speaker, which is Dr. Madiha Rushaidi, who's a biomedicine, Dean of Biomedicine, right, in Newcastle University. She's gonna speak on journey as academic in biomedical sciences.
Thank you so much, and the chair speaker. First of all, I apologize. Actually, I realized that this is really late for all of you. You've been staying here for the whole day. So I put a lot of pictures as comparison to both Prof. Vishna and also Dr. Ahmad Mullah, so that it will be a lighter talk, because I know and I noticed that most of you probably will struggle to try to relate to a journey in academic and in biomedical sciences especially. But hang on, and hopefully you can stay with me until the end. So I had quite a reverse journey compared to Dr. Ahmad Mullah, actually. And if I have listened to his talk 20 years ago, I probably would, follow a different pathway. But nevertheless, let me just share my own journey. And I think every journey will start with something, right? So for me, it starts with a big dream. This is actually a picture of my mother's house, drawn by this artist quite recently, last month actually. And they are from the Angkatan Pelukis Malaysia with collaboration of Balai Seni Negara. We were very proud when this was published on the Facebook. As you can see, I came from a kampung girl lah. I come from a small village, where I would say during that time, hardly anybody left the village for overseas studies, probably the first one, right? So can you imagine, though I look young, but in that particular small village, it's something really, really big to dream up about something as much as going to university itself. So, all right, I started with a like normal childhood, right? That's me with my little brother. But I do have a strange hobby. Well, it was supported by my grandfather. He was the best grandpa in the world. And you can see that my hobby is that I like to ask him, particularly during Hari Raya Korban time, to bring back, organs or things that are not used, like the cow's tongue, the eyeballs, because I like to dissect them. I started this from really early, I think primary times, right? And it didn't stop there, getting more and more, up to the point where when I entered primary school, I started to look for, especially boys who didn't do well in school, to catch lizards and frogs for me. And in return, I would go and teach them maths. So it's probably the beginning of me becoming a teacher one day that I didn't realize at all. But also, because of this bizarre and strange hobby, I think the whole kampung knows that I'm somewhat peculiar child, and they started saying that, oh, she's probably going to be a doctor one day, right? And I think one of the, I can't remember, I cannot forget this, because I went on to a bigger animal, obviously. As you can see, I catch one of my grandpa's rabbit. It looks very sickly, and I thought that putting, an end to the suffering would be a humane thing to do. So, but eventually, I actually gathered my bunch of kampung friends to actually watch me dissecting the whole rabbit, and I got punished, obviously, by my grandfather. He tied me to a rambutan tree full of karanga. Do you know that? That's like a very painful dance. Yes, so that was my grandpa in his younger days and during our wedding time. And just like other people who have been envisioned to do medicine, I started my journey like others. I got scholarship from JPA. I did my Australian matriculation. Then I went on to study medicine in Otago University, New Zealand. But yeah, I should have listened to Dr. Ahmad Mullah's talk 20 years ago. And being a kampong girl, this is a funny story as well. When the teacher asked, what do you want to be when you grow up? Instead of saying, I want to become a surgeon, I said, I want to become a sergeant, you know, because English is not really good at that time. It wasn't my first language. But the whole journey and the whole ambition basically had a bit of twist or change, taking a turn when I called my grandfather Abba, which is in Malay, it's actually father, because he's like a father figure for me. I don't call him grandpa, actually, I call him Abba. He started to lose his memory and his health declined up to the point that when I met him, he asked me, who are you? So that's really, 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 you know, made me sad. And I thought that it would take too long. It's like 6 years to complete my medical studies, and I can't even treat him because being a general medical practitioner, I think that that's going to take me another 5, 10 years, you know, along the right road to become a specialist. So I talked to many, many, many people, and I said, how can I do an impactful change if I want to change this one day? I mean, if I want to find a cure. So it's funny enough, I don't know why I decided to change and make a way into a biomedical science field. So at that time, there's no biomedical sciences degree. So I was lost once again. And because I really love medicine, I just decided to sign up for BSc Honors in Anatomy. Because I did medicine earlier, so it was a piece of cake to me at that time. So I got my first class honors. Then I was offered a scholarship to do a direct entry of PhD. So I didn't do my master, I do my PhD. And during that time, I realized that all of these symptoms, all of these signs of my grandpa or Abba not knowing and not, losing memories and all related to the brain. So that's why I choose to do PhD in neuroscience. That's just my pictures. You see the generation gap, so that's why we put more pictures. So, so my journey to find the cure for ABBA, but eventually in research, though you start with something very personal, you realize at the end, it is something that you want to make a change for the world. It is for a better life for everybody. So I just put ABBA for now, but eventually I hope my research has benefited others. So I started, this is actually the chapter that I wrote in my PhD thesis, where I focus on the memory system of the brain and then aging, obviously. Prof mentioned just now aging. So it is my expertise, Prof. Okay. And I focus a lot on a neurotransmitter, a novel neurotransmitter called agmatine. Okay. And of course, to do research, you need a right tool. I think Dr. Ahmad Mullah also mentioned this. A right tool is where you can get the things going and finding all the answers. So I choose microdialysis. Obviously, this is the pathways. I'm not going to go into details of what I did during my PhD years, but there's a lot of questions. There's a lot of questions that was coming to my mind at the time. You know, I was eager to find a solution. So research is about finding the solution, right? And you have to ask the right questions. And you have to have the right tools as well. So in my journey, I discovered that this is the things that I need. And of course, getting the information from the right source is the key. Talking to various people, people with experience, people with the past evidence can lead you and to make you more focused. So I ended up actually focusing on this pathway, okay, where because aging, we still don't know what's the cause. We don't know is there a right button to start aging? Is there a single button? But we know this is actually multifactorial. So perhaps there's no single answer for this, but at least one of the most prominent theory was related to the nitric oxide bioactive molecules. So I focus a lot on this pathway, and I kind of like fall in love with this whole L-arginine. So this is like biochemistry, right? And you realize that biomedical sciences is not just on a single discipline. From anatomy of the brain, then it goes deeper into the molecular aspect. Then we cannot avoid biochemistry. You cannot avoid all of those topics. I can see my students and smiling at the back, right? And of course, we need to build it upon evidence. where you ask, where you put your aim is really depending on what are the evidence that you've got in the first place. So I ran a test on my fourth year final project to look at whether or not agmatine was found in the brain. It wasn't known whether it is really helpful in learning and memory at all at that time. So I proposed this to my supervisor because we have some other papers who showed neuroprotective effects of agmatine in the brain. And for the first time ever, we showed that this actually probably have a direct participation in the process of learning and memory. So we were really excited, and that's how it came about to become a bigger project and become a PhD project. And obviously, go back to the cure, I would like to find a miracle things that I can contribute to help not just my grandfather, any grandfathers, any aging people, any aging population in the world. And my supervisor herself, she was a geriatrician before. She left the job. She wanted to go for research because she also has some personal stories that I could not tell here, right? So there's a number of chapters and series of research that I work on. I just very quickly go through, but the male spot belly rats are my best friend. As you can see, I learned a lot of new techniques. I learned to prepare and synaptoneurosomes, something new that I haven't prepared before. I didn't know that I could actually separate the presynaptic, the synaptosomes and the neurosomes. It was really, really molecular, really tiny. And I was amazed when I see it under the microscopy. This is what it looks like. And of course, with research, it must come with an outcome. You have to publish it. So we have to publish it. And going next on, well, now I know what aging does to all of these chemicals. Then what about the pharmacokinetics? You cannot stand, as I said, research is developing. It's not just about one particular discipline. So I don't have the expertise of being in pharmacokinetics areas and so on. So I have to reach out. I get my second supervisor now from the School of Pharmacy. And we learned and we looked at many, many things. So one of the new technique that I learned during this period of time is the stereotactic surgery. It's just bring back the childhood memory. And I feel like I'm so confident. The vet said that you really have a skillful hand. I said, yeah, I was trained when I was young, right? So when I did this stereotactic surgery, actually it was very properly done in New Zealand. I think you cannot mess up with the vet. They're the one that give you the cert and the permission to carry on this surgery yourself. So I had to pass series of training before I can do this surgery on my own. And I did this in vivo microdialysis, which is at that time was really expensive and really, really tedious machine to work with, right? And the beauty of it now, you don't measure things after they're dead. You can get a live sampling. You can let your rat run around and do tasks, and you collect the fluid from their brain, and you measure it with real time. You know exactly what increase when they make a jump, when they take a turn, when they decide to find a way out of a maze. So it's really amazing in a way when we do behavior tests. So again, we've got this published, and I went on to see what if I now inject my rats with this agmatine, right? So that we have got all the pharmacokinetics profile and all. Now it's time to do some, real tests, give them some treatment. And here I learned to do lots of animal behavior tests. So the animal behavior test is really amazing and really interesting. I think I spend most of my time playing with the rats, right? I have the Morris water maze. Yeah, don't get too personal with them because you're gonna be really, really sad when you have to sacrifice them, right? And then open field tests and all. Again, when you need to learn something new, you have to reach out to people who are expert in this field. And you can see that my collaborators now expanded to the Department of Psychology instead of just anatomy and pharmacy. Then this research has been picked up by the Brain Health Research Center because we've published a number of things. They're really happy with our research. They see potentials in it. They put in fundings. So with publication, you can actually attract good grants and fundings. So this is what we had at the time. And of course, if you're going to treat patients, you're not going to give them one magic bullet and then they, just recovered, right? It has to be on a certain period of time. That's why I proposed to my supervisor, let's look at the effect of the prolong. This is all preclinical tests, and they're very important before you can even move on to the clinical aspect. So we did this, we were quite ecstatic when we see the age-related changes in some of the behavior function. In short, I would say some of the tests, my age rats perform better and almost equivalent to the young ones. So I feel like, hooray, like, over the moon, thinking that I've solved, find the thing that I was looking for. And like a bonus a bit when the rats also actually quite lean. Normally, when they are aged, they are fatter. When we treat it for prolonged, you can see that they even reduce weight. So I was thinking, this is not just for learning memory, it's probably also for weight loss. So obviously, we need to assess the toxicity with all of this, right? Okay, so the journey was really, really interesting, and I get on into a lot more. This is just some example of what I did after that. I did more and more behavior tests. I want to see whether indigenously it also do something without any intervention of the drugs, right? Artificial drugs. And I did see something amazing. So I really convinced, and I think that this is something that I can, I don't know, if I can get some industry to produce my drugs, then probably I'll be the richest person on earth, yeah? So I went for conferences. I went to the Society for Neuroscience. In fact, there's a number of people who asked me to work for them, asked me to develop this drug because it looks like something magical that might happen. I don't know, right? And then all of this really, really like the peak of my career pathway at that time. But of course, a lot of peak will also have a downfall, isn't it? But I never regret. Okay, life is always interesting. It always takes turns. And I heard that my grandfather is really, really unwell. So I returned home and he passed away. So it took a while for me to recover from that. Then I was also pregnant with my baby. So I give birth, and it's always difficult to once you have a family, it's always difficult to go away again, you know what I mean? So once you settle down in Malaysia, this is almost like your long destination. But I'm lucky enough to find UMAT at the time. So I joined UMAT and I started almost very similar like what Prof has done as a lecturer, senior lecturer. Okay, I'm teaching mostly anatomy and neuroscience. Then I was somehow being picked into a leadership role where I deputy the program for BMS. And I also take a keen interest in education. Then I did my cert in medical education. And I'm currently the Dean of the Biomedical Science. Right, so this is just another role that I did here in UMAD. And I'm also quite active with the association, particularly the Malaysian Anatomical Association. I'm currently the Deputy President. So just a bit of introduction with my program. So what I run here is a 2+1 BSc in Biomedical Sciences. Being a biomedical scientist myself, I think it's a pride and joy to share with them the journey and my own real experience in research. And we are Russell Group University, world-leading research-intensive university. So I'm very proud to say that our faculty is actually bigger, and we're just a part of that, from the School of Biomedical, Nutritional and Sports Sciences, where our teaching is basically a research-led teaching. So we are evidence-based. We are, even from year 2 onwards, we teach students with all of these skills and research focus. So this is our program structure, just in case you're wondering how we run it here. So the first 2 years are in Malaysia. Okay, that's my own, okay. And when the special part about our program, in last year, we sent them to the UK so that they can join Institute of Research and had the first-hand experience. I really envy my students, to be honest. When I was in undergrad, nobody let them into the, proper research institute like this. I had to do all in the teaching labs and all, but they had this chance. So it's really something that's unique about the program. Upon graduation, obviously, we had them working elsewhere and in many, many aspects, but just sharing with permission some of our graduate success. I'm very proud to say that majority of our graduates, more than 50%, went on to further their studies in master's and PhD. So it is a really good program to promote research excellence. And you can see that a lot of our students got full scholarship, like Mr. Naveen here, he's currently in Australia, getting full scholarship from Pfizer. And we've got a lot more, and including one that is currently working at NHS UK. So I think at the end, at least at this point, I feel like all of the journey that started in the beginning of my life till now is just like a complete piece of puzzle. I feel the satisfaction as a teacher, as a researcher, as a learner, and to see the success of my students and fellow colleagues, right? Obviously, in BMS, The industrial links are very, very important. So we develop a lot of links with various companies, and I know some of them here today are also from companies. Please send your cards to me. Let's have a chat, right? So we should expose our students, okay, to all of the opportunities so that they can also build their own dream and pathways. This is what we've been doing. And as for now, okay, I do not no longer do this amazing augmented research, but I do hope people pick it up. I'm still in touch with my supervisors, no worries. But I'm trying to incorporate some of my neuroscience background into education. This is one example of a project that I did with my colleagues in Reading as well as UK, where we looked at the neuromyth prevalence in Malaysian educators and students. You'll be surprised to see the outcomes that even medically trained educators still believe in a lot of neuromyth, all right? Despite learning neuroanatomy or whatever concepts of psychology and all, we still believe in a lot of aspects of neuromyth. What's more concerning is how that translates into practice, how that influence our own practice in research and education. So I also did a lot more focus on anatomy education. So this is one example. This is one of the research presentation that we won first prize last time, I think. We were quite busy during the COVID-19 time. We've got paper on assessment and also teaching and learning. We're sharing practices, good practices. This is with other colleagues in Malaysia as well. I think this was from last year where I talked about transnational education, focusing on anatomy. And we are facing this VUCA world. If you don't know this VUCA world, you can search it yourself, okay? And you have to prepare for the VUCA world. And of course, bridging the gap is really important between the research or preclinical and clinical, where we do a lot of programs outside. Like this is one example where I was heavily involved. I'm in charge of the silent mentor undergraduate clinical anatomy training with my MAA team, with the as well. We try to build a module where we can also expose the undergraduate students, okay, to the clinical anatomy using Silent Mentor. And this is the other Anatomy World Cafe where we try to look at the competency level of undergraduate medicine to practice. And here, we cannot do it alone. We have to do this cafe together with practitioners, with specialists, with practicing doctors and all. So this is really the journey of an academic in biomedical science where we integrate, and most importantly, we don't just stay here in our lecture theater. We go out and we do outreach. We speak to the public and we spread the knowledge. So we have a lot of outreach. This is one example of microbiology outreach at schools. We did anatomy outreach. This is a Little Medic program. We went to the school. We teach the young children, because we're worried about the statistics saying that kids are no longer interested in science and all, you know. So we try our best to share them the knowledge and the joy of becoming a medical practitioner or medical health professionals. And this is, again, we go to the EON and the public where we actually showcase a lot of our anatomy models and our knowledge as well. So in a nutshell, I would say that academic in biomedical scientists have to do all of these things to not just teach, learn from each other, but also we have to disseminate and we have to do it in all of the disciplines that have also been mentioned by my other two colleagues earlier, all right? So I hope that has given you a bit of a thing to take home from. All right, thank you so much for listening.
Okay, so from a clinician, we move to biochemistry and then into biomedical. But although it's like from medical to biochem to biomedical, but it's interrelated, in which those are where we do get the first of all, first information. That's where things are being developed, okay? And then translated out into a clinical work where we can actually use for our real patient. Okay, so with that, I would like to thank all three speakers. And there's actually a token of appreciation. At first, I would like to invite Dr. Madiha. I'd like to invite Prof. Vishna. Dr. Ahmad Mula. Okay, so I would like to pass over to the next chairperson.
Hello, everybody. According to the timetable, we're supposed to have a 15 minutes break, but after talking to a few people, we have decided to just proceed with the feedback and prize giving session. So now I will invite Dr. Nurizan Yahya, who is a ENT surgeon and also head of CRC Hospital Pakar Sultanah Fatimah Muar, to come and chair the session.
Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. The moment we've all been waiting for, at least for the not just the participants, for the those who went for the competitions. Ladies and gentlemen, distinguished guests, honorable judges, esteemed participants and delegates, welcome to the closing ceremony of Johor Research Day 2024. Hosted at Newcastle University Medicine, Malaysia. Whether you are here in person or joining us virtually, we appreciate your unwavering commitment to this event. Today has been a day of enlightening discussions centered around the theme of transforming healthcare through digitalization. We are honored to host speakers who explored into the potential of digital tools and innovations to transform healthcare delivery and patient care. Furthermore, the outstanding presentations and discussions by our participants have highlighted the power of collaboration and innovation in this field. On behalf of the organizers, I extend our heartfelt gratitude to Newcastle University Medicine Malaysia for hosting us and to all the committee members for their hard work in making this event a success. This year, we had participants in two categories, professional categories and medical students category. In the student category, we witnessed 4 original research presentations and 4 case report presentations. In the professional category, the Iskandar Demonstration Theatre hosted 8 original research presentations and 8 case report presentations, while here in this Bailey's Lecture Theatre featured 6 oral presentations. Okay, now let's hear from our head judges from each category. Okay, I think, okay, we're supposed to have Dato' Ghazali's first feedback, but, Dato', there you are. Okay. For each category, we had 3 judges, okay, but we only get feedback from the head judges for the interest of time. We welcome our esteemed judge for the oral presentation category, Dato' Ghazali, to share their insights and feedback. Please, Dato'.
Thank you, Mr. Chairman. It's an honor for me to be with you today. Honestly speaking, I was involved in the research for the last more than 20 years, right, in the faculty and also in the Ministry of Health. And I was heading the CRC for over 20 years. And I think this is probably the first time I was invited for the research day, I think. Most of the time I was more of innovative and so on. Nevertheless, being involved in research, I'm quite happy to see there's some progress made for the Johor State Health Departments. I was the trainer for the clinical research, for so many years, trying to motivate people to get involved in research, especially busy clinicians like us, okay? And after so many years, I think I can see the results, okay, of some of the research. I was more involved in the clinical, in the industry research, okay, at that time. Now I can see that today, I can see out of only 6 participants for this today event. And out of these 5, out of 6, I think, there are 2, I think, 2 or 3 are considered as good, quite good. And the other 3 are quite fair. And as a research, I think they need to look into the new knowledge, to discover new knowledge, or to use the existing knowledge for the new things. Okay, and it is gratifying to see that we can see that that in their presentation. However, I would like to stress that we encourage new discoveries, new thoughts, new knowledge, to move forward. Otherwise, we are stuck. We are stuck. We can find a new discovery, but it is good to add on with the intervention. whether it is effective or non-effective, viable or non-viable. So at the end of the day is that I would say all the 6 presenters has presented quite well during the stipulated period of time given to them. There was a healthy discussion, a QA session, and a good response reply by them. And to the winners, we would like to congratulate to you, and please share this with others, and so that it can entice people, to look into your result, and maybe they can extend to their new finding and discovery. With that, thank you for your attention.
Thank you, Dato'. It's nice to have him back as one of the judges. Yeah, I think this since Dato' left us after he retires, susah nak jumpa kan, except when you come back as a judge to our event. Okay. Now let's move to the category or professional category, original poster presentation category. So we would like to welcome the head judge for this category, Professor Vishna Devi, to give a review and feedback.
So thank you very much. For this category, we had 8 presenters. And what was really nice is I would say all 8 presenters were covering topics that were very relevant for practice. And the nice part was actually we had representation from a medical professional, from pharmacy professionals, even dentistry, right? So it was also, there was an interprofessional element. Now, when we looked at the impact and some of the studies, actually they have their findings can be used for application within their own setting and probably within the context of the local setting or national setting. So one of the things that perhaps we discussed as all the judges is that some of the studies, if possible, it was generally in one hospital or one CRC, under one CRC. If possible, because it's Johor, why not some of the studies collaborate across the CRCs? Because then the finding is more applicable across different contexts. So that's the first thing. The second thing is some of this intervention, we see that it was more cross-sectional rather than, longitudinal. So perhaps that's also something that can be improved upon. But having said that, looking at the presentation, I definitely enjoyed it. I think also with my 2 co-judges, we really enjoyed it. Sampai bergambar-gambar also after that. Because it was nice. To be fair, it was really nice to listen to people who were very passionate about their work, who took pride in their work and presented to us in a systematic manner. So I would say we identified 3 top presentations, but to be honest, all 8 of you are winners to me because, it's not easy to share like this, right? So thank you very much. Yeah.
Thank you, Prof. Okay, let's then invite our head judge for the professional case report presentation category, Dr. Jayamala Turai Rajasingham, to come forward.
I would like to make this, actually it's a great opportunity to see you all present. Dr. Ghazali was one person who really motivated us as long as he was in HSI. I've been invited here to be a judge for every time for Johor Research Day. I'm in the orthopedic session, but it's very interesting to see all the case in today's case reports. Each case, we had 8 presenters. Each case was something unique, something different. And the passion that you all put into picking it up and learning about it and bringing out some qualities in it, all the 8 were good. There are a few of you all, I think about 3 of you all that was a bit extraordinary, like things that even we have not heard about, and we would read up what is this before we see your poster. And that would be something interesting. And a few of you all, like the conclusion that you all come into, the learning that you have taken out from a single case report is something that you can persuade and bring in other departments to collaborate and bring a better outcome for certain case managements. And I think an effort that is put in into all the 8 participants really appreciated and very well presented. Thank you.
Thank you, Dr. Jaya. And lastly, let's welcome the head judge for the student presentation category, Dr. Marina Abdurrahman Sabri, to come to the stage.
Okay, I'm honored that I got to see the students to present actually. So I got 8 students, 4 from the category of posters, original research, and 4 for a case report. And they are our future, I would say, not just researcher, they are also our future clinician. So I can see there's something great that's going to grow out of there. Although there are some improvements that needs to be done, most probably in the way that not the presentation, but more of making it more relatable to clinical research, because some of it is not that, I would say, if you're actually presenting in an actual clinical presentation, you might not fall into the category because there are a few components that are missing. But otherwise, it's a first step. You did great. You did a good job. We've identified those who are really, really good that actually managed to actually fill in the categories in which that actually shows it is actually a real research. Okay, for that, I would like to congratulate all the 8 students and to the winners as well.
Thank you, Dr. Marina. Okay, before we announce the winners, I have a few housekeeping notes. When your name is called, please come forward to receive your prize, and please remain here forward for a group photograph. After the group photograph, for each categories, okay, winners, please proceed to that side of the hall to prepare for the final group photo at the end of the ceremony, which will be assisted by Puan Rohiraja. Okay. Ding. The stressed faces right there standing. Okay. Now, without further ado, let's announce the winners for each category. We will start with the students first. Yeah. Okay. So there are prizes to be won and quite handsome amount. We go from the lowest to the highest. Okay. So we begin with the student category best case report presentation. Wait, we welcome Prof. Vishna Devi to come forward again. And Dr. Hairia Abbas, my deputy head CRC from Hospital Makassar Tanah Fatimah Mua, to present prizes to the winners. Okay. For case report category for students, best presentations who will be awarded 150 ringgit. The winner is Mr. Karim Aiman Ghazi Khalid with the title Bilateral Congenital Femoral Deficiency Suggestive of an Underlying ASCO2 Spectrum Disorder, a Diagnostic Challenge. Please come forward. Congratulations. Okay. Student category for original poster presentation. We start with the third place. Who will receive 200 ringgit goes to Miss P. Sing Yi, investigating the relationship between food glycemic index and insulinic index in diabetic patients, a comparative analysis. Congratulations. Okay, got two more, two more. Second place. Who will bring home 400 ringgit? Wow. Goes to Mr. Abdurrahman Ganaim, deep analysis of motor unit and calculation activity using motor unit MRI, also from UMed. Congratulations. I'm so sorry. Winners. Ada glitch. Okay. Okay. Tadi, alamak.
Tak apa.
Anyway, you won already.
If it can happen in Miss Universe, it can happen here.
Okay. Tadi, the best case report is, Sherry, please correct me. Best case report student. Okay, betul. Best case report tadi betul, 150 ringgit. Okay, for student category, yalah, student tak boleh banyak-banyak duit. Okay, the third prize was 150 ringgit, betul kan? Betul. And then, second place, okay lah, half of it, 200 ringgit. Okay lah, can jolly after this. Okay. First prize will get, higher, 250 ringgit. Goes to Mr. Lion Cheer, drug with eosinophilian systemic symptoms, fatality rate and gender characteristics from Monash University. Well done. Whoa, jolly. Okay, students, please come forward for, come forward. We take photos first. Sabar. Come here. Don't run away. Okay, we take group photos first for the students category. Thank you, Prof.
For all the winners, if you look into your envelope, I would like to ask you to fill up your details, including your name and bank number, and pass them back to me before you go back so then you can receive your money.
If you don't fill it up, don't blame us if you don't get your money, yeah? Okay. Now let's move on to the professional category. I would like to welcome Dr. Marina and to come forward to present the prizes to the winners. Starting with the best case report presentation. Okay, this time I get it right. The winner will receive 300 ringgit. Okay, mana tadi? The 8. The winner is Puan Fatima Amira binti Zakaria from Hospital Pakar Ketangan Fatima Mua with the title Case Report of our Feed Management, Roma Biscuit Boy and his food play sessions. Congratulations. Puan Fatima, can you come forward? Okay. And please stand by the side for a while. Dia dapat duit, dia terus mau lari. Okay, for poster for the original research category. Third place, awarded 200 ringgit, goes to Dr. Nur Fatina binti Abdul Halim, Pejabat Kegiatan Daerah Mua, with the title The Effectiveness of Teledentistry as Adjunct to Non-Surgical Periodontal Therapy on Periodontal Health and HbA1c among uncontrolled diabetic patients at KK Bakri. Congratulations. Okay. Second place get 400 ringgit. Goes to tak salah. Dr. Suzanne Chin Chiung from KK Mahan. Please come forward. All right, Mua 1, 2, yeah. Okay, the winner for original research poster category will receive 600 ringgit. Oh, it gets higher and higher. The winner is Ms. Ong Bian from Hospital Newcastle, maximizing vancomycin efficacy through optimal dosing strategy. Congratulations. Okay, come to the center, please. All the 4 winners with Dr. Marina. Dr. Marina. I miss her. Come, photo. All the presenters are actually winners. It's just a matter that they bring home money or not. Okay, so now we will announce the winners for oral presentation category. Yep. The money is bigger because the stress is bigger. Today we witnessed remarkable presentations from our 6 finalists in Bailey's Lecture Theatre here. The judges' evaluations are final, and I'm honored to announce the top 3 winners. Announcing third place with an award of 500 ringgit. Sorry. Tiba-tiba something missing in the text. I don't have the presenter for the prize. I blame the one who wrote the text. Okay, I would like to call upon Dato. Please give us the honor to give away the prizes. Okay, back to third place, receiving 500 ringgit goes to Dr. Julia Ivy bin Zulkifli from KK Pan Raja PKD Batu Pahang. Prevalence of suspected OSA among diabetic patients in primary healthcare clinics. Congratulations, 500 ringgit. Okay. Okay, second place. How much do you think they get? Tadi 500. Huh? Jangan beritahu. AJK jangan beritahu. 700 ringgit. 700 ringgit. Betul. Okay, who's the winner? Dr. Fariha Bising Kal from Hospital Nursing. Title, 1 year experience of colorectal screening in this hospital. Are we there yet? Congratulations. Lastly. So how much this time? Huh? 1,000. Tak ada duit. Yeah. The winner will be awarded 900 ringgit. Dato', 900 Dato'. No. Who's the winner? The winner is there's a warming tree from Hospital Pananora Ismail with the title Geo Images Better Results, Deep Conclusional Neural Network with few short learning for malaria detection using full blood count differential scattergram images. Well done. Thank you, Dato'. Oh, Dato', photo. Ambil gambar dulu. Okay, all winners, all the winners study, so please come down. All 11 winners, please. Are you there still? All the 11 winners, please come forward for the final winners photo. Are you still there? Ke dah lari? Come. Come forward first, please. Ambil gambar. Sekejap. Wait, please, participant, please. Jangan. Participant, can you wait first? Can you wait, participant? We're not finished yet. Okay. Winner study, all 11, please. Okay, ambil group foto dulu. Hello, bye. Yeah, please give your details before you go. Yeah, to Dr. Karin. Please give your details to Dr. Karin, otherwise you won't get your money. Okay, congratulations to all. Let's give a big round of applause to all our winners and participants for their outstanding contribution. Your dedication to advancing healthcare through digitalization is truly inspiring. Okay. I also have to congratulate the AJK, the committee, for their effort in getting the cash for the winners. Hopefully, this is a motivation for next years to come, for them to produce more research and more presentations. Okay, before we conclude, let's have a look at the video montage of today's activity.
I'm a survivor. I'm not gonna give up. I'm not gonna stop. I'm gonna work harder. I'm a survivor. I'm not gonna give up. I'm not gonna stop. I'm gonna work harder.
Call upon Dr. Marina for her closing remarks.
Okay, I will try not to talk too much because I want to keep it short as much as possible so that all of you can actually go home after a full day. Thank you very much for coming to this. I would say is for the first time ever that we actually did this big Johor Research Day. Previously is on a smaller scale and usually done at a smaller scale as well. So this year we managed to get a lot more collaboration to be done. But our major collaborator this year is Newcastle Medicine and also Japan for helping us out. So I would like to thank everybody. And I would say that I hope today that we do get to kind of like new approaches, new innovation, new ideas, how AI or how digitalization might actually help us in making not just our life easier, helping our patient to make our actually in getting our work in research, in clinical work as well, to improve more and more, especially since there's a lot of, I would say, factors or a lot of reason or a lot of barriers that's currently is getting to cause a lot of problem in ways, either in manpowers, either in funding. So maybe having this kind of event, it'll give an ideas how to go way beyond that, thinking out of the box. So I would like to say thank you again for all the Urus Setia, all the committee, for all your hard work. And for the next chairperson, I would say all the best of luck, because you will be taking over for the next 2 years. But I would say if you want to have it this big as well, start it early, start it from this year itself, get all the major collaborators in, and maybe we have an even grander event for the next Johor Research Day that will be in 2026. Okay, I would like to say thank you again, and thank you for coming. Oh, all right. Before that, I'd just like Prof. Vishna to actually just give the last remark.
We will better cut the price for the students.